Good morning, good morning, and very happy Pongal, Makar Sankranti, happy Lori to all the JEE warriors who are preparing for the 2025 January attempt. I know it's a time where many of the families, your close ones will gather together to celebrate, but for the circumstances you are in, you have to utilize this particular holiday, by studying properly and making sure that you utilize every single minute. Yes, there will be a time where you will be celebrating these festivals next year in the IIT campus, in the NIT campus, in the BITS campus. And that is the time when you will feel very proud that you last year were very, very particular and focused on your JEE Mains January attempt. All right. So let's begin and let's start with the complete physics one shot marathon with the concept and the questions. Many of them will be PYQs or your most important models of question. So I'll be revising the concept, I'll be going through the concept, and then we will be doing the models of question based on that particular concept. Obviously, we will be taking up only the high weightage important concepts. There are many concepts throughout the 11th and 12th standard syllabus, so you can expect around close to 100 concepts that we'll be doing today in this particular session. It is going to be a long marathon. I'll be giving a break after some time, so be ready for it. Okay, so my name is Captain Shreyas, your physics master teacher, and I've been guiding, mentoring, teaching kids for more than 13 years now, and thousands of my students are right now in IITs, and many of them are also in NITs, BITS, and you name it. This year, obviously, it's your turn. I need to make sure that my kids in 2025 are cracking the JEE examination no matter what. And because you are attending this particular lecture, it's my responsibility to ensure I give you all those kind of questions which will come in the examination. So quickly smash this like button and subscribe to the #1 JEE English channel in the country. All right, so let's begin. Hi, Only JEE. Welcome, Vetrali. Hi, Keswan. Anay. Welcome, Anandu. Hi, Hitman, Kamen, Suba, Study, Vetrivel. Welcome, Harborine. Hi, Sarvesh. Hi, welcome, Paddu. Welcome, Nikhil. Nice to see you all. Hello, Arjun. Hello, Lord. Hello, Sigma Institute. Aishwarya. Nice to see you. Vanakkam. Endariki namaskaram. Yes, welcome aboard. Namaskar. All right, let's begin. First, let's start with the concept. We are going with the 11th standard chapters first, then we will go to the 12th standard chapters. That's how the flow will be. And we are going almost sequentially, right? From units, dimensions, kinematics, then your Newton's laws, work energy, center of mass. That's how the flow will be. Homogeneity principle, remember, is a principle which equates the dimensions on both sides. Now, you might be wondering what the hell is dimensions, or you might have forgotten. Let's revise that. And the concept of dimensions and dimension analysis is, first of all, in the homogeneity principle, and also to check the correctness of equation, and also to derive certain things. So let's understand one thing, that there is a clear-cut difference between units and dimensions. Units and dimensions. Like, say for example, if I take the quantity of let's say mass, if the physical quantity that I take is mass, then the unit of mass can be kg, can be gram, it can be, let's say, milligram, or it can be ton. Okay, all these things are nothing but the units, different manners in which you can measure the mass, but dimensionally mass is measured like this. It is written down in square brackets, and the dimensional formula is basically m. Similarly, you can talk about length. Length can be also measured in different ways, like feet, centimeter, kilometer, meter, etc. But dimensionally, it is having the formula L. Similarly, if I write speed or velocity, speed and velocity, I can measure it in kilometers per hour, centimeters per second, or basically miles per minute, or basically meters per second. But dimensionally, the formula will be, because kilometers, centimeters, they are all lengths, and below you have time, so it is L T raised to -1. L divided by T, which is negative power of T. So a quantity may have multiple units, but it will have an unique dimension. All right. Also, sometimes it can happen that two quantities have the same dimension, but they have different units. Example, if I tell you work and torque, work and torque, their dimensional formula is the same, which is m raised to 1, L raised to 2, and you have basically T raised to minus 2. So basically they have the same dimensions. They have the same dimensions, but you will notice that their units are different. Units are different. Units are going to be different. For work, it is measured in joules, and torque is measured in Newton meter. Okay, so sometimes some physical quantities may have same dimension, but their units could be, they are measured in different units altogether. Similarly, also keep in mind there are certain physical quantities which do not have dimensions, yet they have units. For example, if I give you angle, what's the dimensional formula for angle? It is basically dimensionless. It is basically dimensionless, but it has a unit. It can be measured in radian, or it can be measured in basically degree. There are some quantities which neither have units nor do they have dimensions. For example, like say refractive index or coefficient of friction, right? All these physical quantities, there is no unit. There is no unit for refractive index, nor do they have any dimensions. Is this now very clear? The difference between units and dimensions, never ever get confused. Yep, trigonometric functions, strain, correct, awesome. No, we are not doing derivations over here. Yep. So now that you understand this, you should also remember that whenever I put an equal to symbol over here, then whatever quantities are there on the left hand side and whatever quantities are there on the right hand side, dimensionally they should be equal. So whatever I write over here and whatever I write over here, dimensional formula should be the same. Even if I add something or even if I subtract something, their dimensions must be same. Must be same during during what? Addition and subtraction. When you do multiplication or division, all right, is equal to some dimension, or let's say this thing divided by this thing is equal to this, then in these cases the dimensions of each quantity may be different, that is perfectly okay. Like for example, this is m raised to 1 L, and this is L raised to 1 into T raised to minus 1. So dimensionally m will be coming over here. Check this out, what will happen over here. This will be nothing but m raised to 1. L into L will become L square. T raised to minus 1 will come over here as it is. Each of the quantities can have different dimensions, no harm in that. If this is m raised to 1 and this is, let's say, T raised to 1, this can be then, probably m raised to 1, T raised to minus 1. So multiplication division is done normally, like the normal rules of multiplication division. Each quantity can be different dimensionally. Only while addition and subtraction, the dimensions should be equal. That is basically your principle of homogeneity. Also, every term in the physical quantity must have the same dimension, which we already discussed. This is also used to check if an equation is correct or to derive unknown relation. Remember one thing, that if by chance it happens the dimensions on this side is not equal to the dimensions on this side, then dimensionally it is not correct. Dimensionally it is not correct, and physics wise also it is going to be not correct. Physics wise also it is not going to be correct. Okay, 100%. If the dimensions don't match, you can eliminate such options. What you can do, this can be used to eliminate certain options in certain cases. that especially in your objective examination. Now, this principle can also be used to derive certain relationships. Say, for example, I know that, say for example, some physical quantity depends on physical quantity 1, physical quantity 2, physical quantity 3. Okay. Then I don't know how is it exactly related. So you will start by assuming, okay, this physical quantity is some constant into P1 raised to X, P2 raised to Y, and some physical quantity raised to Z. If more quantities are there, more variables can be assumed accordingly. Then you will say, okay, so that's why dimensions of P constant is always, this is going to be a dimensionless quantity. Okay, so then this will be basically P1's dimension raised to X, P2's dimension raised to Y, and P3's dimension raised to Z. So solving this, you will get the value of X, Y, and Z by comparison, by comparing the left hand side with the RHS, right hand side. You will see what is the dimensions here of mass and what is the dimension here for mass, for length, for time, etc. And comparing them, you will be able to derive the formula for that particular relationship. Yep, I hope this is clear. Yes, awesome. So let's basically do some questions on this. Here is the first question. Test if this particular formula is it dimensionally correct. Like it can come as a statement based question. Maybe it is statement 1, or it can be like an option. It is not correct mathematically, but physics wise it is correct, or it is it is not correct at all, or it is correct mathematically and physically also. So all such options can come. So let's see whether it is correct or wrong. Dimensional formula, is this correct or wrong? Come on, my dear students. Now, first of all, if you check the left-hand side, which is basically T, the dimension of it is nothing but just time. So time raised to 1. Similarly, if you check the dimensional formula of the right-hand side, which is basically 2 pi root of mass divided by force by x. Well, dimensionally, this will be dimensions of 2 pi, into dimensions of mass raised to half upon the dimension of force raised to half, and x is going to go on the top. So x is the dimension raised to half. Technically speaking, 2 pi is the dimensionless, mass is m raised to 1, so raised to half, x is basically length, so length raised to 1, whole thing raised to half. Force has a dimension of m raised to 1, L raised to 1, T raised to minus 2, the whole thing raised to half. Everything is raised to half, cancels, L will cancel. So the only thing remaining, by the way, this is dimensionless, so don't worry about it. This goes on the top, it will become T raised to 2, the whole thing raised to half, which is basically T, which is the same as the dimensions on the left hand side. So hence, as you can see, this right hand side and left hand side dimensions are equal. Hence, dimensionally it is correct. Dimensionally it is definitely correct, nothing wrong. If you check formula wise also, there is nothing wrong. You will see 2 pi root of m by force is nothing but kx. Spring force is nothing but kx divided by x. Xx cancels, so this will become 2 pi under root m by k, which is actually the time period, of oscillation. So yes, formula wise also it is correct. There is nothing wrong in it. Formula wise also there is nothing wrong. Happy Pongal to you. Hi Jeffrey. Yep. All right. Exactly, Bharat. That's what we are doing. We are doing the concept, then the PYQs. Concept, PYQs. That's what we are doing. All right. Next question on your screen. It says that the speed of a wave is produced in water, which is given by velocity is some lambda. Lambda and rho are the wavelength and the acceleration due to gravity. And this is nothing but the density of that liquid. What is the value of A, B, C respectively in this particular equation? Okay. The duration of this live might be 4 to 6 hours, anywhere in between that or even more. I don't know. We're just going with the flow. So keep a mindset of 5 hours to 6 hours or 4 hours. So that way you are mentally prepared. Okay. Now, first of all, on the left hand side, you just have velocity. On the right hand side, you have basically lambda, so lambda raised to a, and then gravitational acceleration raised to b, and then density raised to c. Dimensionally, both of them should be equal. What is the dimensional formula for velocity? Because it is meters per second, so it will be length per unit time. L1 t raised to minus 1. Wavelength, it is length, so L raised to 1 raised to a. Acceleration due to gravity, meters, that means length, per second square, that means t raised to minus 2 raised to b. Density, mass per volume, mass is m raised to 1, volume is L cube, but below, so L cube will be minus 3. L cube will be minus 3. Okay, so that is what it is. Now solve the right hand side properly. So you have L raised to a, L raised to b, and L raised to minus 3c. Then mass wise you have m raised to just c, and time wise you just have t raised to minus 2b. Is that right? Length is there, mass is taken care of, time is only there over here, and on the left hand side L raised to 1. In fact, mass is not there only, if you notice. So it is technically m raised to 0, L raised to 1, t raised to minus 1. Now start comparing. Start comparing. Masses power on the left hand side is 0. Here the masses power is c. So basically c is 0. One thing done. Next, check for length or check for maybe time. So time power is negative 1. Here the power is basically negative 2b. So minus minus cancels. So 2b is equal to 1. Therefore b is basically half. Lastly, check the power for length on both sides. Left hand side it is 1. Right hand side it is a plus b minus 3c. Okay, a I think I have to find out. B value is nothing but half. C value was nothing but 0. Okay, so therefore a will be 1 minus half, which is basically again half. So a will be half, b will be half, c will be 0, which is option number C, which is nothing but option number C. Got it, my dear warriors? Everybody with me? That is how you solve these dimensional based questions. Have you now got confidence? Everyone with me? Yep. Uh, Gamer creator, most of the chapters are going to be covered, but in those chapters only those important concepts. Like if a chapter has let's say chapter number X has, let's say, 7 concepts, but every year we see that for sure these 2 concepts will come, then those 2 concepts I will be doing over here, because we are concentrating on marks now, not concentrating on covering the syllabus. The concentration is on marks. What if I tell you I will give you marks? I am not interested in just covering the syllabus for the sake of it, because then you are unnecessarily doing something which is not required. Do what is required. What is required? Marks. If I tell you I'll give you marks or I will give you full syllabus, what do you want? But if you do full syllabus, you might take a lot of time, you might not be able to complete it, you might not do it completely properly, and your marks might be maybe 60 or 70 percentile. But if I tell you, no, I'll give you 99 percentile, maybe complete syllabus not done, some chapters or some topics are left out, you will get 95, 98, 99 percentile. Obviously, you will choose that option where you get more marks, right? Correct. Awesome. Right, let's move on. Let's move on to the next concept of screw gauge, and basically that concept of least count and how do you measure those things in screw gauge. Now screw gauge is, remember, a device where you rotate the screw till it touches and it gets a click sound, and you stop there and you make those readings based on the markings on the screw, and you measure the length of the device, usually used to measure the diameter of a ball or the width of something or the sheet thickness, stuff like that. It has a very good accuracy, generally better than the vernier caliper. So a screw gauge will have a rotating screw, it will have a circular scale, so there is always a circular scale which has some markings, so that is why it has circular scale reading, and as that screw rotates, that circular scale will allow that big rod inside of it to move. That rod will have some markings, and that is the main scale which goes left, right. The circular scale will go round and round, circular scale reading it will have. The rod will move back and forth till it touches the object. that has the main scale. The rod will not rotate, it will just move back and forth. Okay, that's like the screw. All right, so that has the main scale over it. Now there is something called as the pitch of a screw gauge. Pitch is nothing but how much does it move per rotation. So when I rotate it once, how much does that rod move back and forth is called as the pitch. So for one rotation, if it moves 0.5 millimeters, then the pitch is 0.5 millimeters. If I rotate it 10 times, then it moves by 2 millimeters. So for 10 rotations, it moves by 2 millimeters. So per rotation, it will move by 2 divided by 10, which is 0.2 millimeters. So then the pitch is 0.2 millimeters. Per rotation, how much does it move is called as the pitch. Distance moved upon the number of rotations. That's how it works. This pitch is important for the calculation of something called as the least count. Now, least count is basically the smallest measurement that you can make by any particular device. Normally, your watch that you wear has a least count of 1 second. Usually, the the weighing machines that are there around you, usually they have a least count of 1 gram. Then, if you talk about a normal scale, it has a least count of 1 millimeter. A screw gauge usually, a standard screw gauge usually has a least count of 0.01 millimeters. Yes, 0.01 millimeters. Remember, 1 millimeter for a meter scale, 0.01 for a screw gauge. 0.1 is for a vernier caliper. So meter scale is not that great. Vernier caliper is slightly better. Screw gauge is the best because very small error in it, because the least count is 0.01 millimeters. That's very, very small. So what is the least count? The least count is whatever pitch you find divided by, remember that circular scale? The circular scale will have some markings. So number of markings on the circular scale, you just divide the pitch with it. So if it had 100 divisions, divide the pitch with 100, that is the least count of the circular scale. So say for example, the distance moved by it was 2 millimeters for, let's say, 10 rotations, then the pitch will be 2 divided by 10, which is 0.2 millimeters. Let's say now once I got the pitch as 0.2 millimeters, let's say the number of divisions on the circular scale were example 20. There were 20 lines on that circular scale. So 0.2 divided by 20, 2 cancels. So it will be 0.1 divided by 10, which is nothing but 0.01 millimeter. So the least count of that screw gauge will be 0.01 millimeter. Is that okay? How you do these calculations? Everybody with me? Yes. Awesome. Now, uh, yes, we are doing as many things as possible, Deepu, don't worry. And I will want to keep it as one shot, because then if I do it in 2-3 lectures, third lecture, nobody comes. Yeah, they're like, oh sir, I will first have to complete first lecture. I will do it concisely and I will do all the important things. Don't worry, this is a complete physics marathon. Now, once you get the least count, the final answer that you get, the reading that you get, is given by, the total reading is given by this formula. The first thing in it is in the MSR. MSR is the main scale reading. Remember that rod which moves back and forth? On that scale, what is that reading that you get? Which line are you just able to see? That is your main scale reading, plus least count, which we just figured out over here. That same least count you put over here, multiplied by the circular scale reading. Remember, on that circle, when you rotate and you stop, because the rod is just touching the object, on the circle, whatever reading you get, that becomes the circular scale reading. So circular scale reading into the least count plus the main scale, the rod which moves, that is your total reading of the micrometer screw gauge. By the way, the formula for vernier caliper is also very similar. Instead of circular scale reading, you multiply the least count with vernier scale reading. And here you still have main scale reading. That's all. It's the same thing. It's not very different that you get. And instead of actually least count, you have basically something called as a vernier scale. Sorry, least count is there. Instead of circular scale, that vernier scale reading which you get is actually the digit of coincidence. Which vernier scale reading coincides, that's what you multiply it with. Okay. Now, sometimes these machines, these instruments have a zero error in it. Meaning, when no object is placed, still it is showing some reading. Now, there are two kinds of errors that you can get. One is a positive error and one is a negative error. Positive error is when nothing is kept. Imagine you have a weighing machine and nothing is kept, still it is showing 10 grams. So when you actually put something and it shows 60 grams, so you will think, oh, when nothing was there, still it was showing 10. Now it is showing 60. So 60 is not the correct mass. So I have to take out 10 grams. So when it is already showing plus 10 grams, it's a positive error. And a positive error always has to be subtracted because it is showing an excess value. It is not correct. So you subtract it. That is what you do for a positive error. When there is a negative error, meaning when there is nothing kept on the pan, it is showing minus 10 grams. When you keep an object, it shows 60 grams. You will think if it was showing minus 10 when nothing was kept, then it reaches 0, then it climbs to 60. That means the actual mass will be 10 plus 60. Oh, so when there is a negative error, you add that negative error. Got it? So negative error means it is showing less. So you have to compensate it by adding it. Is that right? Okay, so the corrected reading will be the total reading minus or plus that zero error. That's all. All right. Now let's do a question based on this. There is a screw gauge. Read the question properly now. Read the question properly. Everyone, come on, my dear students. Read the question. What is the question? The screw gauge has 100 divisions on the circular scale. Main scale moves by 0.5 millimeters on one rotation. The zero of the scale lies between 6 divisions below the line of the graduation when the two studs are brought in contact. When you place some object, 4 linear scale divisions are visible. Will the 46 division on the scale is coinciding? So the diameter of the wire is. Okay, first go by basics, guys. First go by basics. What is given over here? First, let's do the calculations for the pitch. All right. It moves by 0.5 millimeters on one complete rotation. That means basically the pitch is 0.5 millimeters. What is the least count? I had told you it is nothing but the pitch divided by circular scale divisions, which means it is 0.5 millimeters upon how many divisions are there? It is 100. So 100 divisions. So therefore the least count will be nothing but 0.005 millimeters. Is that right? 0.005. There are 100 divisions on the circular scale and the main scale moves by 0.5 millimeters on one complete rotation. Is that right? Everyone with me on this? Perfect. Yep. All right. Welcome, Alvin. Yes. Came cho Majama. Thank you, Lisa. All right. Yes, the PDF will be uploaded BSO4 after a day. Yeah, today it might not be possible. Okay, tomorrow, because today everybody is on leave. Only Shreyas sir is working. All the YouTube teachers are working out here. Okay, just for you. Next thing is basically, I think the zero error. Zero error is also there. If you noticed, there is something like zero error here. The zero of the circular scale lies 6 divisions below the graduation when the studs are brought together. Studs are brought together, contact with each other means there is nothing else kept in between. The rod is just touching that part, the stud of that screw gauge. So it is still showing some reading. So therefore there is some zero error over here. Now when you look at that zero error, you should realize that the circular scale, if this is what it is, and this is your main scale, it is mentioned that the zero of the circular scale lies 6 divisions below. The zero of the circular scale lies 6 divisions below over here. So that means this number is basically 6. So it is already showing 6 as the reading. So it is definitely a positive error. It is definitely a positive error because the 0 is below, 6 will be here. So I have to subtract the answer later on. So what is that zero error? It will be main scale reading plus the least count multiplied by the circular scale reading. The zero reading on the main scale is 0 plus least count is nothing but 0.05. And what is the circular scale reading? It is basically 6. So this is going to be, oh sorry, this was 0.05, my bad, 0.05 into 6. 0.05 into 6, 005 into 6, 5 6 are 30, guys. So this will be nothing but 0.03 millimeters. 0.03 millimeters. Everybody with me? Got it? Very good. Yeah. Sir, how the session would be? Nitya, the session has already started. You can already experience it. All right. Next important thing is basically the reading that you get when you place with the object. When you place it with the object. So let's read this properly. Main scale reading plus least count multiplied by circular scale reading. Okay, read it properly. When a wire is placed, four linear scale divisions are visible. So four linear scale divisions are visible means linear scale means line. Line means that rod, the main scale. So main scale reading is basically 4 plus. Okay. Now there is a catch over here. There is a catch over here. When if you see the question, lot of you might think the main scale reading is 4, but actually that catch is if you complete a rotation, then the circular scale moves by 0.5 millimeters. So that means each marking on that rod, on that main scale is 0.5 millimeters apart. Got it? I hope this is clear. When you rotate it once, it is moving by zero point 0.5. That means it moves from one marking to the next marking. Again, one rotation, 100 divisions moves to the next marking, That means when the main scale reading is 4, remember, or rather I will say one division will be zero point 0.5 millimeters. One division will be 0.5 millimeters. So four divisions will be how many millimeters? Think about it. Four divisions will be 2 millimeters. So the main scale value will be basically 2 millimeters. Is this clear? Lot of students usually make a silly mistake over here. Okay. Now, the next important thing is the least count. What is the least count? We just got it to be 0.005 millimeters multiplied by circular scale reading. Circular scale reading was the 46th division on the circular scale. So, into basically 46. Is this absolutely clear, my dear students? Circular scale reading was already given to you. So, now just multiply this. How much will it be? 46 into 0.005, basically 46 into half 23. So guys, 0.23, everyone, 0.23. So this will be nothing but 2 plus 0.23 millimeters, which is nothing but 2.23 millimeters. But that should not be your final answer. Remember that our final answer will be 2.23 millimeters. There is a positive zero error of how many millimeters? 0.03 millimeters. So I have to subtract it. So hence it will be 2.20 millimeters. Is this understood, my dear warriors? Is this understood? Yep. Okay. So in this question, I will tell you what exactly happens. See, the circular scale, right? That circular scale. The total number of divisions, there were 100 divisions. You rotate it once. If you rotate it once, what is happening? That circular scale is moving by one division. It is moving by one division from on that main scale. The circular scale is moving how many millimeters? It moved 0.5 millimeters. It is clearly mentioned 0.5 millimeters. So basically it has moved from one division to the next division, and each division is basically 0.5 millimeters on the main scale. On the main scale. So you rotate it once, 100 divisions were there on the circular scale, it moves by 0.5 millimeters. So one division on the main scale is 0.5 millimeters. Is this clear? Okay. So if I take 1, 2, 3, 4, 4 divisions, how much will be the length? If I take 4 divisions, how much will be that length? That length will be 2 millimeters. So 4 divisions will be 2 millimeters. That's why when the linear scale, that means on the main scale, if it shows fourth division, that means it is actually speaking 2 millimeters. Understood? Yes. Is that absolutely clear, Tamil? Yes, everyone? Yeah. Okay. This part is clear why the main scale reading is 2 millimeters. How did I find that zero error? I will say this again. See, this circular scale which was there, it is clearly mentioned in the question that the zero of the scale is 6 divisions below the line of graduation when the studs are brought together. That means when both the things are touching, nothing is in between, the zero of the circular scale is below the line of graduation, means the main scale. So if this is the main scale, this is the main scale, it is 6 divisions below. It is 6 divisions below. That means this is the number 6. This is the number 6. So ideally this 0 should have been here, but actually it is showing already some number. That means if it is already showing some number, that means it is a positive error. How can it show some positive number? That means, it is not correct. It has some zero error and it is a positive error. Understood why it is a positive error now? Why it is a positive error now? It is clearly mentioned. It is basically 6 divisions below the line of graduation. I hope this is clear. Understood now? Clear? Give me a thumbs up if you guys got it. Give me a thumbs up if you guys got it. Awesome. Awesome. Yeah. Yes. Once I get it is 6 millimeter, whatever, 6 divisions. So once I know it is this number 6 will be the circular scale reading, and probably the zero of the main scale will be here. So therefore, I will get my zero error from this particular formula. Main scale reading is 0 plus circular scale reading is 6, least count is 0.05. Understood? That's how I get my zero error. Is this clear now? Everybody with me on this? This concept also clear? This kind of confusion usually they do specifically when the pitch is 0.5 millimeters. Specifically when the pitch is 0.5 millimeters. Okay. What's the difference between pitch and least count? Pitch is basically when you rotate it once, how much does it move? But least count is even smaller than the pitch, because when you rotate it once, there were so many lines on the circular scale. So when you're rotating, you do one tick or you rotate it by one division on the circular scale. Then that linear scale, that rod will move by a small amount, that becomes the least count. So when you just do one tick on that circular scale, the amount that it moves back or forth is the least count. But when you rotate it one complete rotation, how much it moves is basically the pitch. That's the difference. Got it? Yeah. Yeah. Yes. Awesome. Okay. Okay. Samhita, let me tell you, there is a deliberate reason why I did not attach a picture. Reason being, in the actual exam, no picture will be there. Number one. Number two, you have to, make a rough diagram to understand it. You cannot sit and draw a fair diagram. If I sit and draw a fair diagram, that's it. Time is gone. So that's the reason why we have to sit with the rough diagrams to get the idea, get the concept. That's enough. Okay. All right. Let me do another question and tell you. Okay. By the way, for this, the answer was, I think, 2. Yes, this is the correct answer. Let's say, my dear students, let's say another question. Let's try to do this. Let's say if I tell you the circular scale divisions are, let's say, 40. Let's say the pitch, is, let's say, 2 millimeters. Okay. Then can you just figure out what is the least count for this particular screw gauge quickly? Come on, everybody put it up in the chat box. Everybody put it up in the chat box. Let's build this question. Circular scale divisions are 40, pitch is 2 millimeters. Can you quickly find out the least count? Okay, so the least count will be nothing but the pitch, which is 2 millimeters, the whole thing divided by 40 divisions. So that's it. 2 by 40 is nothing but 1 by 20 of a millimeter. 1 by 20 of a millimeter, which is nothing but 0.05 millimeters. So understand the difference. When you have that circular scale, you rotate it once, it will exactly move. It will move how many millimeters? 2 millimeters. It will move 2 millimeters from one division to the next division. That is what it means. It will basically move 2 millimeters. Understood how to calculate the least count? Perfect. Okay, now let's say I already tell you, let's say the least count is basically 0.05 millimeters. This is another fresh example. Let's say the least count is 0.05 millimeters. Example. And I tell you, one division of that main scale example, each division is, let's say, 1 millimeter, 1 millimeter, or let's say I give you, it is nothing but point okay, let's take it as 1 millimeter, no problem. Let's say it is 1 millimeter. All right, each division on the main scale is exam 1 millimeter. Now I tell you the main scale reading is, let's say, 3, and I tell you the circular scale reading is, let's say, for example, 20. Can you tell me what is the reading then? Can you tell me the reading of that particular screw gauge? Can you tell me what is the reading then shown by the screw gauge? Let's do this question, guys. So what is the formula? The formula is main scale reading plus the least count multiplied by the circular scale reading. What is the main scale reading? Main scale reading is basically 3. Okay, so 3 millimeters. Each division is 1 millimeter, so third division will be 3 millimeters. Perfect with that. Got it till this point? Okay, least count. What is the least count? It is given to be 0.05 millimeters. What is the circular scale reading? It is basically 20. So this will be nothing but 3 plus 0.05 into 20. 10 goes with one decimal. So 0.5 into 2, which is just going to be 1. So it will be basically 4 millimeters. It will be basically just 4 millimeters. Everybody with me? Understood how the answer has to be found? Awesome. Perfect. This is how you need to do it. Let's say now it was given that there is a zero error. Let's say there is a zero error of given to be zero point 0.3 millimeters negative. Zero error of 0.3 millimeters negative. What will you do? So what will our final answer be? What will our final answer be? Think about it carefully. The reading that we got was 4, but there is a negative error of 0.3. So our final answer, will it be 4 millimeters plus 0.3 millimeters or minus 0.3 millimeters? If there is a negative error, you add it. If there is a negative error, you basically add that amount of negative error. So the answer will be 4.3 millimeters. That is your answer. Got it? How these questions have to be solved? It will be given in a text form. You convert it into this form. What is main scale reading, circular scale reading, what is zero error, what is the least count, what is the pitch, what is the number of divisions. If you do it like this, you will definitely get the answer. Got it, everyone? Awesome. Awesome. Let's proceed with the next concept of error combination. Now, every measurement that you make has some error. So let's say there is a physical quantity. Let's say there is a physical quantity, and that physical quantity is measured to be, the value is m plus or minus delta m. This m is your most probable value. This is your most probable measured value. This is basically your absolute error. This is your absolute error. And then delta m by m is then called as the relative error. And then you also have delta m by m multiplied by 100, which is then called as the percentage error of that particular reading. So say for example, I tell you the time that you have measured is 20 plus or minus 1 second. So the absolute error in the measurement is 1 second. The relative error in the measurement is 1 divided by 20, which is nothing but 0.05. If you ask me the percentage error in this, then that will be 1 by 20 multiplied by 100, which is basically 5%. So there is a 5% error margin over here. I hope this is clear. Everyone? Awesome. Till this point, absolutely clear. Okay. Now, there are different ways in which you can combine these errors. There are different ways by which you can combine these errors. So let's see what are those error combinations possible. Say for example, you have length of a rod number 1 given to be 2 plus or minus, or let's say 20 plus or minus 3 meters or whatever. Another rod is there whose length is, let's say, 40 plus or minus let's say 2 meters. So if somebody asks you, you are joining these rods together, so that means the length will also be added. So what is the total length? What is the total length? Then what you do is you add the most probable values. So 20 plus 40 is going to be 60 plus or minus 60 plus or minus. These things also should be added. So it will become 5. So whenever you do addition, you just add the most probable values and also the absolute errors. Now, let's say there is another example where you had certain mass given to be, let's say, 50 plus or minus, let's say 4, and there is another mass which is taken out from it, which is, let's say, 10 plus or minus 2. Now you are taking out something. In this case, you are taking out something. So from mass 1 you are taking out mass number 2. So what is the mass which basically remains? This is basically subtraction of error. How much mass is remaining? Just subtract the most probable value. 50 minus 10 is 40, but never subtract this, always add it. So 4 plus 2 is going to be 6. So whether you do addition or subtraction, always remember this: for addition and subtraction, the absolute errors are always added, are always added are always going to be added. Keep this in mind, okay? 3 plus 2, 4 plus 2, always. But this value or this values will always be added or subtracted depending on the sign over here. Cool? All right. Next important thing is multiplication, division, etc. How do you tackle this? For tackling this multiplication, division, and any such thing, remember, always write the formula in the power form. What do I mean by that? For example, kinetic energy. Kinetic energy is half mv square, we know that. So write it in the power form. That means kinetic energy will be half mass raised to 1 v raised to 2. Express everything in powers in the numerator. Another example, let's say, alright, the speed of a wave is root of Young's modulus by density. Therefore, v will be Young's modulus power is half. Density's power on the top, if I write it, it is negative half. Similarly, some other question, let's say, see here things were multiplied, here things were divided. Let's say you take another example, maybe of, some random physical quantity. It is dependent on some constant, or let's say we take the force only, electrostatic force, Coulomb's constant, charge 1, charge 2 divided by r square. So write it in the power form: Coulomb's constant, q1 raised to 1, q2 raised to 1, and r raised to minus 2. That is how you will first write it. Once you write it in that power form, then what you do is to find the error in this quantity, because this quantity and this quantity has error, or there is some margin, there is some problem here, that is why this quantity has some error. What you do is first write down the relative errors of everything. What will you do? First write down the relative errors of everything. That means write delta k by k, then write delta m by m, then write delta v by v. Okay, here equal to is there, put equal to. If there is a constant, forget it. Constants should not be worried about. Just take the powers. What is the power of mass? 1. Multiply with it. Just take the powers and multiply with it. What is the power of velocity? It is 2. So 2 into. Just add it. This is the formula. So if there is some error here and there is some error here, this much error will be there here relatively. So the relative errors are calculated, not the absolute errors. In addition, subtraction, you deal with absolute errors. But in multiplication, division, and any other powers, you tackle with relative errors. So for example, if this had say 0.5% error, and let's say this had 2% error, then 2 into 0.5 plus 2%, which is nothing but 1 plus 2. So this will have 3% error. So the kinetic energy percentage error will be 3% if velocity and mass had 0.5 and 2% errors. Is this clear? Similarly, over here, what you do, first write down all the relative errors, velocities relative error, Young's modulus relative error, and obviously the relative error of density. Obviously the relative error of density. Now put that equal to sign. What is the power of Young's modulus? Half. What is the power of density? It is negative half. So will you put negative half? No, don't put. Always put the mod value. Never ever put negative values. Always choose the positive values. Okay, so that's how you do it. Similarly, over here, the relative error in force will be, it is a constant, so ignore it. Power of the charge is 1, so 1 into delta q1 by q1. Power of this charge is also 1, so delta q2 by q2. Power of r is 2, negative 2, but always take mod value, so 2 times delta r by r. So that's how you combine errors for multiplication, division, roots, or any such quantity. Got it? Yep. Everyone? Everybody with me? Yes. Now, please remember one more thing, that whatever formulas I have given over here, please take a note. This is only for small relative errors. Small relative errors, typically less than 10%. Like this is 2%, 5%, 6%, 0.5%, 0.9%, 3%, 4.2%. Then you can use this. If it is not, then you have no other option but to calculate both the values and then do it. Say for example, I tell you, say the kinetic energy formula we know is half mv square, and I tell you that listen, the velocity is changed, velocity is changed by example, let's say 20%. Then what is the kinetic energy changed by? Then what is the change in that particular kinetic energy? You have no other option but to sit and calculate this. How to sit and calculate? I'll tell you. If you talk about the initial conditions, the kinetic energy was K, the mass was M, velocity was V. This is the formula. If you talk about the final values, the velocity has been changed by 20%. Let's say it was increased. Let's say it was increased by 20%. So final velocity, the final velocity will be the old value of the velocity plus that change which you did. The old value was V, the change was 20%. So what is 20% of velocity? 20% means 20 by 100 into V, which is 1/5, 1 by 5, right? This is V by 5. So this will be nothing but 6V by 5. Is that right? Final velocity will be 6 times V by 5. Now what you do, find the final kinetic energy, which is half m V final square, which is half m. Final velocity is 6V by 5. So 6 square V square by 5 square, which is nothing but 36 by 25 times half mv square, which is now the new kinetic energy. So now in order to find the percentage change in the kinetic energy, you find the new kinetic energy, subtract it with the old kinetic energy, divide it with the old kinetic energy, and then multiply by 100. That is what is going to give me the answer. So the new kinetic energy was nothing but 36 by 25 times half mv square. Is that right? 36 by 25 times half mv square minus what was the old kinetic energy? It was half mv square divided by half mv square, and then you just multiply this with 100. Half mv square will cancel, and you will get 36 by 25 minus 1. 36 by 25 minus 1, the whole thing into 100, which is 36 minus 25 into 100, this thing divided by 25. 36 minus 25, that's 11, into 25 and 100 goes 4 times, so that is basically 44%. That is the answer. Got it, everyone? No, it is not 36%, it is going to be 44%. So when the errors are huge, you have to go with that. Only for small relative errors, you can use these formulas. Okay. So let's do a question basically. If length is this much, breadth is this much, what is L plus B? What is basically L plus B? Come on, very, very straightforward question. Okay, so how do we do this? Start by putting 2.331 and put plus and put 2.1 over here. There is nothing over here. Add both of them, see what do you get. This will be 1, this will be 3, this will be 4, and 2 plus 2 is basically 4. 4.431. It is there over here, but will you mark it? Definitely not. You will be like, sir, such a laddu question. JEE will ask. Yes, and many people will mark A. This is not correct. Be careful. See, whenever you add something or subtract something, always check how many decimal places are there. Here, there are 3 decimal places. Here, there is 1 decimal place. But our final answer is getting 3 decimal places, which is wrong. The final answer should have 1 decimal place because this is the least of the all, always the least. So then you have no other option but to round it off. Yes, you will be rounding it off, round it off to 1 decimal place, which is the least decimal places. What will it be? Check. You have to get rid of this number 31. You have to get rid of this number 31. Yes, you have to get rid of this number 31. This number 31 you have to get rid of. So when you write it down, what will happen? This will just become 4.4. This will just become 4.4. Yes, that is the rule when you add and subtract. So in fact, I can put it up here only. Also the final answer. Also, I'll put over here the final answer. Also, when you add and subtract, the final answer should have the least of decimal places, not significant figures, decimal places. Always the final answer should have least of the decimal places. Here there were no decimal places, so no need to break your head. But if there were decimal points, always least decimal value, either addition or subtraction. Either addition or subtraction doesn't matter, always least of the decimal place. You will be wondering, sir, how did I get rid of 31 like this? Sir, if it was 71, will I still get rid of it? No. See, there are 2 digits, right? 2 digits. Think in multiples of 5. 5, 50, 500, 5,000, 50,000, 5 lakh, like that. So 2-digit 5 number of power of 10, that is basically 50. If you compare the number 31 with 50, it is less than 50. So if it is less than the number 50, this is also 2-digit, this is also 2-digit, then you just write it down as it is. The previous digit, write it down as it is. So hence 4.4 will be the correct answer for this. 4.4. You might think, sir, what if it was something else? Okay, let's say it was 4.471 and I want to get rid of these 2 numbers. I want to get rid of these 2 numbers. No worries. Compare it with the number 50. You can see it is more than 50. The number 71 is more than 50. So what you will do is when you are rounding it off, you will add 1 to the previous digit and this will become then 4.5. Because 471 you can see is close to 4.500. 500 is close to 471. So I did not want this. So it is basically going to be 4.5. Got it? Similarly, imagine if it was 4.4500. Sorry, 4.450. And now I want to get rid of these 2 digits. Okay, compare it. It is exactly equal to 50. Oh, if it is exactly equal to 50, then the previous digit, check. Is it even? Previous digit, check. Is it even? Yes. If it is even, then keep it as it is. If it is even, then just keep it as it is, guys. It will be 4.4 only. But just for the sake of discussion, let's say it was 4.7 0.50 and I wanted to get rid of this 2 digits. You can see it is equal to 50. Check the previous digit. So what is the previous digit? It is odd number. It is odd number. If it is odd number, add 1 to it. So what will it become? It will become 8. So the final answer will be 4.8 after you round it off. That is how you solve the rounding of digits. Got it? Everyone, how to solve these questions? Very, very important discussions. I hope you are remembering everything now. I hope you are remembering everything. Okay. For 4.350, if you get rid of 50, check the previous digit, 3. 3 is odd. So what will you round it up to? 4. 3 plus 1 is 4. Cool? Understood? All right. Perfect. Let's go to the next question coming up on your screen. What is it? A physical quantity is described by the relationship. This particular thing, if the relative error in A, B, C are 0.2, 0.1, 0.3 and 0.5, what is the relative error in P? Guys, this is directly based on that power formula which I just gave you. Write it down in proper powers. Already done. Okay. So the relative error in P will be relative error in A. What is the power of A? It is half, plus relative error in B. What is the power? It is basically 2, plus relative error in C. What is the power? It is 3, plus power of D is 4. Ignore the negative sign. So into D's relative error. So that's it. So relative error in A is 0.2%. 2 times the relative error in B is 0.1%. Relative error in C is 0.3%, plus D error is how much? 5%. Do the math and tell me quickly how much is it. This is 0.1% plus 0.2% plus 0.9% plus 4 into 0.5, that is 2%. Everybody, what is the answer that you are putting? Is it C pakka for sure? Yes. 0.1 plus 0.9, 1, 2 plus 1, 3, 3 point, yes, 3.2%. Perfect. This should be correct answer. Very good. So now you have got a complete hold of this chapter, I believe. If you have got that confidence, I hope you have smashed the like button. I hope you have hit the subscribe button. And by the way, let me also remind you that the JEE test series right now is live for the last minute preparation. I had made a video of this. I don't know how many of you have seen it. It's just for 399 rupees. Do not forget to check it out. I have given the complete details over here. It's also there in the link of the description box. Last mile test series. Click on this particular link. It will give you the last mile test series, guys. 499 for 10 tests and 150 books access digital copies. If you are okay with only 5 tests, then that is there for 399. These are all India level mock test series with solutioning as well as ranking. This is what you will need after this class. So make sure you are participating in these test series. This is irrespective of whether you already have a test series in your coaching. This is all India level. Okay, keep that in mind. All right, let's start. Let's start with the next concept. What do we have? The next concept, projectile motion, and yes, all their parameters related to the projectile motion. Okay. Do you have to by heart important dimensions? No, you don't have to. Don't sit and waste your time. For example, they ask you this kind of question. What is the dimensional formula for example mutual inductance? What is the dimensional formula for mutual inductance? Will you sit and by heart it? No. How many things will you by heart? Just think of a formula related to mutual inductance and self-inductance. So mutual inductance will be 2 is dimensionless, dimension of energy divided by dimension of the current whole square. So this will be the easier way to tackle such a problem. Remember a formula. I mean, formulas anyways you remember. So that's how you do this. Got it? All right, perfect. Okay, moving on now to the projectile motion concepts and the formulas. Let's revise it quickly. A projectile motion is a motion where you throw a body only under the influence of gravity. And acceleration due to gravity always acts down, and it is not partial towards the masses. Meaning, Even if it is a heavy object or a light object, acceleration is the same irrespective of the masses. And it is approximately 9.8. But if you want to make it more approximate, it is 10 meters per second square for easy calculation purposes. Now, every time acceleration acts down, it is never horizontal. So whenever you throw an object at an angle or vertical or throw it from a hill, doesn't matter how it is going, whether it is going a curved path, whether it is going up and down, whether it is just coming from the top to bottom, always the acceleration is downwards. Acceleration in x-axis is 0. This also is very important because if there is no acceleration in the horizontal direction, no acceleration, no change in velocity. So in the horizontal motion, velocity will not change. It's only the y component, the vertical component, whose velocity will continuously change. So horizontal component will never ever change. Is this absolutely clear, my dear warriors? Yep. Okay. So x velocity is usually u cos theta, because if this is u and this is the angle, obviously the horizontal component will be u cos theta and the vertical component will be basically u sine of theta. This component will definitely change. This component will definitely change. This component will obviously be a constant. That is what it is. Next important thing, the time of flight, maximum height, range, trajectory, velocity at any point, angle at any point, all these formulas. Let's revise them. If you want to find the total time of flight, the formula is 2u sine theta by g. If you make it vertical, if it goes just up and down, sine theta will not come because theta will be 90. Theta will be 90 degrees. Sine 90 is 1. So it will become 2u by g for vertical motion. For projectile motion, it will be 2u sine theta by g. U is speed, g is acceleration, theta is the angle of projection. Remember, this number 2 also plays a role. See, if it is just going up, it is u sine theta by g. If it is just coming from top to bottom, it is again u sine theta by g. So time taken to go up and time taken to come down is equal, and it is u sine theta by g. So time taken to go up and come back is, that's why 2 times u sine theta by g. Is that okay? Everyone? Clear? Awesome. Next, maximum height reached. So when you throw a projectile like this, what's the maximum height that it reaches from the ground level? That formula is u square sine square theta divided by 2g. Again, remember the 2 is below over here. That's something which many students miss usually in the height formula. Range, it is u square sine, not square, this is 2 theta or 2 sine theta cos theta. Sine 2 theta, remember, is 2 sine theta cos theta, that is your trigonometric expansion, divided by g. There is a special case in this for maximum range, like if you throw it like this or at a different angle, you know, the ranges could be obviously different. So the range is maximum, as you can see, when you throw it at 45 degree. So that's when the range is maximum. Also notice one more thing, the ranges are equal for complementary angles. Only for 45 degrees there is no complementary, I mean it is itself. So for 30 degrees and 60 degrees, the range is going to be the same. 20 degree and 70 degree, range is going to be the same. 10 degree and 80 degree, range will be the same. So complementary angles, the range will be equal. Next, the path of the trajectory, meaning as this projectile motion continues, if you take any point, it will have some y coordinate, it will definitely have some x coordinate. The coordinates are related with this equation, x tan theta minus half gx square by 2, u square cos square theta. And as you can see, it is a quadratic equation. If it is quadratic, that means this graph will be a parabola. It is going to be a parabola. So the motion is not just any random curve like hyperbola or ellipse. It is a parabola. It is going to be a parabola. Very good. Similarly, if you take the velocity at any point, then you will notice the velocity at any point will have two components, x component and the y component. So x component will always be constant. Y component, you can use kinematic equations to find it out. The angle of that velocity, yes, the velocity will be making some angle. This will be Vy, this will be Vx, this will be theta, for example, or let's say phi. So that will be Vy by Vx which will be tan phi. Remember, the angle will keep on changing as it moves. Okay, the angle will keep on changing. Correct. All right. All right. Perfect. Moving on to some questions. Ready for some questions? Get ready for it. I want everybody to answer it in the chat box. The initial speed is u. The highest point during the motion, the speed is root 3 u by 2. What is the time of flight? Now, if you recollect the formula for time of flight, it is nothing but 2u sine theta by g. The problem is g is given, u is given, sine theta is not known because theta is not given. Don't worry. Hint is given here. In that particular projectile motion, it is mentioned that initially the speed was u, theta not known, but at the highest point, the velocity is given to be root 3 times u by 2. At the highest point, what is so special? At the highest point, this velocity is the horizontal velocity only, because the vertical velocity becomes zero. The net velocity is just horizontal. So this is just ux. And what is ux going to be? What is ux going to be? It is just going to be u cos theta. Therefore, cos of theta will be root 3 by 2. Therefore, theta, whose cos is root 3 by 2? 30 degrees. Oh, so theta is 30 degree. So I'll just put 30 degrees over here and then solve for the problem. So 2u sine 30 degree divided by g. So sine of 30 is basically half. So half into 2 is cancelling out. So it will be just u by g. So which is B option. Is this clear, my dear students? Everybody with me? Shall we proceed ahead to the next question? Awesome. Moving on to the next question. Guys, don't spam. Yeah, spam the answer, but don't spam and disrespect anyone, or else the admin will come and I know that the admin will block or probably time you out. So don't spam or disrespect each other, but answers spam. B B B B B A C C C C D D D D, whatever it is, spam it. I want everybody spam as answers. Doubts, spam it. No problem. Sir, you are loving. Sir, I'm loving the class. Spam it. No issues. No issues with that. Equation of projectile is root 3x minus half gx square. The angle of projection is how much? Interesting. Now compare it with our standard formula. Comparing it, y is x times of tan theta minus half g x square by u square cos square theta. If you just compare quickly, you will see that tan theta is root 3. So therefore, tan theta is root of 3. And here, g by 2 is there. G by 2 is there. Therefore, u square cos square theta is 1. X square is there, g is there, 2 is there. So u square cos square theta is going to be 1. Perfect, everyone, with this? Okay, but we want theta, that's it. So tan theta is root 3. Therefore, theta is nothing but 60 degree. So theta is 60 degree. That means B option should be correct. Very good. If the question was what is the speed, then substitute it back over here. So therefore, u square cos square 60 will be 1. Therefore, u square cos 60 is half. So it will be half square is 1. Therefore, u square will be 2 square. Therefore, u will be 2 meters per second. So if the speed was asked, this is how you can do it. Theta is asked, this is how you can do it. Time of flight is asked. You know the speed, you know the theta, use the time formula. Maximum height is asked. You know you know theta, find the maximum height using maximum height formula. Range is asked. U is known, theta is known, use the range formula. That's how you can solve anything and everything if you know the equation of trajectory. Got it? Just compare it with the standard formula. You will get most of the things. Just compare it. Next, particle is thrown with an angle of 60 degree with a speed. After some time, the direction of the velocity is 30 degree above the horizontal. The speed of the particle at that moment when it is making 30 degrees is how much? That is the question. Let's see how many of you can do this. Come on, my dear students. Very good, very good. Many people. Very good. Vijay, Naranjan, Tamil, Arjun. Awesome, Aswin. Very nice to see all your answers. Sanjay, very good, very good. Nilvan, Kevin, Jyoti, awesome. Ratan, Naren, Girish, Parma, Broken Heart is flirting over here. Sir, do you think it'll be easy for 22nd Jan? No point thinking about or stressing about it. I'm telling you, it will be the most difficult paper. What will you do? If I tell it is very easy paper, what will you do? I mean, think it is going to be the most difficult paper and go. What is the worst thing that can happen? Most difficult paper, no? That's it. Go with it. Okay? It will be difficult for everyone. Number two, if it is very easy, then understand if you don't complete the paper on time and if you don't solve enough number of questions, that is a big disadvantage. So don't think if it is easy paper, it is good. If it is very easy paper, everybody will do well. And if you are not well, then that's it. Your percentiles will decrease. Remember, your scores are compared with the people in the same shift. So be careful about it. Yeah. So let's see. What is the answer for this, guys? By the way, as this projectile motion goes like this, and initially, what was it? 10 meters per second, 60 degrees. So this was 10 and this was 60 degrees. And somewhere over here, I don't know what the speed is, but it is definitely given it is 30 degrees. What is same is that whatever this velocity Vx will be, that will be the same velocity ux. Yes, both these velocities will be equal because acceleration in the x direction is 0. So velocity is going to be the same. That's it. What is this velocity going to be? This will be 10 cos 60. Cos 60 is basically half, which means it is basically going to be 5. So this will be equal to what? On this side, it will be V cos 30. What is cos 30? Root 3 by 2. So what will be V? It will be 2 times of 5 and divided by root 3. Therefore, V will be 10 by root 3. 10 by root 3 is there over here. So option number D. How many of you said it? Many of you said it. Some of you said option A, that is wrong. Be careful. Easy question क्या करना है? Easy so question करना है या नहीं कर? Oh, I didn't understand what you're saying. Okay. You can watch it as well. No problem for revision. No issues. Next, let's go to riverboat questions. All right. Okay. Perfect. Let's solve this. Oh, by the way, in these projectile motion questions, sometimes they will ask you things like when is the velocity going to be making 30 degrees, or when is the velocity going to be making 45 degrees, and such sort of things. So if such sort of question comes, say they tell you, I have thrown that thing with some angle, and after some time it is already given that the angle made is so and so. Let's say it is given to be 45 degrees. So at what time will it happen? So for example, if the velocity is making 45 degrees, what does it mean? The x and y components, the x and the y components both are going to be equal, because 45 degrees means it is an isosceles right angle triangle. So Vx will be equal to Vy. So if Vx is equal to Vy, Vx is always going to be Ux, Vy will be Uy plus Ay into T, equation of kinematics. Here remember, acceleration is not there in x direction. Ux is nothing but u cos theta, Uy is nothing but u sin theta. So acceleration is negative g and this is time. So from this you will get u cos theta minus sin theta, or basically put that gt term over here. So gt will be u sin theta minus u cos theta. So therefore time will be u sin theta minus cos theta, whole thing divided by g. So that's how you can find out this particular time. Okay, theta is basically this. U is that. So you can find the time when the velocity makes certain angle. Such sort of questions can come. Okay. Yes, perfect. Let's go to riverboat related questions and formulas. Now, remember over here, usually you will be given two banks, okay, and the river will have some speed, the swimmer or the boat will have some velocity. So u is velocity of that boat in still water, meaning if the water moves, this velocity will get added. If the water is still, in that still water, the boat or the swimmer can swim at certain speed. So the river will have certain speed. Let's say that is W. So W becomes the velocity of that particular river. So then you get V, which is the net velocity of that particular boat or swimmer with respect to the ground, means the bank, with respect to the bank or the ground. So that will be basically this, and therefore V bar will be the vector addition of U bar and W bar. U bar and W bar. Keep this in mind. Everyone, okay? Till this point clear? Next important thing. This will be the distance between the banks of the river, and they might ask you what is the time taken to cross. What is the time taken to cross? Always, whenever you have to find the time taken to cross, see, to cross the river, you have to go from one bank to other bank. The other bank is on the vertical side, the upper side, Y side. So you just consider vertical motion or perpendicular to the bank motion. So time is distance by speed. So distance by the speed, everything along the crossing direction. What is the distance? Distance is d. What is the velocity along that cross? The velocity along that cross, if this is the velocity, just consider the y component. Don't consider the x component or even the total velocity. No, only consider the y component. That's it. That is the time taken to cross. Is this clear, everyone? Next, as you proceed, you will see that you will reach somewhere over here on the other side of the bank. So yes, there is some drift which will occur. There is some drift which will occur. This particular drift will be the time that you spend in crossing. Distance is time into speed. So basically the speed along the river, the speed along the river. So time taken to cross is just over here. We just figured it out, whatever it was, same thing. Okay, the same thing. Speed along the river is basically Vx. So this multiplied by Vx is basically going to be the drift. This is going to be the drift. Got it? No other formula will be needed. Now there are two special cases in this. What are those two special cases? First is you want to cross it in the shortest time. If you want to cross it in the shortest time, and the second one is basically the shortest distance. You don't want to cover extra distance. So say for example, this is the banks of that particular river. You want to cross it in the shortest time, means you will push yourself or swim along the perpendicular direction. Yes, the river will pull you this way and your resultant will be like this, and you will end up drifting somewhere over here. Okay, you will definitely encounter some drift, okay, because of this. Here, if you notice, the time taken to cross, which will definitely be the least, will be distance between the banks, whatever it is, let's say d. It will be d divided by that vertical speed. Vertical component will be just going to be u. So it will be just u over here. That's it. That's what you will put. So this is v. This u is also going to be vy. U is also going to be the vertical component. So that is the minimum time taken to cross the river. Whereas over here, in order to ensure that you have minimum drift, so this is the river velocity. Your resultant velocity will be perpendicular. So therefore, you will swim against the current like this. This is how your u will be. This is what your v will be. And maybe this is that particular angle. And you will have no drift in this case. So there will be no drift in this particular case. Got it? So this is how you will be swimming for shortest distance. You can measure that angle. It is not that big a deal. So sine theta or cos theta you can find out, because sine theta will be nothing but what is it? Sine theta will be nothing but opposite by hypotenuse. So w by u. So that's how you can find the angle at which you should swim so that your resultant is perpendicular and you encounter no drift. Here u is perpendicular, here v is perpendicular. That's the difference. Cool? All right. Let's solve some questions. Here it comes on your screen. Come on. Hari, Narayan, I'm telling you, we are trying to cover the entire things as much as possible. All right. All high weightage topics, concept question, concept question, concept question. All right. So 11th and 12th standard entire syllabus, this session might go on 4, 5, 6 hours, who knows. The boat crosses a river of width 1 kilometer, shortest path is 15 minutes. If the speed is 5, then what is the speed of the river? Come on, think about it. Okay. The boat crosses 1 kilometer width of river, shortest path in 15 minutes. If the speed of the boat is 5, then what is the speed, okay, of the river? So as you can see, certain data points are given to me. The width is already given. It is nothing but 1 kilometer. Okay. Now, in 15 minutes, okay, so my resultant velocity will be like this. The river velocity will be like this. Okay. And still water, this speed is also given to me. How much is it? It is given to be 5. Okay. Now, if this is the scenario, think about it. The time taken to cross the particular river will be distance by the vertical component. The vertical component in this case is itself V. Distance of that river banks is 1 kilometer. Time taken to cross is 15 minutes. 15 minutes in hours is 1/4 of an hour. Remember, 15 minutes is basically 1 by 4 of hours. This was 1 kilometer. This velocity will be kilometer per hour. Everything is in kilometers per hour. So velocity will be 4 kilometers per hour. Okay. So I got this value of velocity as 4. Obviously, this is going to be a right angle triangle. If this is 5, this is 4. This is a Pythagorean triplet, guys. 4, 5, and this will be 3. 4, 5, 3, 37, 53, 90 triangle. So answer should be 3. That's it. Very, very easy. Got it? Awesome. Awesome. Very nice. D. Very good, Srinivasa. Paddu. Only JEE. Awesome, Tamil. Moving on to the next question. River is so much meter wide. River speed is given. Boat starts perpendicular. How far from the point directly opposite does the boat reach? Meaning the drift is asked. Drift is asked. This is one bank, this is another bank. The boat guy is trying to swim like this. With what velocity? This is basically 5. Okay. The river speed is how much? River speed is 3 meters per second. So the resultant velocity will be like this, and you will end up reaching here. You intended to reach over here. So obviously there will be some drift over here, and that drift will be asked. Now the drift is, what is the velocity along the river? What is the velocity along the river into the time taken to cross? If you notice, the velocity along the river is exactly 3. The velocity along the river is exactly 3. I just don't know the time. How can I find the time to cross? The time to cross is d by vy. Distance of that river is 20 meters. Vertical speed is just 5, which means it will be 4 seconds. Just put that 4 over here. 3 4s are 12. So 12 meters should be the answer. Correct. It is 12 meters. Got it, everyone? No, it is not 15. It is 12. Very good, Abhishek. Disaster. Awesome. Okay. Lunch break after some time. We'll have the lunch break. Don't worry. Yeah. Cool. Shall we go ahead? Ready for the next question, guys? Okay. Here we go. The boat is moving with a velocity of 3i plus 4j. Velocity is minus 3i minus 4j with respect to the ground. The relative velocity of the boat with respect to the water. Okay. Let's see what and all is given to me. The boat is moving with a velocity with respect to the ground, meaning this is the net velocity. So V is 3i cap plus 4j cap. The river water is moving with this much velocity. That means water velocity is minus 3i minus 4j. Remember, this is always the resultant of this plus u. U is question mark. U is basically question mark. And we know u plus w gives me v. Therefore, U will be V minus W. So what is V? V is basically 3I plus 4J, this whole thing, minus what do we have over here? Minus water velocity, which is minus 3I minus 4J. Okay, so what will I eventually get? Minus minus is plus, 3I plus 3I, 6I, minus minus plus 4 plus 4 is 8, 6I plus 8J. So 6I cap plus 8J cap, which is option number C. So you need to know this equation. Without that, you will not be able to do this question. If you know each term separately, what it means, and you are consistently using same formula, same symbols, same alphabets, it will get stuck in your head. Or else once you are reading from one book, once you are reading from another note, once you are making some other manner of remembering it, it will become difficult. Okay, awesome, awesome, great. Moving on. Broken heart, your Priyanka is not here. I think Priyanka is studying for JEE. If you want to meet Priyanka, you'll have to visit inside the IIT campus. Yeah, because she's studying properly. So Priyanka will go into the IIT campus. But oops, so sorry. You will not be allowed inside the IIT campus because you're not studying, no? So the gatekeeper only will be like, stop, where is your ID card? And you will be like, oops, I can't enter inside IIT. So you will not be able to meet Priyanka. So don't waste your time. But if you want to meet Priyanka, you better study. Then maybe there is a chance. All right, cool. Moving on to the next question coming up on your screen. Yes, oh, it's a concept, and we are going to Newton's laws, pulley concepts, and yeah, Newton's laws. All right. Now, whenever you have a pulley just changes the direction of the string's tension. And if it is a fixed pulley, like the one over here, okay, the force required to lift the load is equal to the weight of the load. So, meaning if the pulley is over here and you have some string wrapped around it and there is a mass over here, the force which you require will be exactly equal to the weight of that mass. That's all. Okay, force required will be exactly equal to the weight of that mass. The pulley is stationary, mass is stationary, nothing is moving, acceleration is zero. It's a fixed pulley, nothing is moving, acceleration is zero. But the moment things are moving and all of that, then things will change. You have to use Newton's laws. Also remember one more thing. That sometimes the pulley will be here. The pulley itself might have some mass, and then maybe the string wrapped around it will have some tension. It will have some tension. The pulley itself might have some mass, which is mg. So the roof on the top might exert some normal reaction. The roof might pull it up, and how much force will it have to apply? Mg is there, and this tension, so 2t. So the roof will apply a force of mg plus 2t. That is what you need to keep in mind if such a question comes. Also, whenever you draw a block which is connected to a string and maybe it is accelerating up or down, then that block will experience a tension because of the string. It will have its own weight mg. When you write Newton's law, which is net force is mass into acceleration, always the direction of the acceleration is considered as positive. So it will be tension minus mg is equal to m times of a. Tension minus mg will be m times of a. Okay, keep this in mind. If it was accelerating down, then it will be mg minus t. This will be positive. So mg minus t will be mass into acceleration. That is something again you need to keep in mind. Now, standard formulas. Now, there are many standard formulas. Instead, I will tell you an easy way to do any question within seconds. This is Shreyas sir's trick. Look at what Shreyas sir's trick is. Observe carefully. If you have a pulley, you have a mass, and you have another mass over here, and you have to find what the acceleration is. Always remember the trick is acceleration is the pull force minus the opposing force, okay, the whole thing divided by the mass which is moving, all the masses which are moving, the total mass which is there. So if you apply that concept over here, this acceleration will be the pulling force. The pulling force will be nothing but m2g. So m2g, opposing force, it's trying to go up. This m1g is opposing it, so it will be minus m1g upon the total mass, which is nothing but m1 plus m2. That's it. So it will be nothing but m2 minus m1 divided by m1 plus m2 into g. If you draw the free body diagram and then try to solve it for the tension, right? If you solve it, then the tension will come out to be 2m1 m2 divided by m1 plus m2 into g. That's a standard formula. Remember it. Similarly, let's say I apply the same thing to another question. Let's say there is a mass here, there is a pulley here like this, okay, and there is another mass here. This is, let's say, m1, let's say this is m2. Now this is coming down, so the pulling force is m1g, let's say. Maybe there is friction over here, so the opposing force will be mu m2g, mu m2g. So if you want to find the acceleration, the pulling force will be m1g, opposing force will be mu m2g, whole thing divided by the total mass, which means m1 plus m2. That's it. That is the answer. Okay. Now there is a trick in this also, where imagine you have a pulley like this. This is mass 1. Let's say this is mass number 2. Let's say this has mass. Pulley itself has mass. Then how do you find the acceleration? Well, first of all, the pulling force will be m2g. Opposing force will be m1g. So numerator will not change. Pull minus the opposition. Total mass m1 and m2 are there. m1 plus m2. But what about this mass? Pulley itself has mass. So this is a pulley with mass. This is nothing but pulley with your mass. What do you do in that case? In that case, what you do is basically take the equivalent mass of the pulley. Let's say the pulley is given to be a disk. Let's say it is given to be a disk. Remember the formula for moment of inertia for a disk. The formula is m3 r square, m3 r square by 2. So this number 1 by 2 is very important. That number factor will come over here. The equivalent mass will be m3 by 2. That m3 by 2 will come over here. That formula which is there in moment of inertia, that number which will come 1 by 2, 1 by 12, 1 by 4, 1 by 3, 2 by 5, 2 by 3. That factor will come over here. That will be basically the equivalent mass of rotation. That is the trick. I'll give you one more question. Don't worry. From that you will be absolutely clear. Let's say this is mass 1. Okay, this is another pulley. Just like the previous question, this is mass 2, this is mass 3, and let's say it is a solid sphere. This is nothing but a solid sphere. Okay, and this is coming down with some acceleration. This acceleration, assume that this is smooth for now. Assume this is smooth for now. Pull force, how much is the pull force? m2g. Opposing force, not there only. So minus 0. Total mass, m1 is there, m2 is there. Plus solid sphere, what is the moment of inertia formula? 2 by 5 m r square. So this number will be 2 by 3 times of m3. So very easy to solve these questions. If you don't know moment of inertia, then please by heart all the moment of inertias of all the things. 5-6 things only are there. Just by heart it. It will become very, very easy. Is this clear, everyone? Yes. Isn't it L by R to cancel the radius? Yeah, you can do that. It is a more complex way. I'm telling you very easy way. Just remember the factor which comes. What is that factor? 2 by 5, 2 by 3, 1 by 12, 1 by 2, 1. Just do that. It will become very easy. So even if you have a more complex question, something like this. Let's say there is a mass here. Okay. And there is a mass here. Let's say there is 2m mass here. This is, let's say, a disk, and then it goes to another pulley over here. Let's say this is a solid sphere. Let's say this mass is 5m, and this is going on a inclined plane like this. Okay, this is, let's say, 4m, and this inclination, let's say, is 30 degrees like that. And it's known to me that it is, let's say, for example, assumed to be accelerating like that. So how do you solve this problem? It's a smooth plane. Again, acceleration is the pulling force. Pulling force will be along this direction. Remember, mg will have two components. Mg, 4mg will have two components, one here, one here. This will be not pulling it, this will be pulling it. So this will be 4 mg sine 30. Correct? So it will be 4 mg sine 30. Opposing force will be here only. So it will be just mg. So minus mg over here. The whole thing divided by the total mass. M is there, 4m is there. M plus 4m plus, this is a disk. For a disk, what is the formula, guys? M r square, M is 2m, r square by 2. So the equivalent mass will be how much? Equivalent mass will be how much? 2m by 2, which is just m. Is that right? So the equivalent mass in this case is how much? M only, because 2 got cancelled. For a solid sphere, what is the formula? 2 by 5 mass. Mass is 5m r square. So 5 cancels. Equivalent mass will be how much? 2m. So just put 2m over here. That's it. That will be the acceleration. Isn't it a simple method, guys? Everyone, let me know. Understood how to solve these questions? Okay. All right, this was sine. I missed that sine over here, sine 30. Yeah, if you want to solve it, you can solve it. It is not that difficult. So the acceleration will be sine 30 is half, 4 into half is 2. So 2 mg minus mg, the whole thing divided by 1 plus 4, 5, 5 plus 1, 6, 6 plus 2, 8. So 8m. So 2 mg minus mg is mg. So mg by 8m. So mm cancels, it will be g by 8. So g by 8 will be the answer for this. Okay, cool, clear, understood? Very, very simple. Let's see if we can solve this now. Find the acceleration and the tension. Okay, numerical type of question. Numerical type of question. All right. How to get this? Well, pulling force is only over here. There is no friction. All surfaces are smooth. Okay, perfect. So acceleration will be pulling force, which will be just 4g. 4g. There is no friction only. So it is completely smooth. No force at all. Minus 0 upon total mass, which is 4 plus 2. So it will be 4g by 6. Or if you want, you can write 4 into 10 divided by 6. 4 goes 2 times, 6 goes 3 times. Okay, so it will be basically 20 by 3 meters per second square. This is done. Now you draw the remaining forces. All right. And you can just say this is basically tension. So for this mass, tension is mass into acceleration. But acceleration, we just figured it out to be 20 by 3. So it will be 40 by 3 Newton. So tension is 40 by 3 Newton. No other force is there in the horizontal direction. Vertically, yes, there are forces, but that is not what is important. Tension is mass into acceleration. Job done and dusted. Okay. So yes, 40 by 3 Newton and 20 by 3 meters per second square. Yeah, I'll be uploading the session PDF in the description box of this particular video only, not the Jungle Book or anywhere else. Okay. And I'll tell you one more thing. PDF is very important, but you have to also attend the class. If you just see the PDF, you'll be like, okay, okay, okay. But if you just see the class also, you'll be like, ha, 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 ha. So PDF is important because after the class, you will go through the problems, you will go through the concepts. Session is important because you will understand, you will develop that aptitude, you will be motivated, you will be getting the proper explanation. So both the things will be important and you have to get the PDF after the class is over. Okay, you will get it, don't worry. Moving on. System shown in the figure, the acceleration of 1 kg mass and the tension in the string connecting between A and B is how much? Okay, so both these masses, I think we can just couple them together. That will be easier, right? Yes, so I can just couple them together. That's one single mass of how much? 3 plus 1 is how much? It's just going to be 4 kg. Yes, it's just going to be 4 kg. So the 4g force will be over here and 3g force will be here. This entire system will accelerate like this. This will obviously go up because this is lighter, this is heavier. So the acceleration will be pulling force, which is 4g, opposing force, which is 3g, upon total mass, which is 4 kg plus 3 kg, 4 plus 3. So 4 minus 3 is 1, so g by 7. So acceleration is g by 7 and that find the acceleration of 1 kg mass. 1 kg mass is going down. So g by 7 will be downwards. G by 7 downwards. Yes, definitely it is here. Now the question is also about the tension connecting them. So draw the free body diagram of that 1 kg mass. You will notice, well, 1g is here. There is some tension between the ropes, which we have to find. And it is going down with g by 7. So the force equation will be 1g minus v is equal to mass into acceleration. So tension will be 1g minus g by 7. 1 minus 1 by 7 is going to be 6g by 7. So tension is 6g by 7, which is exactly mentioned over here. So C is the correct answer. Perfect. Cool. Yes, C for Capto Shreyas. Awesomeness. Awesomeness. Moving on to the next concept of frictional force. Well, standard things. Friction is of two kinds, static and kinetic. When you try to push something, first the static friction will come into play and it will try to oppose whatever force you are applying. If you apply 2 Newton force, then it will also apply 2 Newton in the opposite direction. If you apply 3, it will apply 3, 4, 4, 5, 5, like that. Let's say till 9 Newton. Till 9 Newton you applied 9 Newton force, you can bear it. But if you apply even 9.005 Newton force, you immediately see that it starts moving, which means the force of friction was not able to hold it in static nature. So it has started sliding. It now enters a different kind of friction called as the kinetic friction. And the kinetic friction is always less than the threshold friction, the maximum frictional force, because once a body is moving, the friction experienced is less because the surfaces, they will just fly on top of each other, not literally, because there will not be enough time for the surfaces to interact with each other, to get trapped or to get stuck. So that's the reason why when it is stuck, it is difficult to move, but once it is moving, it is easier to keep it moving. So you will see that the kinetic friction is usually going to be less. Static friction will be less than or equal to mu s n. This mu s n is basically the maximum frictional force. Mu s is the coefficient of static friction. N is the normal force on that particular surface. Okay, normal force on that particular surface. Kinetic friction is obviously less than your Fs max, and it will be mu k into n. Mu k is the coefficient of kinetic friction. As you can see in this particular graph, mu k will definitely be less than mu s. But they are not very different. Small difference will be there, but usually mu k is smaller than mu s. Okay. Then also remember angle of repose. It's a very important concept where that is the angle after which any box or any body which is kept, it begins to slide. It just begins to slide. So you can keep increasing the angle, and at one angle it will start sliding. So that angle is alpha, angle of repose. Tan of angle of repose is coefficient of static friction. Coefficient of static friction. Yes, you will be having similar session for chemistry and mathematics too. Limiting static friction is also Fs max. Yes, Fs max is the same as limiting friction. Limit of that friction. Limiting friction, static friction, threshold friction, everything means the same thing. Don't get confused. Okay, Fs max, all these are same things. Very good, guys. Now, if remember, if basically the inclination is less than the angle of repose, it will not slide. If it is more, then it will slide down with some acceleration. So if tan theta is more than mu s, remember tan alpha is equal to mu s, it is just on the verge of sliding. But if theta is basically more than alpha, definitely it will start sliding, and the acceleration while sliding is g. Remember this value, g common, sine theta minus mu cos theta. If friction is absent, mu will be 0 and the acceleration for a smooth surface will be g sine theta. If it is having friction, g sine theta minus g mu cos theta, or g can be taken common. Very important acceleration formula. Keep this in mind. Is that okay? Another important thing related to friction, many times they ask you this question. If you have a circular track and a vehicle is going on that circular track, how much can be the maximum speed without it skidding off the surface? That maximum speed on that curved track, horizontal, is root mu rg. Mu is coefficient of static friction, g is acceleration due to gravity, r is the radius of that track. that circular track which is there, the radius of it. So this is the maximum speed formula. These are the critical things which you should remember. Also, in the angle of repose, they can ask you these kind of questions where they will give you a heap of sand, and if you keep on adding sand, I mean, it will keep on becoming like this, but after a point it will not increase in height, rather it will just become a cone. If you add more sand, it will just, you know, it will just slide down like this, and it will have a constant angle. This angle is also the angle of repose, because if any more sand is added, it will just slide down, because the inclination angle will be more than alpha there. So if you add more sand, it will just slide down over here, and it will ensure the angle of inclination of that heap of sand is basically alpha. This concept is also used in that insect in the bowl question. So you will have a bowl like this. You will have a bowl like this, and there is an insect, and it can only climb till certain height. Why? Because as you move up, the inclination will increase, and there is a certain instant when that inclination will be exactly alpha. So the insect inside can only reach till here from the bottom point. So this is basically the maximum height which the insect can go. This is the maximum height which the insect can go when the tangent drawn makes an angle of alpha, which is the angle of repose. These questions are standard questions. All right, perfecto. Let's do some questions on this, and then we can have a small break, definitely. Okay. How to find the friction direction in circular motion for different cases? Okay, I'll tell you something. Always remember one thing. Static friction always opposes the tendency of motion. Whereas kinetic friction always opposes the actual relative motion. That's how you do it. So say for example, you have a curved track, and let's say there is a vehicle which is going like this. Okay, vehicle which is going like this. What is the friction which will be acting? First of all, it will be static. What is the tendency of the vehicle? Always static friction opposes the tendency. Remember, the tendency of the vehicle, it tends to fly out. It tends to fly out. Hence, the static friction will pull it towards inside. Hence, the static friction will pull it towards inside. Then there is one more question where there is a circular drum, and that circular drum, like a washing machine, is spinning. The axis is vertical. Imagine the clothes or the objects inside are spinning like this, and they all stick to the circular wall or the curved wall of that cylindrical drum. So imagine such a scenario, guys. This is that circular drum. It is spinning like this. Then obviously it wants to fly out any object over there, any object, let's say over here. Okay, I'll just take it over here. This is our object. It will try to fly out. It will try to fly out. That's why there will be a normal force on it from the wall of the container, from the wall of that cylindrical container. It will tend to fly out. So there will be centrifugal force outside, centrifugal force outside. Because of its own weight, it will try to fall down. Because of its own weight, it will try to definitely fall down, the weight of it. Now, because it wants to slip down, friction will prevent it from slipping. So static friction will act upwards. So static friction will act upwards then. Got it? Understood? Very good. Similarly, imagine that you have an inclined plane, and let's say you have kept a box on it, and somebody decides to push this particular box like this with a force more than mg sine theta, with a force more than mg sine theta. Remember, mg sine theta will act downwards, and somebody is pushing it with more force than mg sine theta. So what will happen? It will have a tendency to fly up. It will have a tendency to slide up the inclined plane. So what will static friction do? Static friction will oppose it. So static friction will act like this. Got it now? How to find the direction of the friction in any given scenario? All right. Kinetic friction is always easy because you can already see the motion happening. So say for example, you have one surface like this. This is going with 7 meters per second. And let's say this bottom surface is like this, which is going with 9 meters per second. Then you sit on this and look at this. So sit on the bottom guy and then look at the top block. You are moving fast, this guy is moving slow, so this guy will appear to move relative motion of 2 meters per second. So what does kinetic friction do? It always opposes relative motion. So the friction on this guy will be like this. Got it? So always check the relative velocity and then solve the question for kinetic friction. Awesomeness. Moving on now, there is a mass which is on a rough contact with a plane inclined at 30. Find the coefficient of friction. If it is just, I think, on the verge of sliding and all that, it is just about to slip. Just about to slip means the concept of angle of repose should be used. So tan of alpha should be mu s. So static friction is what is asked. Angle is already given to be 30 degree. So 1 by root 3 is mu s. So 1 by root 3 is a standard value, 0.57, because root 3 is 1.732. So it will be 0.57, I think, around that much. Yes, it is 0.57. That's 1 by root 3. Okay, so that's how you solve this particular question. Usually it can be asked as an integer type, so you might have to go till the second decimal. Better to remember these root 1 by root values and all of that. If a body takes time t to reach the bottom with the horizontal angle of inclination theta, if the plane is made rough, then it takes double the time. What is the coefficient of friction? Okay, let's do this. If the plane is smooth, if you release that block, it will reach over here in time t. The distance covered is x. It starts from rest, and the acceleration for a smooth surface, remember, will be g sine theta. So use kinematic equations. S is equal to ut plus half g sine theta into t square. Okay. In the second scenario, the same surface is now made to be rough. The same block is left from rest and it reaches over here, covering a distance of x only, but in double the time. But this time the acceleration will be g into sine of theta minus mu cos theta. That is the formula. Remember, I just gave it to you. Okay. So again, use kinematic equations. So S is equal to ut plus half into g sine theta minus mu cos theta, but the time taken is 2t, so 2t whole square. All right, x will be equal. Question is find the coefficient of friction theta terms. Okay, so x is going to be the same. So take this x from here. So it will be half g sine theta into t square. Okay, is going to be equal to, I have half over here, g over here, where very good, sine theta over here minus mu cos theta over here, and this 2t square will become 4t square. T square cancels, half cancels, g cancels. So what am I left with on the left hand side? Just sine theta is equal to, and over here, is that right? G got out, 2 got out, t square also got out, sine theta is remaining. Okay, so sine theta multiplied by 4, that is 4 sine theta, minus mu into 4 into cos theta. That's what it is. So take that 4 mu cos theta on this side, 4 mu cos theta on this side is equal to 4 sine theta over here minus that sine theta, 4 minus 1 is 3, so 3 sine theta is equal to 4 mu cos theta. So, okay, mu will be equal to 3 by 4 sine theta by cos theta, which is 3 by 4 tan of theta. So 3 by 4 tan of theta, which is A option. That's how you do it. Is that okay? Cool. Perfect. Awesome. Option A is the correct answer. Very good, guys. Very good. Awesome. Awesomeness. Moving on to the next question. Yes, this is also a very popular question. If there is a block which is sliding with a force F at an angle, coefficient of friction is mu, the acceleration A is given by. Very nice question. Reason why it is nice is because normal will not be mg. Yes. See, the weight of the block definitely will be mg, but this normal over here won't be mg because this force will have two components, one over here, one over here. This will be F cos theta, this will be F sin theta, and apart from that, there will be a normal reaction. Now, the total acceleration is towards the right side, and we have to find that out. And well, I think friction is also going to be there because it is going towards the right side. So friction is also there. That is mu into n, mu into n. So I think we need to find the normal first. So if you do everything in the y direction, the normal plus f sine theta will be balanced by weight. Therefore, therefore, normal will be mg minus f sine theta. Okay, perfect. Now let's do everything in the horizontal direction. In the direction of acceleration, everything is positive. So therefore, f cos theta minus the friction, which is mu into n, will be equal to mass into acceleration. Okay, so f cos theta as it is, mu k as it is, normal, I will just get it from here, which is mg minus f sine theta. Is that right? Is equal to mass into acceleration. Rearrange this, I think, and put mass below. So F by m cos theta minus mu k g, m gets cancelled, minus minus becomes plus. So mu k F sine theta divided by m is equal to a. Therefore, acceleration will be, take F by m common, cos theta plus cos theta plus mu k sine theta and minus mu k into g. That is what it should be. Yes, that is what it should be. Yeah, it's the same thing. However you want to write it, f by m cos theta is there. Yes, minus mu kg is there. Minus minus becomes plus. Mu k f by m sine theta is also there. Yes, this is the correct answer. Yeah, it is C option. Just check this out. Okay, the options look very similar to each other, so you need to be very, very careful. You need to be very, very careful. Harish, I don't know. The way it is going, I think it might go on like that only. All right. Kinetic energy of a particle is changed by 300%. Find the percentage increase in its momentum. Did we miss a slide? Oh, yeah, we missed a slide. Kinetic energy. Yeah. Okay, we'll come to this after a short break. Just give me some time, just 5-10 minutes, and then we'll be back. 10 minutes break, and then we'll continue. Hello, hello. All right, the time is up. Get all your friends back to the session because yes, Shreyas sir is here on Makar Sankranti, on Pongal, on Lohri for your festival celebration. And in fact, we are celebrating this festival because we are JEE students by attending a class, by revising the entire chapters, revising the entire subject, in fact, in this one short marathon for 99 percentile. If you are a zero, if you feel that you are not better than most other students, if you feel hopeless, if you feel demotivated, this session is for you. This will 100% boost your score. Just give me one day, and that is today. Tomorrow there will be chemistry and then maths. So these 3 days, guys, this is going to boost your scores like anything. Build your confidence. So get all your friends because we don't want any student to be left behind. Neither should you. Don't think, sir, if I tell my friend to attend, he will score better, my rank will go down. If that is the way you are going to think, definitely your rank will also not go up. So encourage everyone to attend this class because this is specially for all the kids, and this is, yes, in English, because many lectures are there in Hindi and many students don't understand it that well or don't connect with it that well. So this is for all the kids who prefer learning in English, and this is the number one J English channel. All right, so let's begin. No, this is not thermodynamics. uh, welcome. Hi Arya, hi Anshu, hi Aditi. 40 45 what. Welcome, disaster. Welcome, everyone. No, we are not concentrating on JEE Advanced in this particular session. This is for January attempt JEE Mains 2025. Okay, so break is over. The next concept, one second, let me just change the AC temperature. I'm already sweating. All right. Done. Let me get my pen. Okay. Work kinetic energy theorem states that the work done by all the forces externally and internally together, that is the total work done, changes the kinetic energy of the system, where the kinetic energy formula is half mv square, or the square of the momentum by 2 times of the mass. That's what work kinetic energy theorem is. Also, when you want to calculate the work, you have two options. If the force is constant, it is F dot of S. Else, it is integration of force with respect to the displacement. This is when F is going to be constant. This is when F is going to be a variable. This integration also tells me that you can just take the graph of force with respect to displacement, and let's say the graph is going like this. You just measure the area under the graph. This area, whatever is there, is the integration. That area will give me the integration of force with respect to displacement. Cool. Integration is area under the graph. Remember, the areas which are on the top are positive, area which is below is negative when you are doing the calculations. All right, so let's do some questions. Kinetic energy is increased by 300%. Find the percentage increase in its momentum. Please do not use error formula because the percentages are very large, in fact 300%. So definitely you cannot use those error formulas. Yes, break is over. Neha and Akash, yes, the break was just now. I think you just came after the break. Okay, so welcome Anshu. All right, maths and chemistry, Aditi will be there tomorrow and day after. One day, one subject is going to be there. Is that right? Okay. Now, here, what we do is basically kinetic energy is changed by 300%. Let's say the initial kinetic energy was K. Then, if you talk about the final kinetic energy, it will be the old kinetic energy plus it is increased by 300%. So, 300% of K. That is the change. So, which will be K plus 300% of K means how much? 100% of kinetic energy means K. 200 means 2K. 300 means 3K. So therefore, this will be 3K. So the final kinetic energy will be 4 times of K. Now our usual formula for kinetic energy and momentum is p square by 2m. Isn't that right? So it also means that initial kinetic energy will be p square by 2m. Therefore, the final kinetic energy, this 4k, will be also equal to the new momentum square by 2 times of m. But wait a minute, k is nothing but p square by 2m. So just put the value of k from here, which was p square by 2m, and this continues to be equal to the new momentum square by 2m. 2m cancels. So therefore that new momentum will be 4 times of p square. Now take uh, new momentum square will be 4 times of p square. Take square root on both sides. The new momentum will be 2 times of that old momentum. This can be also written down as p plus p, which means it will be p plus 1p is nothing but 100% of p. So this is basically the change of that momentum. So the momentum increases by how much? 100%. That should be the answer. Okay, many people give a wrong answer. I have seen many people giving 200% or even sometimes some weird answers, but that is not correct. All right, perfect. Thank you. Oh my God, We Enthuse Club, you deserve a shout out. It means a lot. Where can I go about it? Yep, there we go. Oh my God, thank you so much. Thank you so much for your Guru Dakshina. I mean, it was not really uh, needed. Your like is also enough. When you smash this like button and you subscribe to the channel, that is really grateful for me. But thank you for the super chat. Sir, you are the reason many students get into IITs, NITs, and wishing happy Makar Sankranti, Pongal, Lohri to each and everyone. Thank you, We Enthuse Club. Means a lot. Let me just like this. Yes, perfect. Thank you so much. Means a lot, yeah. We Enthuse Club. I mean, I don't know. You are making me emotional by sending this, because no teacher ever asks for such donations. We tell, okay, please, join our courses. We just, buy the material that we have worked hard on. Okay, but this donation means a lot. Thank you so much. Thank you so much. All right, moving on to the next question coming up on your screen, and let's see what it is. Okay, there is a block which is kept. This was asked in 2019. It is moving up with an acceleration of g by 2. The question is, what is the work done by the normal reaction in time t? What is the work done by it? Okay, let's see how do we do this particular question. First of all, in order to find the work done, what we need is the force into the displacement. Here, which force are we talking about? The question is the work done by normal. So it will be the normal force. It will be the normal force multiplied by the displacement of that particular body. Do I know the normal force? Not yet. We can find it out. Well, the weight of this box will act downwards. The normal force will act upwards. Acceleration is upwards. So normal minus mg is ma. Therefore, n will be mg plus ma. A is nothing but g by 2. So 1 plus half is 3 by 2. So it will be 3 by 2 times of mg. So that is our normal force. So I'm just going to put that over here. 3 mg divided by 2. Still the displacement part is remaining. How do I take care of it? Well, I can use displacement is ut plus half a t square. Initial velocity 0, acceleration g by 2. So put that over here into t square. So it will be gt square divided by 4. That's your displacement. So put it over here, gt square divided by 4. That's it. I think we can calculate the work now. 3 m g into g square t square, 2 4s are 8. So 3 by 8 should be there somewhere. Yes, 3 by 8 is only over here. So option D will be the correct answer. Perfect. Very good. Awesomeness. Very good. Clear? Close enough. Fourth option, very good. Disaster. Yes, Sri Shinchan, awesome. All right, Padu, thank you. Love you too, bacha. Hopefully, you are saying I love you to me only. Maybe not some other person over here, because we have sometimes some kids who are saying I love you, and then I'm like, thank you. Then the kid told me, no, sir, it was not for you. It was for that other person in that chat box. I'm like, oh, sorry. Sorry to disturb you both. Continue. All the best. A particle of mass 0.1 kg is subjected to a force which changes with distance as shown. If it starts its journey from rest and its velocity at 12 meters will be how much? Okay. So, in order to do this particular question, find the speed force graph. I think work, power, energy, obviously, because the area under this particular graph, that area is going to give me the work, and work area is of a trapezium, which is half into sum of the parallel sides multiplied by the height of the trapezium. What is the parallel sides? This is 4 units, this is 12 units. So the sum of the parallel sides will be 4 plus 12. Height of the trapezium is 10 units. So this will be 4 plus 12, 16, 16 by 2, 8, 8 into 10 is basically 80. So 80 joules is the work done. And we know by work kinetic energy theorem, work is final minus initial kinetic energy. Final kinetic energy is half into mass, which is 0.1 into velocity square. It starts from rest. It starts its journey from rest. So initially will be 0. And the work done, we just calculated it to be 80 joules. Okay. So now 2 into 80 divided by 0.1 is V square. Therefore, V square will be 80 into 2, 160 divided by 0.1, 1600. Therefore, velocity will be root of 1600, which is 40. So 40 meters per second is option B. Yes, that is the correct answer. So that's how you use the concept of area under the graph to calculate the work. You should know the standard areas of standard geometries like circles, semicircles, triangles, squares, trapeziums, triangles, all these things, standard things. And kinetic energy theorem, which will give me change in the kinetic energy, is the work done. So I use that. No need of kinematics, no need of Newton's laws as such. All right. Yes, some of them are PYQs, some of them are non-PYQs. Okay, both combinations are done. Home thief, I'm very good. I'm scared. Please don't ask me such questions with such names. I'm like, are you going to rob me? Yeah, home thief. Right. All right. So what is the next question? We have two masses connected with some spring. And the question is, if both of them are given the speed v, then what's the maximum elongation? What if they ask velocity in a and t graph? If that is the thing, Chaitanya, area under acceleration time is the change in the velocity. So find the area of acceleration time. That will be v final minus v initial. If you know initial speed, you can find the final speed. Okay, Chaitanya? All right. Home thief. No, I have not forgotten you, because I think first time a thief is visiting my class, unless I've forgotten this particular pseudonym. Okay. So what is this? This velocity is v. This velocity is going to be v. This is not stretched only initially. Then later on, this mass will be here. This mass will be here. They both will be at rest. There is some extension. So I can say the kinetic energy of both the blocks goes into the spring potential energy eventually. What's the kinetic energy? Half into m into v square, 2 blocks, so into 2. Spring energy half k x square. Half cancels. So 2 times mv square is equal to k x square. The question is elongation. So x square will be 2m by k into v square. Therefore, x will be v root 2m divided by k. Velocity not given. Mass, is it given? 250 gram. 250 gram is 1/4 of a kg. Spring constant 2. 2 cancels. So it will be nothing but v root 1 by 4. 1 by 4's root is nothing but 2. So v by 2 should be the answer, which is option B. Yes, that is the correct one. B option. Correct, Siva Prasad. Very good. Disaster. Thank you, V Enthuse Club. And I'll always be the motivation for many, many years to come. That is the whole ambition of mine. All right. Okay, let's move on to the next one. The next concept is of center of mass, where you will be given standard geometries or some masses are placed here and there, and you are asked where is the center of mass. If there are point masses, then the formula is very simple. You multiply each mass with their coordinate, add them up in the numerator, divide it with the total mass, you will get the coordinate of the center of mass, whether it is x, y, or z. Now, if you know standard geometries, it will be very, very helpful for you. So let me put up some standard geometries right over here. Like for example, if you take a triangle, doesn't matter, scalene triangle. Okay, so the center of mass, is at the centroid. Center of mass is at the centroid, and the formula for centroid is x1 plus x2 plus x3 whole thing divided by 3, comma y1 plus y2 plus y3 whole thing divided by 3. What is this x1, x2, x3, etc.? These are the coordinates of these 3 points. So it is always at the centroid. This is a laminar sheet. Please understand that it is not a frame of wire. It is a triangular sheet. The center of mass is always at the centroid. Okay, standard spheres, squares, etc., it is always at the geometrical center. Next thing, obviously, for a solid cone, the hollow cone, the formula is as follows. For solid cone it is h by 4, for hollow cone it is h by 3. From the base, everything is circular from the circular base. Similarly, you have a solid hemisphere, half of a sphere, because complete sphere I know it is at the center. Solid hemisphere, and then you have hollow hemisphere, which looks like a bowl. Hollow hemisphere, empty bowl. Okay, so the formula for center of mass is as follows. For solid it is 3r by 8, and for hollow it is just r by 2. This is also something which you should remember. Then you have this. If you have an arc of a circle, this is just an arc of the circle of a radius r. The complete angle is, let's say, theta. Then the center of mass will be, let's say, somewhere over here. Center of mass will be somewhere over here. So distance, this distance is given by r sine theta by 2, the whole thing divided by theta by 2. That is the formula. But instead of an arc, let's say it was a complete sector. That means it is like a pizza piece. It is like a piece of pizza, like this over here. Then the formula is slightly different. But it looks very similar to this same thing. R sine theta by 2 by theta by 2. Just put 2 by 3 number over here. Just put the number 2 by 3. That's all. Then you will get back the answer. I hope this is absolutely clear. Everyone till this point? Awesome. Great. All right. Now, next thing. Whenever you have two or more bodies making up another body, like for example, some object is there, let's say over here, and another object is, let's say, over here, and each of them have their center of masses here. This is body number 1, this is body number 2. Then together what you get is a composite body. Together what you get is basically called as a composite. That means it is made up of multiple body. Then the center of mass of that composite body is given by, you take mass 1 of the first body into coordinate of the first body, and then you add it to the mass of the other body into coordinate of it upon m1 plus m2. That's it. That is how you find the center of mass of a combined body. But then the other way around is, imagine you have a big body, let's say the mass is m1, and from that you take out certain mass. Let's say over here. So this is the cavity which you create, and that cavity's mass which was taken out is m2. So whatever is remaining is this shaded part. So this is that shaded part. So you have taken out something from another body. So this is called as truncated bodies. not composite, truncated bodies. The formula for center of mass in such a case, is given by, here you will put m1x1 as it is, but instead of plus, you will put minus m2x2, and here also m1 minus m2. So that's the only difference in the formula. Is that okay, everyone? So the center of mass of the cavity could be here. Center of mass of that whole big body could have been here. Center of mass of that composite, or the remaining body could be here. That's how it goes. Understood? Clear? All these formulas, please remember it. Let's start with some questions. Oh, this formula is also important, where you shift things here and there. So let me write it down over here. So whenever it is given that the center of mass is not moving, or it is found that it is at rest, that is net external force is 0, center of mass is not moving, then, or basically velocity of center of mass is 0, center of mass is at rest, then you can say that mass number 1 into displacement 1 plus mass number 2 into displacement 2, mass 3 into displacement 3, that sum will always be 0. m1 s1 plus m2 s2 plus m3 s3 plus m4 s4, like that, is 0. What is this s1 s2 s3? Mass 1 moved here, mass 2 moved here. How much will the third mass move? So those sort of questions can be solved using this particular equation. Okay, most of the questions you will see are also going to be that kind, like the one over here. See this. There are two masses, 10 kg and 30 kg. They are along a line, and then 10 kg is moved by 6 centimeters towards the other block. How much will the 30 kg move? Assuming the center of mass of the system is unchanged. Assuming the center of mass is basically unchanged. Okay, come on, my dear warriors, think about it. Okay. What can I just do to qualify, Sai Nandesh? Attend this class, concentrate on heavy weightage topics. Just qualify means 120 marks safe score, but sometimes 110, 100 will also do. But on the safety side, 120, that means 40 marks per subject. That means bare minimum 10 questions should be correct. If you have tendency to make mistakes, that means you should solve around 13 questions. So maybe 3 questions go wrong here and there. So around 90, 93 percentile you should get. Okay, 92, sorry, you should get. Cool. All right. So let's see, how do you solve this particular question? As you can see, the 10 kg mass, is moved towards the other mass by 6 centimeters, and that 30 kg mass will be moved by some amount which I do not know. I'll call it as S2. In fact, that is what is asked. It is clearly mentioned that their center of mass is at rest. So m1 s1 plus m2 s2 will be 0. So mass 1 is 10, distance is 6, mass 2 is 30, distance I do not know. So from this, 30 s2 will be minus 10 multiplied by 60. 30 goes with 62 times, so minus 10 into 2, which is minus 20. Don't worry about the negative sign. Negative means it is towards the left side by 20 centimeters. Sign is given, means it is direction. That's all. So the answer is, did we make any mistake? Oh, it is in meters. So, oh no, it is in centimeters only. Did we do something wrong? I think some factor of 10 is missing. Just check this out. Mass 1 10 kg, another mass 30 kg. Okay, 30. And oh, I know what I did. 6 into 10 is 60. There was no need of putting that 10. I'm so sorry, guys. It was already 60, had already multiplied it. So this would be just minus 60. So S2 will be just minus 2. Yes. So minus means it is towards the left. And by how many centimeters? 2 centimeters. Yes. So 2 centimeters towards the other block. That is the correct answer, which is option C. Very good. Okay. Yes. It was 10 into 6. I had already written it down. Correct. Okay. Moving on to the next question. There is a disk of mass m with surface mass density as shown. The center of mass of the quartile disk only this part is asked. The coordinates are this and this. What is that x value in the nearest integer? Very nice question. This is like the sector. This is like that sector. Come on. Like the pizza slice. 100% the center of mass will be on the angle bisector somewhere over here. Maybe this is where the center of mass will be. This is, let's say, the distance d. And that distance d can be found out by 2 by 3 r sine theta by 2 by theta by 2 formula. Is the radius given? I think the radius is given. Oh, radius is given to be a. Yes, the radius is given to be a. So a will be here. What is theta? Observe carefully. This is theta and this complete angle. Don't ignore this theta over here, which is basically 90 degree or pi by 2. So hence it will be nothing but sine of pi by 2 by 2. Theta itself is pi by 2. So this theta should be pi by 2 by 2. Okay, so what do I get? 2a by 3. Sine of pi by 4. Sine 45 is 1 by root 2. Okay, into this will be pi by 2 is 4. So 4 goes on the top. So this will become 4 to the 8. 8a divided by 3 pi root 2. That is what that distance from the center will be. But that is not the question. Say this distance I know. Okay, this is your x-axis. This is your y-axis. By symmetry, this will be at 45 degree and the x coordinate and y coordinate is asked. So this will be the x coordinate of the center of mass and this will be the y coordinate of the center of mass. Obviously, because it is 45 degree, this distance and this distance will be equal. So x cm will be equal to y cm, which will be how much? This cos 45 or sine 45. So d cos 45 or sine 45 is one and the same thing, which will then be d value is over here, which is 8a by 3 pi root 2. Cos 45 is 1 by root 2. 1 by root 2 into 1 by root 2 is 1 by 2. So 3 pi multiplied by 2. 8 goes with 2 4 times. So 4a by 3 pi. So 4a by 3 pi, I think the value of x is going to be 4. Yes, the answer is 4. Perfect. That's it. That is the correct answer. Loved the question, guys. Amazing. Yep. Very good. Very good. Awesomeness. A is not the area. That is what is given in the question. No. Is it? No. A is the radius. Oh, A is an area. A is an area as shown in the figure. Oops. Then how come we are getting that answer? If A is the area, I think while marking, they have marked it as the radius, but while finding the answer, also they have taken it as the radius. But if you find it in terms of area, then how you will have to do it is means you'll have to say area is equal to pi a square as per the variables given. So a will be a by pi, the whole thing under the root that you have to put, but doesn't seem to be right. So I think this is not the correct assumption. It should have been A is the radius of that shaded figure, something like that. It should have been. So I don't think this should have been here. So I'm just removing it because the answer is perfectly matching. I think there was some mistake while printing it over here. A is the radius of the shaded figure. That's what it should be. Okay. All right. All right. If anything explodes, Sanjay, then what will happen is basically, the center of mass will stay intact. Again, you can use the same formula which I have given over here. One mass moves this much, other mass will move how much? First mass moves S1, other mass will move S2. If there are three particles, then you can find S3 if S1 and S2 is known. So for explosion problems also, you can use this because center of mass will stay there because the explosion force is an internal force, not an external force. So external force is still zero. So this is applicable. Is that okay? All right. Moving on to another question coming up on your screen. Here it is. Yes, this is more than enough, Ramchandran, but also attend my mock test, which we are doing every day. Yeah, what is the answer for this particular question, my dear students? If there is a truncated body, you have removed this part, then find the mass of the center of mass of this following remaining thing. The radius of the original disk is smaller. Okay, so let's see this. The original disk, this particular distance, okay, this particular distance is basically r. So this whole thing obviously is going to be r. So the center of mass of that big disk is over here. This is where the center of mass 1 is. The smaller mass which has been removed is this one. Okay. And the center of mass of that smaller mass which has been removed is over here. And that distance as measured from the origin, if this is r, this will be r by 2. Okay. Now the shaded part, the center of mass will be somewhere over here. So we have to find this. So XCOM will be nothing but as simple as M1 x1, here M1, and then you have minus M2 x2 minus M2 over here. That's what it will be. But the masses are not given. That's the problem. And these are nothing but what is it? Disks. Okay. So for a disk, which is a planar body, the mass per unit area will be constant. So use that concept now. So mass per unit area will be the same everywhere. So if I take the big disk, the mass is m1, the area of that big disk would have been pi r square. This will be equal to that small disk which was taken out, the mass was m2, upon the area will be pi r by 2 whole square. So pi r square cancels. So m2 divided by 1 by 4 will be on this side equal to m1 divided by 1. So what is the value of m2 going to be? M2 will be 1 by 4 goes on the top, it will be m1 by 4, or m1 will be 4 times of m2, one and the same thing. So you can put 4 times, that will be easier I think to solve. So mass number 1 will be 4 times of m2, okay, 4 times of m2 into x1. Coordinate of the center of mass of the big disk will be at the origin, so into 0. Okay, this again m1 is nothing but 4 times of m2 minus m2 below, here minus mass number 2 as it is. Coordinate of the center of mass of the smaller disk is r by 2, so r by 2 over here. So let's see now what do we exactly get. This is 0 minus, I can see very easily m2 cancels out everywhere, so I'm just left with minus r by 2 divided by 4 minus 1. So minus r by 2 by 3. So 4 minus 1 is 3. So minus r by 6. So this coordinate is r by 6. That should be the answer. Correct. Minus r by 6. Perfect. We got it. That's how you solve these kind of questions. Is that okay, everyone? Awesome. All right. All right. Moving on to the next one. Hey, lunch break. Hold on, man. I'll give you. Hold on. Collision related questions. All right. So, always for collision, remember if net external force is 0, then the total momentum initially will be the total momentum finally. That is one thing. Okay. Momentum is always conserved. Momentum is always conserved. That is a standard fact even in explosion, but it is the energy which may not be conserved, and for that you have something called as the coefficient of restitution. So the coefficient of restitution is given by relative speed of separation after the collision upon the relative speed of approach before the collision. And this value of E will decide whether energy is conserved or not. So when E is 1, that means numerator is equal to denominator. That means approach is equal to the separation relatively. Then the initial energy is equal to final energy, and then there is no loss. That is the first particular scenario that you can have. The next scenario is where E is less than 1 but more than 0. It is called as inelastic collision. Inelastic collision. Here the final energy is less than the initial energy. There is some loss. There is definitely some loss which is going to happen. By the way, this collision was completely elastic collision. The last is basically a perfectly inelastic collision. Perfectly inelastic collision where E is equal to 0. So after the collision, they usually stick together. They usually stick together, and the final kinetic energy is obviously less than initial energy, and there is maximum loss of energy. There is maximum loss of energy. So these are the things which you should consider while solving collision problems. Not just that, sometimes there might be questions on impulses. So impulse, remember, is change in momentum. Impulse is change in momentum, and the quantity is a vector quantity. So it is actually final momentum minus initial momentum. But sometimes you can find the momentum by graphical or integral methods, where you might be sometimes given a graph of force with respect to time, and maybe that graph is something like this. Then if you consider the area under the force versus time graph, that integration, which is force with respect to time, that from T1 to T2 will also be the impulse. So it is nothing but area under the force versus time graph. Remember, whatever is here will be positive area, this will be negative area. This will be positive area. Whatever is on the top is positive, whatever is below is negative. Sometimes there can be impulse related questions also. All right, so let's solve some questions now. Here it comes. Okay, first question, only graphical question. 2 kg mass is at rest. A force acts on it. Magnitude changes with time. The force time graph is as shown below. What is the velocity after 10 seconds? See, if this was force with displacement, I will calculate work and I will use work kinetic energy theorem. But if it is force with time, I will do it with the impulse method. I will do it with the impulse method. Got it? Awesome. So how do we do it? Okay, come on, everyone. G Jyoti from Andhra. Some of you are from Tamils, Anandu. Very good. Anybody from Karnataka? Anybody from Kerala, Maharashtra? Please let me know quickly in the chat box while you're answering. Thank you, R. Sanjay. Thank you. So, whenever we have force time graph, we will obviously find the impulse. Let's start with finding the area first. Okay, so there are too many areas over here. So let's go step by step. I mean, first things first, this one, it's a small triangle. It will be half into base into height, which will make it 10. This is a rectangle, 2 into height, which is 10, which will be 20. Okay, then again, this is a trapezium. So trapezium means half into parallel sides addition. So height is 10. One side is 10, another side is 20. So 10 plus 20 into the distance between the parallel sides, which is nothing but 2. Okay, so this will be 10 plus 20 is 30. 2 cancels. So this is 30. This area will be half into base, which is 4, into height, which is 20. 4 by 2, 2. 2 into 20 is 40. So what is the total area then? It will be 10 plus 20 plus 30 plus 40. 10 plus 20, 30, 30 plus 30, 60, 60 plus 40, 100. So 100 is the complete area. Okay, so once we have this, we can do the next part. Impulse is change in momentum. Impulse is nothing but the area under a force time graph, which is 100. Change in momentum is nothing but final minus initial momentum. Final momentum is mass into final velocity. Initially, it was at rest, clearly mentioned over here. All right. So therefore, VF is 100 divided by 2. Hence, it will be 50 units. So I think it should be answer D. Yes, it is correct. Very good. Option number 4, option number D. Awesome, Thiash. Happy Pongal, Jacinth. Happy Pongal, Disaster. Very good, Sachin. Very good, Anandu. Very good, Harborine. Awesome, awesome, Tharshan. Awesome. Very good. Girish, Ashwin. Thank you for all the love from Tamil Nadu Disaster. Okay, shall we go ahead to the next question then? Here we come. 50-gram bullet moving with some speed gets inside another body. How much is the loss of kinetic energy of the system? That is the question. All right. So first of all, let's draw the diagram. This is essentially 50 grams and it is moving with 10 meters per second. There is a big box which is, let's say, at rest, and the mass is 950 grams. After the collision, what will happen? It will just become one big thing with the bullet inside, okay, and it gets embedded in it. This will become 1000 grams. 950 plus 50 is 1000, and it will now move with a new velocity. So yes, it is a perfectly inelastic collision, but momentum is conserved. So mass into velocity plus mass into velocity, it is at rest, is mass into velocity. So this will become basically 500 is equal to 1000 V. So V will be 500 by 1000, which is basically 0.5 meters per second. Now that's not the question. The question is find out the loss in the energy, percentage loss. So percentage loss will be initial kinetic minus final kinetic upon initial kinetic into 100. That's the change upon original. Change upon original is the loss of the percentage energy. Initial kinetic energy is half, mass is 50 grams, into velocity is 10 square, minus final kinetic energy is half, 1000 grams, into velocity, which is 0.5 square. Whole thing divided by half into 50 into 10 square. This whole thing into 100. Now, I know some of you will be thinking, sir, why did you not convert the grams into kg? Yeah, I could have, but it is unnecessarily going to be meaningless because, like, sir, how can you multiply grams with meters per second? I know technically I shouldn't, but I have a smart move here. I know if it is grams here, grams here, grams here, eventually it will get cancelled. Eventually, eventually, it is going to get cancelled. So I don't really care whether it is grams or pounds or some other quintals or tons also. Okay, I hope this is absolutely clear. So therefore, I can solve this easily now. Half cancels out. 50 into 10 square, so two more zeros, minus 0.5 square is 25.25. So 0.25, that means it will become 250 over here. Whole thing divided by half has got cancelled out. So 50 and two more zeros into basically 100. So 5000 minus 250. Okay, by the way, these two zeros will cancel. 5000 minus 250 is 4750 divided by 50. 0 cancels. 475. 475 divided by 5. Come on, my dear warriors. 475 divided by 5. How much is it going to be? How much is it going to be? 95. Yes, 95%. Just check this out. 95%. That should be the answer. Yes, that is the correct answer. That's how you solve this. Very nice. These kind of questions are very common. This is also a very beautiful question where there is a block. It's coming towards another rest block which has a spring attached. That block hits the spring will start compressing, and the question is, what is the maximum compression? Right now, what is the speed? It is 2 meters per second. This block has 1 kg, and the rest block, each of the blocks has 1 kg. Okay, even this has 1 kg. Eventually, what will happen is, what will happen is, this spring would be compressed by X. This has been compressed by X. And because this is maximum compression, that means both the velocities will be equal. Now, this is a concept which many people take some time to understand also. Why should Maximum compression means velocities are equal. See, think in terms of relative velocity. Imagine you are sitting on this block. You will see you are at rest on this block. The other block is coming. It hits me. So I start moving. That's okay. I don't realize my motion. But for my relative motion, that block will come close, 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 stop. And then it will start moving away. So that block from the back is coming and going behind. So when it stops, that's when the compression is maximum. When it stops with respect to me, when that block comes and stops with respect to this observer, it stops, means relative velocity is zero. That means both velocities will be same. So very, very crucial thing. So if one considers relative motion, the relative motion is zero at maximum compression. At maximum compression. Hence, therefore, both of them have same velocity then. Both of them will have the same velocity during the maximum compression. Got it? Everyone? Yeah. So, what energy went into what energy? It's a question on energy conservation now. You can see there was initial kinetic energy, there was no spring potential energy at all. It went into final kinetic energy and some spring potential energy. Initial kinetic energy is half mass into velocity square, nothing else is there. Finally, both the masses have the same energy, half into 1 into v square, but 2 times. Why 2 times? Because there are two blocks. Spring energy half k, spring constant is 50, so 50 multiplied by x square. You just have to solve this now, it's not that difficult. 2 square by 2, that's going to be just 2, is equal to 2 cancels, so you just have v square. Oh, but wait a minute, I don't even know v square. Plus 50 by 2 is 25 into x square. The problem is, what the hell is this v? Oh, now comes the logic of momentum conservation. Momentum has to be conserved. Spring is an internal force. Yes, momentum can be conserved. Net external force is zero. So momentum is going to be conserved. Is going to be conserved. So initial momentum is mass into the velocity. The other block was at rest. Other block was at rest over here. Finally, both the masses move together. So mass is 1 into V plus mass is 1 into V. So therefore 2 is equal to 2V. Therefore V is equal to 1. Oh, so that's how I get the velocity. Substitute it back over here. Substitute it back over here. So 2 is equal to 1 square plus 25x square. So 1, 2 minus 1 is 1, is equal to 25x square. So x square is 1 by 25. So x is equal to 1 by 5 of a meter. So x is equal to 20 centimeters. So 20 centimeters or 1 by 5 meters or 0.2 meters, everything is the same thing. Got it? Everyone? Electrostatics or ray optics? Ray optics as compared to electrostatics is little smaller. Electrostatics needs even more knowledge, okay, of other chapters like energy, work, Newton's laws, vectors, all that. Ray optics completely independent. Ray optics is also big, electrostatics is also big, if you consider Gauss law and all of that. And it has many more concepts than ray optics. Ray optics is that way simpler than electrostatics. But some people might differ in opinion. They will be like, no, sir, I find electrostatics easy. That's because you have done gravitation properly in 11th standard. That's the only reason. Or maybe you know the basics very well. Okay? All right. Can you do it by reduced mass concept? Yes, you can do it, but it might be often confusing how to use that concept when you don't have complete understanding of it then. Okay, the next concept of moment of inertia. Moment of inertia is the equivalent of mass but in rotation, and it depends on three things. How much mass you are rotating, which axis about you are rotating, which axis is rotated, okay? And third thing, how far are these masses from the axis? Maybe the axis is same, the masses are close or far apart. If it is far, it is very difficult for it to rotate. If the masses are close, it's very easy to rotate. So it depends on all these three factors, and it is the equivalent of mass but for rotation. The formula is sigma summation mass 1 r square, mass 2 r square, every mass multiplied with the distance from the axis of rotation. You also get a concept of radius of gyration. which is if there is a body which is rotating, every mass is at different place. So you find the moment of inertia of that big body. Radius of gyration is that particular place or that distance from the axis where you can combine the entire mass of the body into a singular point and it will possess the same moment of inertia. So you melt the entire body, condense it into a point mass, and you rotate it along the same axis. So that distance, which will give the same inertia, is the radius of gyration. So radius of gyration is again mk square. Okay, so radius of gyration is given by the formula mk square. K is the radius, I is the inertia, m is the mass. Cool. These are the main things. All right, all right. Perfect. Now, standard moment of inertias of standard bodies. You should know this. Like for a ring, mr square. For a disk, mr square by 2. For a rod, when it is rotating about center, yes, a rod about the center, ml square by 12. But if you take it and spin it about the end, using parallel axis theorem, you get it as ml square by 3. Be careful. All right. Then if you have a solid sphere, it is 2 by 5 mr square. If you have a hollow sphere, then it is 2 by 3 mr square. 2 by 3 mr square. Keep that in mind. Then if you have a rectangular plate, imagine a plate and that plate is rotating about an axis perpendicular to the plane, then it is ml square by, sorry, m by 12 a square plus b square. Height, length square, you can add it. That's the formula for a plate which is rotating. Now, if there is any other axis, you have no other choice but to use the theorems. One is parallel axis, one is perpendicular axis theorem. So first is that parallel axis theorem, which says that moment of inertia about parallel axis is moment of inertia about center of mass plus the mass of the body multiplied by how much you are shifting it by square. Okay, so this is the first formula. So if there is a mass here, this is the center of mass. Maybe I know the moment of inertia about this axis, so moment of inertia about center of mass. Now you want to rotate it about this axis, so this is the parallel axis. That means you have shifted it by this much distance. So this is the distance by which you have shifted it. That's how you can use this formula. The next one being the perpendicular axis theorem, where you can only apply it to planar bodies or laminar objects. Planar means two-dimensional bodies only. So maybe I rotate it once about this particular axis. Let's say the moment of inertia is I1. Then I rotate it about this particular axis. The moment of inertia is, let's say, I2. This may be center of mass, may not be center of mass, doesn't matter. Center of mass concept only comes for this, not for this. You draw a perpendicular axis. Perpendicular means like this. Okay, it goes like that. So this perpendicular axis moment of inertia will be the sum of I1 and I2. I1 plus I2. This is called as the perpendicular axis theorem. Got it? So perpendicular axis theorem only for planar objects. Parallel axis theorem only, it can be for any object, but one of the axes must pass through the center of mass. Here there is no such condition for center of mass. Keep that in mind. Okay, perfecto. Can I take a screenshot? Definitely, Rakesh. Why not? You can definitely take a screenshot. Let's see if you can solve this question. Come on, try to solve this question. The value is 2 is to root x. What is the value of x? Root x has shifted here. Some formatting issue. All right. So let's do this. What is it? Solid sphere and solid cylinder. For a solid sphere, the moment of inertia formula is 2 by 5 mr square. If I equate it with m K of that solid sphere square, will cancel. K of that solid sphere will be r root of 2 by 5. Similarly, if I find the moment of inertia of that solid cylinder, cylinder, it is the same as mr square by 2, which is like a disk. This I can write it as what is this? The radius of gyration of that cylinder square. Cancels, so K of the cylinder will be R by root 2. And the question is all about the ratio of this. So K of the sphere by K of the cylinder, just take these two things and divide it. R root 2 by root 5 divided by R by root 2. R cancels. Root 2 will multiply with root 2 and I will have root 5 here. Root 2 into root 2, 2. So 2 by root 5. So this should be obviously root 5. Hence that X value is 5. Perfect. That's the correct answer. Cool. Many of you gave the answer as 5. Very good, Kiyash. Very good. Nagan Shri. Very good, Srinivasa. Awesome. Awesome. Asif, how much time? My God, I don't think we have even reached half of the session. I hope you agree with this. Yeah. Can you tell the conditions for with and without slipping the beta values? Kirtana, I'll just tell you with or without slipping. What do you mean by beta values? You are asking the condition for slipping and not slipping. See, if it is not slipping, simple. V is omega r, and the point of contact does not move with respect to the ground at that instant. If it is slipping, V will not be equal to omega, either it will be more or less, and the point of contact will have a relative motion. That's all. Choose the correct answer. Moment of inertia, solid sphere, about any tangent. Oh my God. Everything is about some axis, which is different. So moment of inertia of a solid sphere about a tangent. I know about the center of mass. It is 2 by 5 mr square. So plus, I have to shift it by r. So plus mr square, because this is the tangential axis and this was the center of mass. So that will be 2 by 5 plus 1 is 7 by 5 mr square. Just check this out. Is 7 by 5 mr square. So definitely goes with this option 2. Is that right, everybody? With me on this? Clear? Okay. Next. Yep. Next. A is going with 2. So automatically D option gets eliminated. And even B option gets eliminated because A is with 2 is only there in these two options. Now, B is with 1. So both the options will give me again that confused result. But C option or D option can give me clarity. C option is moment of inertia of a ring about tangent and moment of inertia of a disk about any diameter. Anything you can go. Let's say I go with the D option. So for the D option, moment of inertia of a disk about any diameter. So if you take a disk, this moment of inertia I know it is mr square by 2. About the diameter I do not know. Let's say I call it ID, any diameter. These two axes are in the plane and it's a 2D object. I can use perpendicular axis theorem. So it will be ID plus ID. Therefore, mr square by 2 is 2 times of ID, or ID is mr square by 4. Mr square by 4 is third option. So D will go with the third option. D will go with the third option, which is over here. So this can't be correct. This automatically gets eliminated. So C option is also eliminated. So hence answer will be A. Hence the answer will be A. So that's how easily you can solve match the following. You don't have to sit and solve every option. Just see which options are leading to clarity. It should not lead to confusion. I hope this is very, very clear. Very nice. Awesomeness. Let's move then to the next question coming up on your screen. Yes, angular momentum conservation comes many times. Remember, angular momentum, if you take for a particle, the formula is mass into r, distance from the axis, into the velocity. But if you take angular momentum of a big body, which is many particles, it is moment of inertia into angular velocity. Now, if it happens that from outside the external torque is absent, then then angular momentum is conserved. Angular momentum is conserved. That means the total angular momentum initially will be the total angular momentum finally. Usually it might happen like disk problems are there. A disk is touching another disk and all of that. So, or a moment of inertia has changed. So I1 omega 1 will be equal to I2 omega 2. These kind of problems can come in your examination. There is a person who is holding his hands close by, inertia is I. He stretches his hands, moment of inertia becomes double. So if inertia becomes double, angular velocity will become half. So those questions are also again standard questions. All right, let's see some questions on this. There is a disk of inertia I and it's perpendicular to the plane. It is rotating with omega speed. Another disk 2I rotating with double the speed in opposite direction. If they are combined together, what's the final speed? What's the final angular speed? How to find moment of inertia of truncated bodies? Exactly the same way as center of mass, just I1 minus I2. Just I1 minus I2. So basically, if you ask me over here, moment of inertia of truncated bodies, imagine there is a body here like this, and from that you have taken out this particular body. So this body about, let's say maybe this is the axis about which you are rotating it. If you know the moment of inertia of that big body, it is I1, and the cavity which is removed about this axis is I2, then whatever moment of inertia is there of that remaining shaded figure over here, right? That moment of inertia will be simply put I1 minus I2. It will be just I1 minus I2. Just the essential condition is everything about the same axis. About the same axis. You cannot change the axis. For the yellow thing, the axis is not this. The axis is this. So you might have to use parallel axis theorem and all of that. Okay. So most of the times it involves parallel axis theorem. So keep that in mind. Okay. The axis should be the same for everything. Okay. All right. Let's solve this question, which I just gave it to you. All right. So let's draw the diagram. It will be very easy. Imagine a disk of moment of inertia 2I and it is rotating like this with 2 omega. Another disk is of moment of inertia I. It is rotating with omega. Now you combine both of them. Okay. So basically what happens is one disk will be on top of another disk. The moment of inertia will be 3I. And this is higher speed, higher inertia, so that will dominate. So this will be the final angular velocity. So conserve the angular momentum, that's it. Conserve the angular momentum. Initial angular momentum will be I into omega. This is the first body's angular momentum. I into omega for the second body. Both of them are opposite in direction, so put minus. Okay, why is this minus? They are in opposite directions. That's the reason for it. So this will become 4, this will become 1. So this will become 3I omega. This will be equal to, on this side, total moment of inertia 3I omega. 3I into omega final. So this will be 3I into omega final. So what will omega final be? I cancels. I think 3 also cancels. It will just be omega. Wow. Yeah. So that is the answer. The answer will be omega. I think the answer was not printed, but yes, the answer will be just omega. Is this absolutely clear? Everyone, till this point? Shall we move ahead? Okay, very good. Let's move. Next question. Yes, gravitational force, energy, and escape speeds. Awesome. Let's go. First of all, gravitational force between two masses. Gravitational force between two masses is very similar to electrostatics law, and that force is given by G m1 m2 by the separation square. It's like the inverse square law, right? Now, if you find the gravitational field due to gravitational force, the field is the force by mass, just like the electric field. So gravitational field, I think the symbol used over here is wrong. Don't use this symbol, use E. Gravitational field is force per unit mass. It is gm by r square. That is why the unit also will be Newton per kg. Yeah, gravitational field will be the force acting per unit mass. The properties of the field are very similar to electric field concept or magnetic field concept. Okay, so the field will give me the direction of the force acting on a unit test mass and all of that. Now, next concept, if there are two masses, if there is an interactive force, it will also have an energy between them. The interaction energy of two masses, which is also called as the gravitational energy, is given by negative gm1 m2 by r, not r square. If it is r square, it will become force. If it is energy, it will become r. Keep that in mind. Negative energy, very important, only for gravity. For electrostatics, that negative sign does not come. In fact, these negative signs only come when the forces are attractive. Even in electrostatics, if you have a positive and a negative charge, the total energy becomes negative. If you have two negatives or two positives, it will automatically become positive potential energy. Is that okay? Okay. Yes. Lunch break, Kodtini. Lunch break will be given. Just 1 second. Let me just complete gravity. Okay. After gravity, we'll have lunch break. What say, guys? Yes? All right. All right. Now, just like any other problem, you can conserve energy. So, whenever two planets, one planet, one sun, one planet, one moon, anything, two heavenly bodies are moving towards each other, or you throw a mass, whatever, you can use energy principle. You can use this potential energy formula to find out anything, to find out kinetic energy, speed, etc. And one such calculation is done for escape speed, meaning you throw a mass from the surface of the planet and it should never ever come back. That means after it goes to infinity, it should stop. That means when it is very, very far away, kinetic energy becomes negligible. So that speed with which you should throw so that it never comes back is the escape speed, which is root 2 gm by r. And this happens because as it goes towards infinity, as it r tends to infinity, then the potential energy of infinity becomes 0 and the kinetic energy at that infinity also becomes 0. This r is, don't confuse, this is not the radius of the planet, this is the distance from the planet. This r is the radius of the planet, this is the mass of the planet. Escape speed is independent of the mass of the object. Very, very important. It is also not dependent on the angle at which you throw it. Yes. Free pie lunch break after this particular thing. Okay. Yeah. Very cool, Ninja. Yes, I know. Some people, what to do? They think that if you delete the chat, I cannot see. Ayo, I can see the chat, man. The admins also can see the chat. Not just me, the admins who are behind also can see the chats. Okay, let's solve. There is some mass taken from the surface to a height equal to double the radius of the planet. The change in the energy will be how much? Where g is the acceleration due to gravity on the surface. Okay, so this is the planet. This is that radius. Earlier, the mass was here, and now you have taken it to a distance of 2r and you have brought it over here. So this is the initial point. This is the final point. What is the change they have asked? Initial energy, well, the mass is separated by distance of r. So it will be negative gmm divided by r. Finally, it will be negative gmm. The total separation will be r plus 2r, which will be nothing but 3 times of r. From this, I will get the change in the energy, which is final minus initial. So minus gmm by r is common. So 1 by 3 is over here, minus 1 by 1 is over here. That's it. Is that right? Minus, oh, minus sign is already taken common, so no need of doing that. Minus 1 is over here. Okay, so this will become minus gmm divided by r. 1 by 3 minus 1, or 1 minus 1 by 3 is 2 by 3. So this will be minus 2 by 3. Okay, minus minus becomes plus. So it will become 2 gmm divided by 3 times of r. But none of the options are matching. What to do? No issues. We know one more thing. On the surface, the acceleration due to gravity is gm by r square. So gm is basically gr square. So use this substitution over here. So this will become g r square, rest of the things as it is. So 2m over here divided by 3r. RR gets cancelled and I'm left with 2g mr divided by 3. So 2 by 3 mgr. 2 by 3 mgr is right as option C. Yep. Very good. Awesome. Happy Pongal, Moganthi. Happy Pongal, happy Pongal. Yeah. Why can't we use U is equal to mgh? Girish, you only tell me why we can't use mgh. What is the problem? Many people will use that, I know. Why we can't use? Because that formula is only valid for small heights. G should be constant. When you go for a height which is double the radius of the planet, do you think G will be constant? No, right? So that formula is only for few meters, maximum 2-3 kilometers, 10 kilometers, okay. But when it is thousands of kilometers, you can't use it. Next, escape speed of two planets are in the ratio 1:2. If the ratio of the radii respectively is 1:3, then the ratio of the acceleration due to gravity of planet A to the acceleration of planet B will be how much? Yes, come on, let's try to solve this. Escape speeds, ratio of radii, ratio of the acceleration of the planet A. So acceleration of planet A upon acceleration of planet B will be g mass of A by radius of A square by g mass of B upon radius of B square. G cancels, so it will become MA by MB and it will become RB by RA the whole square. I think the ratio of the radii is given to be 1:3. So this is 1, this is 3, this is squared. I just don't know MA by MB. No issues. We can use this information. Escape speed of planet A by escape speed of planet B will be root of 2g mass of planet A by radius of planet A upon root of 2g mass of planet B by radius of planet B. Okay, escape speed ratio is 1:2. So this is 1:2. G 2 cancels. So it will become root of 2 times mass of A upon mass of B, and here it will become RB by RA. The ratio of the radii is 1:3, so this will become 1 by 3. This will be root of MA by MB. This is nothing but 1 by 2. Therefore, mass of A by mass of B, whole thing under the root, will be 3 comes below. So 1 by 2 root 3. Therefore, mass of A by mass of B will be square of this. So 1 by 2 square root 3 square will be 3. So 2 square is 4, 4 3s are 12. So 1 by 12 over here. Okay. So MA by MB is 1 by 12. So how much will this come out to be? So 3 square is 9. So 9 by 12. 9 by 3 is 3. 12 by 3 is 4. So 3 by 4, which is D option. Correct. That is perfectly fine. Got it, my dear students? So it's a slightly lengthy problem, but it is a good problem. It is a very good problem. Very good. Awesomeness. Awesomeness. Next question. Radius of the earth and the acceleration rg is equal to pi square. Then the length of the second pendulum at height equals to 2r will be how much? Very interesting question. Very good. Radius of the earth is r. Acceleration due to gravity on the surface is g. What is the length of the second pendulum when the height is 2r? Now, remember, for a second pendulum, when you use the time period formula for a pendulum, which is 2 pi root L by that g at that height, I just need to find out how much is this length. Because it is given to be a second pendulum, the time period will be 2 seconds. So just put 2 here. This is pi. I don't know L. What is that gravity at height h? The gravity at height h is given by the formula g r square by r plus h whole square. So g is g, r is r, okay. R plus, actually g is not g, g is given to be pi square. Look at that. So it is pi square, r square as it is, r plus h, h is 2r. So this is 2r whole square. So this will be pi square, r square, 1 plus 2, 3, 3 square is 9. So 9r square. R square cancels. So it will become pi square by 9. So put this as pi square by 9. what will happen? Pi square becomes pi, pi cancels. So I will be just left with n 9 times of L, which is 3 times of root L. So root L will be 2 by 3. Therefore, L will be 2 square by 3 square, which is 4 by 9, which is 4 by 9, which is D option. I think 1 by 9 was wrong. Just check this out. It should be 4 by 9 of a meter. Yes, everyone? Yes, 4 by 9. Awesome, awesome. Yes, it should be 4 by 9, not option A. Yes, the math session will be there tomorrow or day after tomorrow. So next 2 days is chemistry and mathematics. Yes, perfect. Oh, I think I made a mistake somewhere. Yes, I know where I have made the mistake. That number 2. I'm so sorry, guys. This time period was 2 seconds. So this is 2 pi root of L, which I don't know, by GH. GH was pi square by 9. 2 cancels. So I'll be getting 1 is equal to pi root L multiplied by 9 pi square. Pi square cancels. So it will be root of 9L. So 1 square will be 9L. Therefore, L will be 1 by 9 meters. So I think this should be the correct answer then. Yes, it is. Perfect. Yeah, I think I didn't cancel the 2 before. Yep. How time period became 2 seconds? Seconds pendulum. Seconds pendulum means what? It goes like this, tick, and it goes like this, tock. So tick is 1 second, tock is 1 second. So tick tock is 2 seconds. That's a seconds pendulum. Got it? Sachin, Pakka? Yeah. Awesome. Next, satellites and Kepler's law. After this, we'll quickly have a break. Satellites and Kepler's law. Let's quickly revise the formulas. For satellites, the velocity of that particular orbit will be given by root of gm by r, where r is radius of the planet plus the altitude. That's the formula for velocity of the orbit. The time period of revolution is given by 2 pi root of small r cube by gm. This is the time period of revolution. Remember one thing, if the velocity is not equal to the velocity of the orbit, then the path is going to be elliptical. Then it is going to be an elliptical path. This is assuming the velocities are still lesser than the escape velocity. If by chance the velocity is exactly equal to the escape velocity, then the path taken by that body around that planet will be exactly a parabola. And if by chance the velocity of the object is more than the escape velocity, then the path taken by that particular body is going to be a hyperbola. These are the things which you should remember, and only for this particular speed it is going to be a circular orbit. Otherwise it will be ellipse, parabola, hyperbola, depending on where the speeds are. Also keep in mind certain more things. When you have the time period of that revolution of that satellite is equal to 24 hours, it is called as a geostationary satellite. Geosynchronous satellite. When that r is nearly r, that is h is very, very small, then that is called as a surface satellite. Okay, these are the two terms which you should be aware of. Next, Kepler's laws. If you talk about it, if this is the sun, then the planet will go in an elliptical orbit such that the sun will be at one of the focus. This is the first law of Kepler. The second law of Kepler says, while it is going in the elliptical orbit, when it is very close, the speed will be more. When it is very far, the speed will be less. That's because the area which it sweeps per unit time is L by 2 times of m, which is going to be constant. L is the angular momentum. Angular momentum which is conserved. Angular momentum is conserved. So L by 2m is constant. So the area which it covers per unit time is same. So when it is close, it will move more so that it will be the same as the area when it was far away. When it is far, because this distance is more, it will move less. So it will be fast over here and it will be slow over here. Obviously, at this point, you have the sun. Okay, this is a second law. And then comes the final law, which is the third law of Kepler, where the time period of rotation square is proportional to the radius's cube. This is also there over here. If you square this, t square will be proportional to r cube. Okay, this is the third law of Kepler. Yes, I know TikTok is banned, but TikTok pendulum is not banned. Seconds pendulum is not banned, luckily. So we can use it in JEE. Okay, match the following. I think energy, kinetic energy, potential energy formulas. You should know this. Come on, quickly figure this out. Total energy of a satellite, total energy of a satellite is minus GMM by 2, whatever, A. If you talk about potential energy, it is minus GMM by A. And if you talk about kinetic energy, it is GMM by 2A. You can see kinetic energy is negative of total energy and potential energy is double of that total energy. So similar to atomic structure, electrons revolving around it. So everything is there over here. Come on guys, which option is matching? First option, A will go with 3. Kinetic energy of the planet G, uh, sorry, A will go with 2, my bad. GMM by 2A, perfect. Then B will go with 1, gravitational energy of sun planet system. Yes, minus GMM by A. Total energy of the planet C will go with 4, which is minus GMM by 2A, which I had written down over there, minus GMM by 2A. Escape energy of the surface of the planet of unit mass, that will be nothing but GM by R. Perfect. Everything is matching, nothing problematic. Yes. These are the formulas which you should know. These are for satellites. Exactly similar to electrons in orbits. Okay. Planet takes 200 days for revolving around the sun. If the distance is made 1/4, then how many days will it take? Third law of Kepler, nothing more. T square proportional to the cube of the radius. So the new time square by the old time, which was 200 square, will be the new distance. It is 1/4 of the original distance. So r by 4 cube. Original distance was r. That's what it will be. So r cancels 1 by 4 cube. 1 by 4 cube. 4 4 the 16. 16 4 the 64 is t new square by 200 square. So t new square will be 200 square by 64. So the new time period will be taking roots. It will become 200 root of 64. So that will be 200 by 8. What is 200 by 8? 100 by 4, which is 25. Yes, so that is 25 days, which is D option. Yeah, it is a D option. Perfect. Very good. Awesome. Yes. We have started the live at 11 o'clock in the morning. All right. So we'll come to this after the break. Okay. So we'll have a break time. Oh, that's a little bit late lunch break, but it's okay. Let's meet after 20 minutes. Welcome back. Welcome back. I just had some nice pongal, and I don't know what you guys had. Just quickly let me know. How was it? Yes, let's start, Banunga sir. Yes, we are starting. Started. All right. The lunch break is over. Time up. And we are on to solids. And after this, I think thermo is there. A little bit of waves concept, and we go to the 12 standard important concepts too. Ooh, sweet pongal. Pongal only, sir. Pongal, sir. Wow, super. Super Gaundi. All the students out here, quickly let me know what you had for lunch. Yes, and call your friends back because Shreyas sir is starting the next segment after the lunch break. And we are on to solids now. I think you would have already seen through the slides, but let's quickly go through the slides again. Let me tell you, when we start this particular concept of stress, strain, and all of this, remember, in general, any kind of stress is nothing but the intensity of the force, which is force per unit area. And the strain is basically, the change in the length upon the original dimension. Upon the original dimension. That is what it is. And the modulus of elasticity, the modulus of elasticity is given by your stress divided by strain. Stress divided by strain. So the unit of modulus of elasticity will be pascals or Newton per meter square. This is dimensionless and this is also going to be in pascals. Remember, there are three different kinds of deformation. That's why you get three different kinds of stress, strain, and moduluses. So one is basically longitudinal deformation, where the longitudinal stress is the perpendicular force by the area. The strain is the change in the length. The strain is the change in length by the original length. And here you get Young's modulus, which is that stress divided by the strain. Similarly, you get shear deformation, where you have shear stress as the parallel force by the area. When I say parallel and perpendicular, what do I exactly mean? See, when you have an area, the force can be at an angle, maybe. The force can be at an angle. When I say perpendicular force, it's this component of the force. And when I say parallel force, I mean the force which is parallel to the surface. That's what I mean. Okay. So shear means this kind of deformation. You are applying the forces parallel to the surface. It bends, it deforms. And the strain will be the, the motion along the surface upon the height between those two surfaces. That's what it is. And that is also tan of theta. And here you have rigidity modulus, which is the stress of shear upon the strain, which is x by h. Lastly, you get the bulk deformation, where the stress is the change in the pressure. This is useful for volumetric deformations. You expand a gas, you compress a liquid, you change the volume of a solid, those kind of things. The strain is the change in volume upon original volume. And here you have the bulk modulus, which is change in pressure upon change in volume upon original volume, but it comes with a negative sign here. That's it. Yes. I hope this is absolutely clear. Yes, usually the 11th physics theory is very vast, although the weightage is very similar. Thank you only Jay for all the Telugu people. Yes, thank you so much. Thank you so much. All right. Okay. Now, all this is given here also, nothing different. Few more formulas which you should know is the energy density. So the energy stored per unit volume is given by half stress multiplied by strain. Also, the equivalent spring constant of an elastic body is given by Young's modulus into A divided by L. You can use this. So when you have an elastic body, you can convert it into a spring-like structure of equivalent spring constant YA by L. You can use F is equal to Kx, where that K will be this, or time period formula. where the K value will be this. All these are valid. And remember that you also need to go through the stress strain graphs, which is done many times, where in the beginning you will see in the beginning you will see that the stress is proportional to the strain. This is where the Hooke's law is valid. Hooke's law is valid, and here stress is proportional to the strain, and the slope of this graph often gives you the Young's modulus. Till a particular point, this is called as the proportional limit. After this, it is not proportional, rather it is just elastic in nature. That means if you release it, it will come back to its original state and shape till this particular point, which is also called as the elastic limit. And this particular stress till which you can give it is called as the yield stress. Till this point, it is basically elastic in nature. After it becomes inelastic, that is over here, then it is not a two-way graph. You can expand it, but if you release it, it will probably come back over here. If you expand it till here and release it, it will probably come back over here. This is basically your permanent deformation. This is basically your permanent deformation or permanent set. This is your plastic behavior. This is basically your plastic behavior. And this happens till a particular point, which is often called as the maximum load which you can give. So this is also called as the strength of the material, the strength of that material. This is the maximum loading point which you can load it till, because after this, what is going to happen is the irreversible damage. It is just going to decrease the stress and it will eventually break, or basically it will fracture. It is irreversible. You can't come back. You can't go anywhere. That's it. It will happen very fast. This happens very fast. These are the things which you should know about the stress strain diagram. Yeah. Yeah, Bhargavan, that's the aim, to complete the class before the mathematics class. I know. So we'll try to complete it by 5, 6 o'clock for sure, or maybe at least 6 o'clock. Okay. Here is the question. The wire of certain length and area is hanging. The length of the wire changes from to L1 when the mass M is suspended. Then the expression for the Young's modulus is how much? Okay. So basically, the original wire was having certain length, and then the wire became longer over here. The original length was L. The original length was L, and when that mass was hanging over here of how much M basically, then the length became L1. Okay, it was supported from the top. The wire itself is massless. As you can see, the extension over here is L1 minus L. And if you notice, the stress on the rod, which is the force by area, the force is mg and the area is basically A. So this is the stress, this is the extension, this is the original length. So we can easily figure out what is the Young's modulus. Young's modulus is stress by strain. Stress is mg divided by A. Strain is x divided by L. So it will be mg divided by A. Extension is L1 minus L, and original length was L. So mg L by A, L1 minus L. So that is nothing but option number C. C for your Cap2 or Captain Shreyas. No, it is not B. It is option C. Yeah. Yes, very good. Yes. Today, we are going to complete it, B. Raju, even if it is late. Yeah. Is it okay to write J with only 12 chapters? Zeba, if you are planning to only study 12th, trust me, it is going to be a little bit dicey situation, because although it carries 50% weightage, but a lot of dependencies are there, like vectors, Newton's laws, work energy, SHM, waves. These are chapters which are basics for another chapter, like electrostatics, electromagnetic induction, or gravitation relates to electrostatics, and then even AC and even light waves are related on waves and oscillation. So many dependencies are there. So if you can tackle that, it's okay. Or else actual weightage might be 50, but what happens practically is it becomes less than 30%. So 30% is barely 20-30 marks here and there, and the two you might make mistakes in that. So that means you barely might score 20 to 25 marks. by just studying, 12th standard without knowing anything about 11th. That's the problem. Okay, so moving on to the next question. There is a catapult made of rubber cord which is some meters long, some cross section, negligible mass. A stone is there and he stretches it and releases it. It flies off with 20, neglecting the change of area. Find the Young's modulus. This is a question completely based out of energy conservation. How, you might ask? Because because when you stretch it, it has elastic energy that converts into kinetic energy. So it's just a question of elastic energy, elastic energy getting converted into kinetic energy. What is the elastic energy? Well, it is the density into the volume. Density of energy into the volume. Density of energy into the volume. And this is nothing but half mass into V square. Now you might ask, what is the density? Density of energy we have seen, it is nothing but half stress into strain into the volume. Volume is nothing but area into the length. So this is equal to half mv square. Half and half cancels out. Stress into strain. Now I don't think stress is given because force is not given. So get rid of stress. Stress is Young's modulus into strain, correct? Because y is sigma by epsilon. So sigma is y into epsilon. So into epsilon, area is pi r square into the length. This is equal to m into v square. Speed is given, Young's modulus has to be found. This is the strain, right? Okay, so this will become Young's modulus into strain square into pi. Radius is not given. I think diameter of the cross section is given. So it will be d by 2 whole square into the length is equal to mv square. All right. So next step will be nothing but Young's modulus. Strain. Strain is not given, but the change in length upon original length can be written now. So x square by L square pi, and you have d square divided by 4. Here you have L is equal to mv square. Many things will cancel. Anyways, Young's modulus is asked. So 4 can be taken up, mv square can be taken up, and also L will remain because one L will get cancelled. So 4ml v square, the whole thing divided by, you have pi over here, then you have x square, then you have d square, L got cancelled. That's it. M is known, L is known, V is known, pi is known, X is known, D is known, everything is known. Solving this, you will get the Young's modulus. Okay, solving this, you will get the Young's modulus as same calculations are given, 10 to the power 6. Everything can be substituted. So 10 to the power 6 pascals or Newton per meter square. Got it? Awesome, awesome. Moving on to the next concept coming up on your screen. Here it is. There is a rubber ball which is taken to the depth of 1 kilometer inside water so that its volume reduces by 0.05%. What is the bulk modulus for rubber? That's the question. Yes, today we are completing 12th syllabus also. Well, in this particular question, the rubber ball is taken 1 kilometers inside. So therefore, there will be a change of pressure given by rho g h, density of water 10 to the power 3, g is 10, height is 1 kilometer, which is 10 to the power 3. So this will become 10 to the power 7 pascals. Now the next concept. What is the bulk modulus? Bulk modulus is change in pressure upon relative change in the volume, negative sign, but I'm interested only in the mod value anyways. So change in pressure 10 to the power 7. The volume reduces by 0.05%, which means delta V by V is 0.05%. Now, if this is percentage, think about it. Actual value will be 0.05 divided by 100, because when you convert it into percentage, you multiply by 100. When you relieve percentage, you divide by 100. So this will be 5 into 10 to the power negative 4. So just put it over here, 5 into 10 to the power negative 4. So this will become 10 to the power 7 plus 4. That's going to be 11 by 5, which is nothing but 1 by 5 is 0.2 into 10 to the power 11, which is 2 into 10 to the power 10. 2 into 10 to the power 10 is C option. That is the correct one. Got it, my dear students? Everybody with me? Perfecto. Shall we move ahead to the next question? Yes. Shall we move ahead to the next question? Yeah. The concept of fluid mechanics was only limited till here, rho gh. This is very easy Laddu formula. Okay. Let's go. Some pressure is applied on a cube so that it is compressed. K is the bulk modulus and A is the coefficient of linear expansion, or alpha is the coefficient of linear expansion. Suppose we want to bring back the cube to its original size, what should be the temperature change? Yes, you're right. So, my dear warriors, coming back to the question. Now, when you apply some pressure, it will compress. So, we can find the change in volume using this formula. Bulk modulus is the pressure change upon change in volume by original volume. So, delta V will be, check this out, delta V will be delta P, K comes below, V will go on the top. This is what it will be. Okay. Now, how much is the change in the pressure? I think it is given. External pressure P is applied, and technically this was not K. Usually we use the bulk modulus symbol. So this was B. So getting it back into original symbols, delta V will be P V divided by K as per the symbols given. Now there is also another formula for change in volume. If you notice, for thermal expansion, change in volume is original volume gamma into delta T. But gamma is not given, alpha is given. But we know coefficient of volume expansion is 3 times of linear expansion. So gamma is 3 alpha into delta T, definitely. So delta V from here, if I substitute, which is P times V divided by K, as you can clearly notice over here, volume just gets cancelled. All right. And we have to find delta T. Okay, so if this is the case, put 3 alpha below. So P by 3 alpha K is equal to delta T. That's what is asked. What is the temperature that should be raised? P by 3 alpha K. Yes, that's the answer, option number C. Sometimes they can combine it with some another chapter like you are seeing over here. So don't think if I just do one chapter, will I be able to solve all the questions? Maybe. But usually when they combine the chapters and you don't have knowledge about something else, then you will be stuck in that question. So that is the reason why you should not just go through the weightage. You should also see how many combined questions can be asked. And that's where the magic lies. All right. All right, all right. Perfecto, perfecto. Let's move to the next concept of calorimetry. In this, again, every time, most of the times, you will see a concept, a question based on this particular concept, where either they will ask you equilibrium temperature, or they will ask you specific heat capacity, or they will ask you heat required. All these kind of questions are usually asked over here. So the major formulas are, when you are going to melt, or when you are going to vaporize, or you are going to freeze, or you are going to condense, then the heat required will be m into L. That's the formula. Don't use mc delta T, because this kind of operation is a isothermal operation. That means the temperature is always going to be constant in a phase change. So whenever there is a phase change, the temperature never changes. It's the state, solid, liquid, gas, which changes. And the formula is ml. M is the mass, L is the latent heat. Usually for latent heat from ice to water is usually 80 calories per gram, and the latent heat for water to steam is 540 calories per gram, standard value. Now, when you are in the similar phase, liquid to liquid, gas to gas, solid to solid, then you use mc delta T formula. Here, this is in the same phase that you will use, and temperature can change by delta T. M is the mass, C is the specific heat capacity. Standard formula, specific heat capacity of water is 1 calorie per gram per degree centigrade. That's something which you should know. All right. I hope this is clear. Koteswar yes, please ask. Please ask. Chapter which is going on, we are on to thermal physics, heat, Kathira. Block on block concept not needed. I mean, it's a low weightage thing. For JEE Advanced, yes, sometimes they ask questions on that, but not necessary every single time. Okay. Now, when you reach thermal equilibrium, when you reach basically thermal equilibrium, then the temperatures of the bodies A, or basically you can say some bodies over here and the temperature of the other bodies on the other side, they both will be equal. And when that happens, I can also say one more important thing, that is the heat which is lost by the hot body is equal to the heat which is gained, the heat which is gained by the cold bodies. So this is very, very important because this is the principle of calorimetry. So some things will lose, some things will gain. How much is lost or how much is gained can be used, can be found by these formulas, ml or mc delta t. So see which are hot, see which are cold, accordingly solve the question. That's all. Okay. All right. Let's do some questions then. Let's do some questions. Calorimeter, water equivalent, contains water 25, steam at 100 mixed in it, final temperature 31, that's at thermal equilibrium, latent heat of water and specific heat capacity given. Now, when you see this word, water equivalent, it is exactly what it means. See, any object will have its own specific heat capacity. Meaning, if you supply some heat, it will raise by temperature something amount. Water will raise by some other amount. Now, if I want to convert that object into water, how much water will be needed so that it will behave exactly like the original object? So that much mass of the water which behaves like that object in terms of heat is called as equivalent water amount, okay, or the water equivalent. So it's the mass of water which will accept the same heat for the same temperature as that of the body for the same heat and the same temperature. Got it? So forget the body, think it has been converted magically into water and it is behaving thermodynamically heat wise the same way. So treat it like water only. So eventually we have 180 plus 20, which is 200 grams of water. Okay. Now, if you notice what has happened over here, who is the cold object? Cold object is the water over here. So 200 grams of water, which is at 25 degrees Celsius. And then the hot object, which is the steam. The steam, which is of how many grams? M grams. M grams of steam, which is right now at 100 degrees Celsius. This is going to lose the heat, and obviously this is going to gain that heat till they achieve what is called as thermal equilibrium, which is happening at 31 degrees Celsius. So once you identify who gains, who loses, it becomes an easy problem to solve. Okay, I'll put equal to over here. All right. Water is converting into water because 31 degrees Celsius, water is water only. So mass of the water 200, specific heat capacity 1, delta T 31 minus 25, which is nothing but 6. So 200 multiplied by 6. All right. Till this point, everybody clear? Right hand side. Steam directly can't go into water. First, it has to condense, then it has to lower the temperature from 100 degree Celsius water to 31 degree Celsius water. So it's a two-step process to calculate this. First is ml. M is M only. Latent heat is basically 540 plus M into specific heat capacity into 100 minus 31. Is this absolutely clear? Change in temperature from 100 to 31 and steam to water. So M is common, I believe. So here we have 540 plus 100 minus 31, that's 69. So basically plus 69 over here. So from this, definitely we will get M. M is basically 1200, whole thing divided by 540 plus 69. Okay, so that's just going to be 609, I believe. So it's close enough to 2. Yes, this is going to be close enough to 2 because this will be 1200 divided by 609. 1200 by 600 is approximately 2 or is equal to 2. So by 609 will be almost 2. So this mass will be almost 2 grams. So 2 grams of steam was there. That's how you solve the questions. Is this clear? Happy Pongal Ji Avnash. Chemistry session, Surya is going to be there tomorrow. I don't know whether you have seen this. Please see this. Okay, on the channel only it is there. Yeah, complete maths one shot revision 16th January. 15th January you have complete chemistry one shot marathon, complete maths formula. It is at 7 o'clock. Today we are doing this, and before this we have done NTS favorite questions. I have also done a big surprise in terms of test series, and also for CBSE board students there is a special crash course where even I am there. Yeah, check that out. And also the test series just for 399, 5 mock tests for 399, 10 mock tests plus ebooks for 499, extra 100 rupees. That's all. Diksha ma'am has taken all the physical, inorganic, organic marathons, 99 percentile questions over here. Namrata ma'am has taken the Obsession JEE series for mathematics. Before this, we have done Ezekiel questions. We have done difficult questions, most expected high weightage questions. Please check out every session. It has good collection of questions. And in every session, you will also see there is a PDF. Yes, just open any session up. You will see the session PDF. It has all the questions over there. Yeah, so solve all these mock tests. You can give this as a practice and then see the solutions in our channel. Okay, that's an easy way to complete all these sessions. Cool. All right, let's move to the next question. Ready, warrior pandus? Ready, warrior pandus? WP warrior pandus whistle podu. WP please. I need some energy. Huh. Bernoulli's equation. Come on, let's go. Yes, even today's session PDF will be given in the comments or in the description box. The PDF link will be uploaded. Okay, just wait till tomorrow morning, it will be done. Okay, great. Hold on, we are coming to KTG. Hold on. Bernoulli's equation. Pressure plus half rho v square plus rho gh is a constant. Pressure at any point, rho is density, v is speed, rho gh, g is gravity, acceleration, h is the height. This is the formula which you use for pipes basically, or for streamlined flow. Maybe the height here is h1, maybe the height here is h2, maybe the pressure here is p1, pressure here is p2, the velocity here is v1, the velocity over here is v2. So then you can use this concept from one cross section to other cross section, something like this: p1 plus half density into speed square plus rho g height 1 is equal to pressure plus rho g h2 plus half rho v2 square. Not just that, if you change the cross section, speed changes. Maybe the area here is A2, area here is A1. So you have something called as equation of continuity, which says V1 A1 is equal to V2 A2. And this quantity over here is nothing but the volume which is flowing per unit time. So it's the volume flow rate. Area into velocity is volume flow rate. So volume flowing per unit time inside is volume flowing out per unit time. That is what the equation of continuity is all about. Then I think I have mentioned it over here too. Okay, no issues. Then you have this viscosity based questions a lot. First is the Newton's law of viscosity, where if you have a surface or layer of liquid, it is moving with a relative speed dv. The actual speed might be v plus dv. With respect to the lower layer, the speed is dv. The lower layer might be moving at a speed v. Then if there is a relative motion between them, there will be a drag force, which is the viscous force between the layers when the fluids slide. That drag force is given by eta, I will put it over here, viscosity coefficient, relative velocity, which is going to be dv over here, by dx, and this is actually the force per unit area, so you will have to put a over here. Eta a dv by dx. What is this dx? Dx is basically the separation between the layers, dv by dx. That's the formula. This is viscosity coefficient, this is area, this is relative velocity, this is separation. So then I don't have to put this over here. Okay, that's what you need to remember. Is that clear, everyone, till this point? This is Newton's law of viscosity. Now, this is for layers. But when you have spherical bodies, then you have something called as the Stokes law. Then you have something called as the Stokes law, where you have a sphere moving with speed v, the radius is r, inside a medium. Then the drag force, the viscous force is given by 6 pi eta rv, 6 pi viscosity coefficient into radius into velocity. This is your Stokes law, my dear students. Based on that Stokes law, you get the concept of terminal velocity for any object which is dropped. So maybe the object starts from rest, slowly the speed increases, and eventually the speed just remains constant. So this is your terminal velocity, which remains constant, and that formula for terminal velocity is given by 2 by 9, okay, g into radius square divided by viscosity coefficient, density of the drop or that sphere minus the density of the fluid. Please remember here, this is for the fluid, this is for the drop. That's something which many students get confused over here. Okay, this is the terminal speed velocity, and when the terminal speed is achieved, you will see that the buoyant force, which is v rho g, and the drag force and the viscous force basically, which is 6 pi eta rv, will be balanced by the weight, which is m into g. So this is what happens when the terminal speed is achieved. Because they are balanced, that's why the acceleration will be zero. The acceleration will be zero and the velocity will be constant. These concepts are very important for these questions. Then the Torsily's law, again, this is based on Bernoulli's principle. If you have a bucket of water like this, and maybe it is filled with some liquid over here, like this, till some height. Let's say the height till which the liquid is filled is h. Now somebody makes a small hole over here. At a depth of small h. Then the velocity of that liquid, which is the velocity of efflux, is given by root of 2g this h, the height from the surface. This liquid will definitely fall somewhere. So you will basically get the range. That range is given by 4 times h minus h into h. H is this complete height, small h is from the surface. This is what the range is going to be. This is very, very important. Yeah. Yes. All right. Now, next important thing. Yes. Well, see, all the planes, wings, fans, everything, they all have this concept of pressure difference, which is created by velocity difference. So they create a differential velocity, which creates a differential pressure. That pressure difference is what creates that force. That's what happens. One part will have slow moving velocity, one part will have high moving velocity of liquid. That is what creates the pressure difference every time. Aeroplane, houses flying off during tornadoes, blades of a fan or a rotor, all these things. Okay, these are the important formulas. Also, the rate of flow of the liquid which is coming out will be the area of that small hole, area of that hole multiplied by the velocity, the same velocity, the velocity of efflux. Very, very important. Sometimes they might also ask you what is the force of that liquid coming out, the force of that liquid, or basically that efflux, that is density into area multiplied by the velocity square, rho a v square. That's the formula. The velocity in square into the area into density gives you the force with which the liquid comes out through any hole. These are the important formulas here. So let's start with some questions. Here it comes. A tube spray pump has radius r. It has n holes, each of radius r. Speed in the tube is v. What is the speed of the liquid through the holes? Very straightforward question. So imagine this is a tube of radius, basically, let's say r, and inside of it, the liquid is entering with a speed v. Now, what happens is, as you go ahead, it breaks down into small, small tubes. N number of such small tubes, and each having how much radius? Small r, and each of them the velocity, let's say I call it as u. So n number of such tubes are there. So the question is, what is that speed? I believe, what is the speed of ejection of liquid? U is asked. What is this u? So use a equation of continuity, so which says that the rate of liquid going in is the rate of the liquid which is going out. Now the rate of the liquid which is coming in is area into the velocity, area being pi into r square, pi into r square, so into velocity. The rate which is going out, there are many such tubes, many such tubes. Each tube has an area, let's say small a. The velocity is u, but there are n such tubes, so multiplied with n. This small area will be pi r square into u into basically n. Pi pi cancels, pi pi will cancel definitely. Therefore, u will be, check this out, u will be, r square is there, v is there. From here, r square will go down and even n will go down. So r square v by r square n. That is the answer. R square v by r square n, which is B option. Everything else, there is some or the other thing which is unnecessarily squared or not squared. Yep. Cool, everyone. These are the important, obviously, concepts from fluids which you must know. Moving on to the next question. There is a liquid going through a horizontal pipe. If the pipe is horizontal, that means the height is not changing, it is constant. Speed is v, where the pressure is p. Another point, pressure is less, but the speed is different. If the density is rho and the flow is streamlined, then what is capital V going to be? Okay, so for this particular question, remember the height is not changing, only the pressure and the speeds are changing. Pressure is P, here it is P by 2, here it is going with speed V, here it is coming out with capital speed V, and this capital V is asked. So let's use Bernoulli's equation. Height is constant, obviously, height is going to be the same. So pressure plus rho GH plus half rho V square is equal to, here it is P by 2 plus rho GH plus half rho capital V square. Rho GH cancels. So P minus P by 2 is equal to half rho V square, or half, I'll just keep this small v square as it is, half rho small v square is equal to half rho capital V square. P minus P by 2 is P by 2. So P by 2 plus half rho V square is equal to half rho capital V square, half cancels. So P plus rho small v square is rho capital V square. So V square capital will be P by rho plus V square. So V will be root of P by rho plus small v square. P by rho plus small v square, which is D option, I believe. Yes, that is the correct answer. Got it, everyone? Yes, D option. Very good, Nagarshini. Come on, guys. Full energy, full Josh. I want everyone. Okay. Awesome, awesome, awesome. Let's move. Let's move to the next question. Ayo, already this answer is given. Anyways, try to do this question now, homework, because already the answer was given. Okay. This is based on the concept pressure difference is nothing but that force which is created per unit area, and this pressure difference comes because of the velocity which is different. Use Bernoulli principle. Yeah, use the Bernoulli principle. Arey, why are all the answers given so quickly? Uh, okay, try to do this also as homework. Anyways, try to do this also as homework. Terminal velocity is given, viscosity is given, speed is also given, radius is also given. What is the viscous drag force? This is a question based on Stokes' law. Stokes' law. Viscous force is 6 pi eta RV. Believe me, everything is given. Eta is given, radius is given, also speed is given. You just have to find this 6 pi eta RV. Directly you can do this question. Okay, let's do the next question. Luckily, answer is not given here. Okay, solid sphere of certain radius acquires some speed through a medium of viscosity eta. It is broken down into 27 small spheres. Each of these acquires speed v2. What is ratio of the speeds? What is the ratio of the speeds? Okay. Now for this particular question, find the new radius. Your job will be done, because remember the terminal speed given formula is 2 by 9 g r square sigma minus rho whole thing divided by eta. So terminal speed is proportional to r square. So when I want to do V1 by V2, it should be R1 by R2 whole square. So what do I do now? If you take a big sphere, break it down into small, small parts, the volume which is there of that big sphere will be volume of that small spheres multiplied by the number of such drops, multiplied by the number of drops. Each drop some volume, add all those volumes, small, 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 small drops, you get the volume of the big sphere. What's the volume of the big sphere? 4 pi, I think, r cube divided by 3, 4 by 3 pi r cube is equal to volume of the small one will be 4 by 3 pi r2 cube. Number of drops 27. 4 by 3 pi cancels, so r cube will be r2 cube multiplied by 27. Take cube roots, so r will be 3 times r2. Rather, this r is actually speaking r1, so r1 by r2 will be 3 by 1. Makes sense. So the new radius is 1/3 of the previous one. So r1 by r2 is 3 by 1, so this will be 3 by 1 whole square. So that's it, guys. You are going to get this as 9 by 1. So 9 by 1, I believe, or 1 by 9. Yes, with 9 by 1, which is option A. Yes, correct. Perfect. This is 9. 9 by 1 is the same as 9. Correct. Got it, guys? Everyone? Yes, option A. Perfecto. Awesomeness. These are standard questions. Let's go to KTG and thermo. Let's directly go to now to KTG and thermodynamics after this. Ready for it? Okay, cool. Let's go, my dear students. Boyle's law, when temperature is constant, P into V is constant. Pressure is inversely proportional to volume. That is your Boyle's law. Next, Charles' law, when your pressure is constant, then your volume is directly proportional to temperature. That's your Charles' law. Next, your Gay-Lussac's law, which is when your volume is constant, then pressure is directly proportional to temperature. Hence, you get PV is equal to nRT, which is your complete ideal gas equation. PV is equal to nRT. N is the number of moles, R is your gas constant, T is temperature in Kelvin, V is volume, P is pressure. You can also rewrite this formula as Pm is equal to rho RT, where M is the molecular mass, M is the molecular mass, rho is basically the density. Rho is basically the density. If you ask me how to calculate the number of moles, I will say you can do it like this: number of molecules by the Avogadro number. This is Avogadro number 6 into 10 to the power 23. Or you can also do mass of that particular gas, upon the molar mass, That will also do mass of that gas upon the molar mass. Is that right? Yeah. Okay. So that will give me the number of moles. Cool. Next important formula for RMS speeds and all these things. So RMS speed is root of 3 RT by M standard, where RMS value means root mean square. So it is taking the squares of each speed, V1 square, V2 square, like that, taking the average, that means divide by N, and then finally taking the root. That is your root mean square speed. It's 3 RT by molar mass, standard formula, which you should know. Okay. Then some more formulas I will give it to you right over here, which you should definitely know. You also have something called as the most probable speed, and you also have average speed, average being V1 plus V2 plus nth molecule divided by N. Average speed is nothing but 8 RT by pi M. Most probable speed is the root of 2 RT by molecular mass. And you have the main KTG equation of pressure and RMS speeds, which is given by pressure into volume is 1 by 3 number of molecules, mass of each molecule, into RMS square. This is number of molecules. This is mass of each molecule. Mass of each molecule. Very, very important. This mass of each molecule is the molar mass divided by Avogadro number. Very crucial again. Okay, keep this in mind. Very good. Awesome. Now, the next thing which you should know is a table chart for polyatomic gases, standard basic results. So when you talk about monoatomic gases, like example, helium, neon, etc. And then you have diatomic gases, example, hydrogen, oxygen, or even uh, triatomic gases, but which are linear. Triatomic gases which are basically linear. Example, CO2. And then you have non-linear triatomic gases. Example, H2O. Yeah. For each of them, you have something called as the degrees of freedom. The degrees of freedom. For monoatomic, you have 3 translational degrees of freedom. Then for diatomic, you have 3 or even for linear, 3 translational plus 2 rotational degrees of freedom, which makes it 5. Degrees of freedom, the symbol is F. Degrees of freedom, the symbol is F. Non-linear triatomic, you have 3 translational and 3 rotational, which makes it 6 degrees of freedom. Then you have something called as the specific heat capacity at constant volume, which has a formula, degrees of freedom R by 2. So for mono, like helium, neon, etc., it is going to be 3R by 2. This is going to be 5R by 2. You can see degrees of freedom is 5. This is 6R by 2, which is going to be 3R. Then you have CP, which is CV plus R, which is Mayer's relation. So CP for mono will be 5R by 2. For diatomic, it will be 7R by 2. And for triatomic non-linear, it will be basically 4R. Then you also get something called as gamma, which is the ratio of Cp by Cv. Gamma, which is the ratio of Cp by Cv, which is also 1 plus 2 by F. For monoatomic, the gamma will be 5 by 3. For diatomic, it will be 7 by 5. For non-linear triatomic, it will be 4 by 3. These are the formulas. Yes. Is this clear, everyone? These are main things that you should know in kinetic theory of gases. Apart from this, some more things which you should know is the law of equipartition of energy, which says that the energy per degree of freedom per molecule is half kT, where K is Boltzmann constant, which is R by Na, which is 1.38 into 10 to the power minus 23. This is your Boltzmann constant. So keep this in mind. The total energy of a molecule is degrees of freedom into half kT. Whereas the total energy of a gas is given by number of moles into Cv into T. So change in internal energy of a gas is NCV delta T. This is again a formula which you must know. Gamma is your adiabatic ratio, Poisson ratio, whatever you want to call it. Okay, so Cp by Cv ratio, adiabatic ratio, right? That is what it is. Now, let's solve some questions based out of this. Here is the first question. There is a graph given of pressure versus temperature. All these gases, when extrapolated, they meet at this particular point, K. And the question is, what is the temperature corresponding to that particular point? It's a very simple laddu question. Everybody should be able to give it. Gamma is useful for calculating work, heat, etc. in adiabatic processes. It is also useful for calculating, pressure, volume, temperature for those processes where heat exchange does not happen, basically an isolated system, correct? So that is where you will see it used. It's also useful for calculating the speed of sound, which has the formula root gamma RT by M. Okay, speed of sound. So many places you will see the usage of gamma. Yes, this has to be absolute zero, which is minus 273 degrees Celsius. Perfect. Very good. Awesome. Yes, option A. Next, the RMS speed of oxygen is 160. RMS speed of hydrogen at zero is how much? Now remember, RMS velocity is root 3 RT by M. Temperature is same. So it is indirectly proportional to the root of the molar mass. So that's all. So velocity of hydrogen by velocity of oxygen will be molar mass oxygen on the top, molar mass hydrogen below. So what is for oxygen? Well, it's 30. For hydrogen, well, it is 2. So it will be root of 16, which is basically 4. So velocity of hydrogen will be 4 times velocity of oxygen. So 4 times of 160, 16 fours are 64. So 640 meters per second. 640 is option A. Yes, it is correct. Simple formula, indirectly proportional to root of mass, and that's what will give me. Is that clear, everyone? Moving on, next question on your screen. Diatomic gas does 100 joules of work in an isobaric expansion. What is the heat given to the gas? All right, let's do this. Diatomic gas is doing 100 joules of work. Okay, work is known. In isobaric expansion, that means pressure is constant. So usually the formula for work is P delta V, and this is given to be 100. 100 is basically P delta V. Okay. What have we been asked? The heat given. Heat for isobaric process will be NCP, specific heat capacity at constant pressure, delta T. For diatomic gas, diatomic gas CP value, we just figured it out in this table. Remember, diatomic gas CP value is 7R by 2. All right, so let me just put it over here. Diatomic gas, it will be nothing but 7R by 2, and this is nothing but delta T. Now you'll be like, how do I find this? This is given. I have an idea. Let me write this as 7 by 2 nR delta T. You know what nR delta T is? nRT is PV. So nR delta T is P delta V. Yes, PV is nRT. So P delta V is nR delta T. That's it. Differentiation on both sides. Derivative difference on both sides. That's all. So P delta V is 100. So just put 100 over here. So that into 7 by 2. 100 by 2 is 50. 57 is 350 joules. So that is the heat. Option number C. This particular thing is useful many times. So I will just mark it here. P into V is nRT. So P delta V is nR delta T, assuming the pressure is going to be constant. N and R are always going to be constant. So that is a very important relationship which you must know, which we have used it over here. Okay, cool. Let's move to the next question. How much energy do 10 non-rigid molecules have at some temperature T? 10, 10 non-rigid molecules, diatomic molecules. I think I know energy of each molecule. Energy of each molecule is half kT into degrees of freedom. So half, K is also there, T is also there. Diatomic has 5 degrees of freedom. So for 10 molecules, the energy will be 10 multiplied by 5 by 2 kT, correct? 10 by 2 is 5, 5 5 is 25, so 25 kT. 25 kT, I think I have missed something. Why have they written 35 kT? 10 non-rigid diatomic molecules. Diatomic molecules have 5 degrees of freedom. Yes, perfect. K is K only, T is T only. There are 10 molecules. 10 by 2 is 5, 5 5 is 25. I think it's a misprint. It shouldn't be 35. Uh, unless we consider vibrational degrees of freedom. So I think either you give in the question that also considering vibrational degrees, if you consider vibrational degrees, the degrees of freedom will be added by +2. So then over here, what will happen is, over here, this won't be 5. This will be basically 5 plus 2, which is going to be 7. So 3 translational, 2 rotational, and 2 vibrational modes will come. So because of which it will become 7. So half kT into 7. Yes, perfect. So then 7 by 2 kT will be multiplied by 10. So 10 by 2 is 5, 5 sevens are 35. So 35 kT will be there considering vibrational modes, and this will only happen when the temperature is very high, not at normal temperature. Normal temperature vibrational degrees are not there. Only at very high degrees, at very high temperature it will be there. Okay, I hope this is absolutely clear. And I think the hint can also come from this part over here, where they have mentioned that it is non-rigid. Non-rigid means the distance between the molecules can change. So definitely they can vibrate. So that is the reason why we should actually consider the vibrational degrees of freedom. So technically speaking, this question is fine only. No need of mentioning this because non-rigid is mentioned. That means the molecules can go back and forth with respect to each other. So vibrational modes have to be considered. Okay. So this happens at high temperatures usually, and you have to add extra 2 degrees of freedom. All right. Next, beats, resonance, coming towards the end of the 11th part. Yep. Yes, Ashwin, non-rigid is given. Very good. Clear? Is this question PYQ? I'm not really sure. Some questions might be PYQs, some are not. And these days there are so many PYQs because there are so many shifts, no? So many shifts, so many attempts. Some years there were 4 attempts, 3 attempts. So the number of questions are like crazy. So it's very difficult to remember these days which is a PYQ, non-PYQ. J advanced question at least you can remember. But mains questions, it's like piece of garbage. Like garbage is thrown everywhere. So much, so many questions are there. Just have to solve PYQs. Okay. Bit frequency. Beats is when two sounds of similar wavelength, similar frequency are together. Individually, they sound the same, but when sounded together, they will alternatively produce loud sound, faint sound, loud sound, faint sound. So that loudness and faintness leads to that phenomena of beats, and there is a rate at which that loud, faint goes on. That is called as the beat frequency. That is precisely the difference of the frequencies. Whichever is big, put it first. Whichever is small, put it later on. Cool? Yeah. Awesome. Yes. When will the class complete? The target is to complete it by 6 o'clock. Hopefully, if it doesn't, maximum 6:30. Okay, because 7 o'clock you have the mathematics class. All right. Now, whenever resonance occurs, okay, then remember two things will vibrate with maximum amplitude, their frequencies will be similar to each other. So whenever the word resonance is used, frequencies are same, amplitude is maximum, sound, light, whatever it is maximum. When they are identical but not equal, they will produce beats, the difference of the frequencies. When you load a tuning fork with wax or some material, some clay, then the tuning fork becomes heavy, it becomes slower, and the frequency reduces. Keep that in mind. Now, the most important repeated question in these is about pipes, organ pipes, and this resonance tube specifically. You should remember one thing: when you have a completely closed or completely open on both sides, a pipe which is open on both or closed on both sides, the frequency is given by n times velocity of sound by 2 times of length. This is the length of the pipe, speed of sound, n is the harmonic number. So you have all the harmonics. F is there, 2f is there, 3f is there, 4f is there, 5f is there, and so on and so forth. This is called as the fundamental frequency. This is called as the fundamental frequency. But if it is open or closed on one side only, such an organ pipe will have a formula: F is equal to odd V by 4L. Be careful, 2 here, 4 here. The frequencies of such pipe will be F, 3F, 5F, basically 7F, odd F. Odd harmonics only, even are not present. This most basic is again called as fundamental frequency. This is third harmonic, fifth harmonic, seventh harmonic, ninth harmonic. Even harmonics are absent. Now, using the concept of open closed end, you take a pipe, dip it in water. So this side becomes closed and this side becomes basically open pipe. You take a fork of frequency F, sound it, the standing waves are produced inside this particular pipe, open and closed. And the formula for frequency is given by odd times V by 4L. But this length is the effective length because there is something called as the end correction, which is the original length plus plus 0.3 times the diameter. This is called as the end correction. This end correction is because your standing waves do not exactly end on the open side. They go slightly outside of the open pipe. So you have to accommodate that extra length, which is called as the end correction, E. So the length that you put in this formula should be the geometrical length plus some additional factor, which is 0.3 times D, where D is basically the diameter of that pipe. Diameter of that pipe. That's all. Now, when you vary the length, when you can make this pipe go up and down, you can get different harmonics. The first harmonic when you get, you will see there is an antinode here, node here, and you will see that the total length of the pipe plus the end correction will be lambda by 4. This is the first harmonic that you will get. Then in the second harmonic, next harmonic, antinode, node, antinode, node. So you will see that the length plus the end correction, this will be the next length, will be, you know, this is lambda by 4. This is lambda by 4, lambda by 4, lambda by 4. So this will be 3 times lambda by 4. Next time when you change the length, of course. Okay, so this will be the next length. I can call it L3. This will be, let's say, L1. Okay, the wavelength will also change if tuning fork is different. If it is the same, wavelength will be same. This will be obviously the third harmonic. Same thing you can go for the next one also. So it will be basically L5 plus E will be 5 times lambda by 4. This is going to be the fifth harmonic. So as you move the pipe up and down, more and more wavelengths will fit in, and accordingly this length will change as per these formulas. Remember, how do I know this lambda by 4? Because if I have a standing wave, this particular lobe which is there, this is actually lambda by 2. And how do I know it is lambda by 2? Because look at this. This is completely one wavelength. This is a wave. So this is half the wavelength. So if somebody only considers this much, that much will be lambda by 4. And in fact, this is exactly what is considered here. Antinode node, it's half of the lobe. Half of the lobe. Lambda by 2's half is lambda by 4. That's why I have taken this as lambda by 4. Okay, so keep these things in mind. No problem, Poojash. Welcome aboard. Yes. Thank you so much, Muthu Lakshmi. Means a lot. Yes, whole of the physics portion, all the high weightage topics. Yep, cool. Let's do some questions. Oops, based on this. Yeah, a resonance tube is old and has some, some weird end. Jagged end means it is not very great. It is still used in the laboratory. A tuning fork is used, and when the tube is filled with water to a mark of 11 centimeters, then the open end of the tube, then there is a resonance. The experiment is repeated with another fork, and the mark is 27 centimeters. So the velocity of the sound in air obtained in this experiment is approximately how much? Come on, let's see how do we do this particular question. Very interesting. The first resonance, then the experiment, yeah, produces the first resonance. First resonance means the first harmonic. This is the original length. There is some jagged end, means there is an end correction involved here. Okay, keep this in mind. So length plus E is equal to nothing but that odd number into lambda by 4. In this case, is the first harmonic, so odd number is 1. This is lambda by 4. Length of the pipe is 11 centimeters, so 0.11 meter plus the end correction. This is the first equation. Similarly, in the second case, it is repeated with a different tuning fork. Okay, different tuning fork. So 512 and 256. So think about it. If this gives some wavelength, frequency is halved. What will happen to the wavelength? Frequency is half. So what will happen to the wavelength? The wavelength will become 2 times lambda. If this was lambda, that will become 2 lambda. Yes or no? Everyone clear till this point? Okay. So next time, what is the length? 27 centimeters. So I can say next time 0.27 plus the same end correction. Again, the first resonance, that means first harmonic, that means odd number is 1. That is 2 lambda divided by 4, that is number 2. Obviously, E is not known. From this, I can find the lambda. and then solve for the question. That's all. So subtract the two, guys. Nothing great over here. Take this and subtract the two. Subtracting, you will get 0.27 minus 0.11. E will get cancelled. 2 lambda by 4. 2 lambda by 4 minus lambda by 4. This will be nothing but 0.16 is equal to just lambda by 4. So lambda will be lambda by 4. So lambda will be 4 times 0.16, which is 0.64 meters. Now you can find the speed of sound. So speed of sound will be f times of lambda. F is 512 and lambda is nothing but 0.64. So do the math and you will get the answer as 328 meters per second. So this will be nothing but 328 meters per second. Is this clear how to solve this question? Yep. Awesome. Awesome. Very good. Clear. Let's move to the next question on your screen. There is a tube, both ends open. Tube, one end closed. Otherwise, they are identical. The ratio of fundamental frequency of tube A and tube B. Okay. Simple, guys. If you take tube A has both ends open, the fundamental frequency of tube A will be NV by 2L. If you take tube B, one end is closed, the fundamental frequency will be odd V by 4L. What is the ratio of the fundamental frequency if they are identical in nature? Okay, just take the ratio, guys. FA by FB, V by 2L, V by 4L. So it will be 4 by 2, which is 2:1. So 2:1, which means option number C. Yes, correct. Option C, which is 2:1. Very good. Let's go to the next question. A closed pipe gives 7 beats with an open pipe, both in the fundamental mode. What is the speed of sound? Very nice question. Let's try to solve this. If you take a closed pipe, which produces with an open organ pipe, now closed means it is closed on one side. Don't take it closed on both sides. So if it is closed on one side, the formula for the frequency will be odd V by 4 into the length. Length is 150 centimeter, which means 1.5 meters. Next thing, open organ pipe, that means it is open on both sides. Length is 350. So for that guy, NV by 2 into length. Length is 3.5 meters. Okay, so this will be nothing but V by 7. This will be nothing but V by 6. Obviously, V by 6 is more as compared to V by 7. It is clearly mentioned in the question 7 beats per second when both of them are together. So F1 minus F2 is 7. So therefore, V by 6 minus V by 7 is 7. Take the LCM. So 7V minus 6V by 6 into 7 is equal to 7. Is that right? Okay. Right? Okay. So this will be nothing but V divided by 6 multiplied by 7 is equal to 7. So V is equal to 7 into 6 multiplied by 7. How much is this velocity? How much is this velocity? Come on, my dear warriors. 7 sevens are 49 into 6. Well, 50 into 6 is 300. So take out 6 from it. So it will be 294. So 294 meters per second. Just check this out. Okay. Yes, the answer is 294. Perfect. The answer is 294. Very good. Awesomeness. Oh, it's break time because now after this we have 12th standard syllabus. I think 12th standard syllabus, not many topics are there. Okay, because 12th syllabus is much lesser than the 11th syllabus. So we'll be able to do it on time, hopefully. Okay, so we'll take a break quickly and then we will start with the 12th standard syllabus. Okay, we'll take a 10-minute break, guys. Welcome back, everyone. Wow, what a session it has been. And we started at 11 o'clock in the morning. It's going to be almost 6 hours. Are you guys all ready? J Advance is already ready to blast J mains. Somebody's from Coimbatore, Thanjavur. Wow. Hi, Ukule. Welcome back. Awesome. Welcome aboard. Everyone. Yeah. Perfect. Disaster ready. Padu 29th shift. Wow. You will get enough time. Nikhil from Andhra. Hi, Sriniti. Yes, your captive is back. Yeah, very good session. Thank you so much, Prem. Ready? Srinath, Shiv, welcome. Let's go. Now, starting off with Coulomb's law based questions. Coulomb's law in electrostatics, which is K Q1 Q2 by R square. Charges product divided by the distance square. K is the Coulomb constant, which is 9 into 10 to the power 9, which is having the formula 1 by 4 pi epsilon naught, which is permittivity, which is having the value of 8.85 into 10 to the power basically negative 12. Now, usually this permittivity can also change. The permittivity of any medium is permittivity of free space into K. This K is not the same as this K over here. This is your dielectric constant of that particular medium. Usually it will be like 2, 3, 4, 100, whatever, some value will be given, because of which the force can become less. The electric field intensity can become less when you place these same charges in a different medium. So the choice of medium decides the quality of the electric field and the electric force. That's a very common thing in electrostatics. Is that right? Okay. So let's do some questions based on the electrostatic force and all of that. And by the way, this force is also going to obey superposition principle and standard things. So the net force will be F1 plus F2, like that till the nth force. You can do this. You can also find the field due to this, and the field due to this particular force will be electric force divided by the charge. Electric force divided by the charge, that is the electric field value. How much force is there per coulomb of charge? Per coulomb of charge. Let's do some questions. This was asked in JEE 2024. In a hydrogen-like system, the ratio of Coulomb force and gravitational force between an electron and a proton is how much approximately? So if you take an electron and you take a proton, obviously the masses are also going to be different, but what is the ratio of the electric force upon the gravitational force? The electric force will be K Q1 Q2 divided by R square, whereas the gravitational force will be G M M divided by R square. Now obviously the question demands us to take the ratio of this. So the electric force divided by the gravitational force will be K by G. Here you will have E square, here you will have mass into mass. Now these values you can substitute and get it. K is 9 into 10 to the power 9, G is 6.67 into 10 to the power minus 11. Electron charge is of the order 1.6, 10 to the power minus 19. Mass of what is this? Electron is 9 into 10 to the power negative 31. Mass of a proton is close to 1.6 into 10 to the power minus 27. These are approximate values. You can just substitute it, and the value that you will get is 10 to the power 39. Best is to remember this value, because many times these questions come in different exams, state entrance, bids, so many places. So remember, it is 10 to the power 39 times stronger. So electric force is very, very strong as compared to the gravitational force. Is that right, everyone? Okay, cool. Moving on to the next question on your screen. This was also asked in J24. The force between two charges in vacuum is F. When you place a dielectric medium at R by 5 distance, what's the new force going to be? So if you ask me what's the old force formula for the distance r, it will be Coulomb's constant into Q1, Q2 divided by r square. Now when we find that new force, that Coulomb constant will now become divided by 5 and the charges are still the same. The distance is r by 5. So this will be r by 5 whole square. So 5 will cancel. K Q1 Q2 divided by r square by 5. One of the 5's got cancelled. So 5 will get multiplied in the numerator. Else you will have K Q1 Q2 divided by r square. This is same as this. So it will be that force multiplied by 5. So the new force is 5 times the old force. That is the answer, which is option A, I believe. Right, perfect. Whenever you have the dielectric medium constant given, always divide the older force by that dielectric constant, because the force always becomes lesser as compared to previous. It becomes weaker. Okay, I hope this is clear. Ramasekar, which part of the previous question you did not understand? Please let me know. This is electric force, charge on electron, charge on proton, K Q1 Q2 by r square. Gravitational force G m1 m2 by r square. When you divide both of them, r square will get cancelled out. So this is what you will get, K by G E square by mm. Correct? Coulomb constant this, gravitational constant is this, electron charge is this value. Mass of an electron, you should remember this. Mass of a proton is 10 to the power negative 27. If you remember these values, it will be easier. Else you cannot do this question unless you already know this value somehow. Okay, fine. Okay, next question coming up on your screen. Is on electric fields, different formulas. If you have electric field to be found for different things, all the formulas are given here. Remember, electric field is force per unit charge. Starting off with, due to a ring, if you have a charged ring on the axis of it, the formula is kq into the distance divided by r square plus distance square raised to 3 by 2 on the axis of the ring. Similarly, if you have electric field due to a large sheet, the sheet will have a charge density sigma. The formula is sigma by 2 epsilon naught. Sigma by 2 epsilon naught, it is a uniform field on both the sides. Keep this in mind. This was for the ring. And here this Z represents how far you are, and this is the radius of the ring. So at this point, how much electric field will be there? Here, in this particular thing, you have a charged sheet. The electric field will be here also and here also. How much electric field will be there is given by sigma by 2 epsilon naught. Okay, this is a charged sheet. Remember that. Okay. Similarly, due to a thin shell, shell means it is like this. This is the radius r. The charge is distributed only on the surface, or it's a conducting sphere, so charges are only on the surface. If you are inside, there is no field. If you are outside, it behaves like a point charge. So you just measure the distance from the center. It will be kq by r square if it is a shell. If it is a solid sphere, uniformly charged, meaning just visualize as if everywhere, even inside of it, there are charges everywhere scattered, okay, uniformly. Then this is the radius. If you are outside, then as if all the charges concentrated here, measure the electric field, so kq by r square. But if you are inside, then it is kq by r cube into r. So it is proportional to r, remember that. In fact, the graphs are also very critical over here. If you draw the graph of electric field with distance, that graph will be straight line and then it will go like this. Whereas for here, if you draw the graph of electric field versus distance, it will be 0. It will suddenly climb up and then it will go down. So that's how the graph looks like for a shell. If you remember the graphs also, often you will immediately recollect, oh, it was a straight line, so it is proportional to r. So to compensate the dimension, you will make it r cube below. R cube below. Okay, I hope this is clear. All right. Should we memorize all? Yes, you have to memorize all. Correct. There is no other option. Okay. Moving on to the questions. Infinitely long hollow conducting cylinder with radius r carries. Oh, ayo. Why magnetic field question came over here by mistake? No issues. By mistake, magnetic field question has come. Anyways, still we can do it. It's not like we should not do it. Uh, Anyways, so if you have, this is not a question on electrostatics, guys. This is a question on magnetic field. If the current is going only on the surface of that particular cylinder, okay. So question is, what is the magnetic field around it going to be? What is the magnetic field around it? Inside, what will happen? There will be no magnetic field. Inside, the magnetic field is zero. In fact, this cylinder behavior is very similar to this behavior of a shell. Inside the shell, there is no field, only outside there is. So the behavior is very similar. So inside it will be zero. So A, C and B graphs will go away. So as you can see, inside it should be zero. And once you go outside, the formula for magnetic field is mu naught I by 2 pi r. So it is inversely proportional to R outside. So as you can see, it is inversely proportional to R right over here. So it should be basically D option. Yes, it is the D option. Okay, this question shouldn't have been here, but it's okay. I mean, we all know magnetic field formula and all of that. Is that okay, everyone? Let's move to the next question. A particle is moving along a circle of radius r along an infinitely long wire. Yes, that reminds me, there was one more formula which was missed over here. So let me just add it. If you have a wire which is like this, and you are standing at a distance r from here, and you want to find what is the electric field, the electric field will have two components, Ex and Ey. This is a linear charge distribution. Some charges are there over here, uniformly distributed, and that charge distribution is lambda, which is the charge per unit length, lambda. Then all you need to do is draw a line from here to here, call this alpha, call this beta. This Ex will be 1 by 4 pi epsilon naught lambda by r. Here it will be sine of alpha plus sine of beta. Whereas Ey, the y component will be again 1 by 4 pi epsilon naught lambda by r. Here it will be cos alpha minus cos beta. From this you get, if it is an infinitely long wire, then alpha and beta both are 90 degrees, and the electric field will come out to be 1 by 2 pi epsilon naught lambda by r. This is the value that you will get for an infinitely long wire. Instead of 4, you will get 2, because when you put 90, 90, sine 90, sine 90, 1 plus 1 will become 2. 2 will cancel with 4, it will become 2 pi epsilon naught. That's for an infinitely long wire. I think this question is based exactly on that. A particle is moving in a circle along an infinitely long wire which is charged of density lambda. What's the time period going to be? K is the Coulomb's constant. So think of a very long wire. Think of a very long wire. This has positive charge on it and a particle of charge minus q. So that means negatively charged particle will get definitely attracted towards it, and this is going in a circular path like this, whose radius is basically r. So that will experience an electric force here that will cause centripetal acceleration like this. It will have some velocity over here, and or rather I will say it will have some angular velocity like this. So I can say by Newton's law, the centripetal force is mass into centripetal acceleration. This force will be electric field into the charge. Acceleration is omega square into r. Electric field due to an infinitely long wire is 1 by 2 pi epsilon naught lambda by r. Q is here, m omega square r is here. So bring R and M on this side. 1 by 2 pi epsilon naught, I can write it as 2 by 4 pi epsilon naught into lambda by R square. And M is also going to be here. Q is going to be on the top. This is omega square. What is this? This is 2 into K. 1 by 4 pi epsilon is K, Coulomb's constant. Lambda Q divided by R square M is equal to omega square. From this, I will get omega, which is the root of all these things. So the root of 2k lambda q divided by r square m. But omega is 2 pi by time period. Omega is nothing but 2 pi divided by time period, and we want the time period. So time period will be 2 pi under root, time period will be 2 pi under root r square m divided by 2k lambda q. That is what it will be. If you want take r outside also, that is okay. So that is going to be D option, I believe. Yes, perfecto. D option is correct. 2k lambda q, m is there, r can be taken out, so it will become 2 pi r. Is that right? Yes. We can do it by dimension, but it might be little bit difficult at times to go by dimensions because these are all weird things. Coulomb's constant has some unit and all of that. Next, let's go to the next question. Capacitance. Capacitance of a device, any device which can store charge and it will store energy between those two conductors, is called as a capacitor. It will basically store charge and electrical energy between those conducting plates. And the charge stored on a capacitor is given by capacitance into the voltage difference between those two plates or conductors. Capacitance is measured in farads if charge is in coulombs and plate voltages difference is volts. Now, if you have a parallel plate capacitor, the formula is epsilon A area of the plate divided by the distance of the plates. If you add some dielectric medium over there, then you can multiply this with K, which is the dielectric constant, which is the dielectric constant of that. This is one major formula which you should know. Now, when you store that energy, how much is that energy? That is given by half CV square or Q square by 2C or half QV. All formulas are the same because Q is CV. That formula, if you use and substitute it here, you will get any of these combinations. There is also a formula over here for electrical energy density, which is given by half permittivity into electric field square. So this is the energy density. Energy per unit volume is half epsilon naught E square is the electric field. This is also seen in this particular chapter. If you combine capacitors in series, use the resistors in parallel formula. If capacitors are in parallel, then use capacitors in resistors in parallel, resistors in series formula. It's exactly opposite of resistors. When capacitors are in series, it is the charge which is going to be the same, and it is the total voltage which will be V1 plus V2 plus Vn. In parallel, the voltage will be the same and the total charge will be Q1 plus Q2, like that for all the N capacitors. Is that right? This is what is going to be. Any method that you know for finding equivalent resistance, be it Wheatstone, be it disguised form, be it Wheatstone's bridge, or any series parallel combination trick that you have learned, all the things, Kirchhoff's laws are still valid for capacitors, are still valid for capacitors. Also, the standard most problem, if you take a battery of voltage E, take the switch and take this capacitor and charge it. If the energy stored in the capacitor is half CE square, then the work done by the battery will be CE square. So you might be wondering, if battery did CE square work, energy stored is half CE square, where did the other half of CE square go? It will go in basically heat loss. So when you charge a battery by closing the switch, you will see half of the work done by the battery only gets stored and the other half is going to get lost in the wire's resistances. This is also very, very important. All right. Oh my God, who is this? Okay, don't worry. This I'll ask the moderator. Yeah, don't worry. The moderator will block them. Yes. So make sure, guys, please don't spam like this. It is not great. I mean, other people are studying here seriously. Don't spam over here unless you really have something to ask. Will you post this video? What do you mean by will I post this video? This video is already live, no? What do you mean by that? Who told you 28, 29 shifts are tough? Who are these people who are telling you all these things? 28, 29 will be tough. 24, 25 will be easy. Based on the past year trends. Guys, please stop watching all such videos. I mean, really, no, nobody will, nobody will be able to guess such things. Okay, so don't waste your time. Chumma, that 24th will be easy because it is the first day. They don't want to scare you. What they are, NTA people are doing some favor on you by keeping the paper easy on the first day because you will be shocked. Do you think they really think so much? No, nobody thinks so much, guys. Yeah, so please don't waste your time so much. They will not do this kind of analysis. Oh, the last day people would have seen all the shifts, so they know all the questions. So I have to make a different question paper set, and it has to not match with any of the model papers. It has to be way tougher. Students will think it will be easy, so we'll make it tough. I think these kind of mind games, they have really time. They can't manage so many things properly. Oh my God. Yeah, many YouTube didis and bhaiyas only. Basically, didis and bhaiyas. Correct, you are right. Because first of all, they would not have even gone into that graduation mode. They would not have completed their graduation, and before graduation only you start making these videos. I mean, you should be teaching in that JEE batch for at least 2 years, 1 year, at least 1 year, 2 years. You should have taught. Then you will know that all these things you will never say. Okay, let's move. Figure shows charge versus voltage for the two given capacitors. The capacitances are what? Okay, so charge versus voltage is given, and we know Q is equal to C into V. So C is equal to Q divided by voltage. So if you talk about the first capacitor, which is A, so the capacitance A will be charged by voltage. So I can take the voltage as 10. Charge is basically 500 micro. Voltage is 10. So it will be 50 microfarad. So 50 microfarad is only there in one option, as you can see in C option. You don't even have to do the other thing, but on the safety side, if I were to find capacitance B, charge will still be how much? 80. So 80 micro divided by 10, which is basically 8 microfarad. So that is option C, of course, very straightforward. Moving on to the next question. Believe me, this question came in JEE 2019. Yeah, there you go. Thank you, Srinidhi. All right. What is, oops, sorry, why the slide goes off? 8 drops combine, the capacitance is how much? Now, this kind of questions, no, they are based on this concept where if you have a sphere, this is an spherical, isolated spherical capacitor. If the radius is r, then the capacitance is given by 4 pi epsilon naught r. Just like you have parallel plate capacitor, this is spherical capacitor. That's all. Now, if you are going to combine 8 drops into one big drop, so the volume will be conserved. So 8 times volume of that small drop will be the volume of that big drop over here. So 8 times of 4 by 3 pi r cube is 4 by 3 pi capital R cube, which means 4 by 3 pi cancels. So 8 small r cube is capital R cube, taking cube root, 2r is equal to r. So the radius has been doubled. So think about it logically. If radius is made 2 times, the capacitance will also be made 2 times. So hence the answer will be 2 times. Very straightforward. Okay, very good, Anandu. Disaster. Oh, where am I from? Right now I'm in Bangalore, but I was born in Salem. I have did most of my education in Pune, Mumbai, Nagpur. Yeah, that's how it is. Okay, moving on to the next question on your screen. Two capacitors are charged and they're charged with different voltages. Then they are connected in parallel. The positive is connected to the negative. Oh my God, the final energy is. Yes, these kind of questions are also going to be very, very common. Oh, you are also from Salem, Sravesh. Welcome. Nice to see many people from Salem. High five. Yes. Born Tamilian. Born a Tamilian. Being working as doing service from Karnataka as a Kannadiga, uh, done my education from Maharashtra, and obviously all my uncles and everyone being IITians. Yes, most of my family is from IIT, either IIT Bombay, IIT Kanpur, and all of that. So many of my family members and majority of them are from Andhra. They were born and raised there in Andhra. So I'm really proud to be a South Indian and doing this work for all the South Indians out here who want to learn in English, because nobody understands all of us better than us, and we know the importance of having dedicated classes in English, and the importance of uh, learning in our local languages also at the same time, and having the best teachers, not any random teachers. Yeah. If I was born in Tamil Nadu, I can't be born in Kerala, but I wish maybe next life in Kerala, right? Okay. So how do you do this question? We have two capacitors. This capacitor is with voltage V, so the charge on it will be CV. Another capacitor 2C is charged with voltage 2V, so the charge on it will be 2C into 2V, which is 4CV. Now what you do, you take this capacitor, positive, negative, connect it, not yet connected now, but it will be connected slowly to another capacitor 2C. This is negative, this is positive. So when you do that connection, here is the magic which happens. By the way, these two capacitors together will behave like one single capacitor. This will behave like one single capacitor of equivalent capacitance. How much? They are capacitors in parallel. So capacitors in parallel. So C plus 2C, which is basically 3C. Is that right? They are capacitors in parallel. Voltages will be same. Eventually, they will have some charge stored on them. And this can be converted into one single capacitor, which is C parallel. This is C, this is 2C. Okay, so how much will be the charge stored on them? How much will be the charge stored on them? That will be, because the positive is connected to the negative, positive is connected to the negative, it will be nothing but 4CV minus CV. Why this minus? Because the positive charge will cancel with the negative charge. The positive charge will cancel with the negative charge. That is the reason why it should be minus. If positive connected to positive, the charges will add. But positive charge and a negative charge, think about it. Actually, it is addition only, but you are adding the negative charge. Think of it like this. So hence it will become 3 times of CV is the new charge. Parallel capacitance is 3C. Question is, what is the final energy of the configuration? So, my dear warriors, the final energy will be half Q square by C parallel. Q is basically 3CV, so 9C square V square. C parallel is nothing but 3C. Okay, 9 by 3 is 3, 2 as 2, CC cancels, and V square. So 3 by 2 CV square, which is D for IIT Delhi. Very good, we got the answer. Is that right? Awesome. Thank you for all the love, Rahul Bhatt from Kashmir. Thank you so much. All right. Wow, and I'm pretty sure some of you are already asking the weather. I can't even imagine how it must be in Kashmir right now. We are freezing out here, even in Bengaluru, because there is a cold wave going on. But yeah, I'm pretty sure it must be lovely with all the snow to look at and doing all the snow activities and experiencing the snowfall, the frozen Dal Lake, and whatnot. Yeah, and Gulmarg and Sonmarg must be beautiful too, with looking at the beautiful rivers with fresh water flowing through those scenic mountains. Must be amazing, must be such a picturesque view, isn't it? Moving to the next question. What is it? There are parallel plates, one in front of the other with different distances between them, stair-like structure. Who thinks of such things? And the capacitance of the arrangement is how much? Okay. Now, now, yeah, we will complete the syllabus. Good boy. Like a good boy, we will complete it. Don't worry. So, how do we do this? There are multiple capacitors, like you can see. This is one capacitor. Then this is one capacitor. Then this is one capacitor. Here the area is A, the distance is H, 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 H. So it is basically 5H is that distance. Here H, 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 3H is that distance. And here it is just H. Is that right? So they are all in parallel because the potential differences are same. So think as if they are all in parallel. So C parallel will be C1 plus C2 plus C3. The first capacitance, if you talk about it, it will be having a capacitance of epsilon naught A by distance, which is H. The next capacitor which we have will be having epsilon naught A by basically 3H. The last capacitance will be epsilon naught area by basically 5 times of H. So this is all going to be like LCM. So this will be basically 15 times of H. You will also have epsilon naught A common. H will go here 15 times, here 5 times, and here 3 times. 15 plus 5, 25 plus 3, 23. So 23 epsilon naught A divided by 15 times of H. So whatever that is, 23. Yeah, answer is 23. Very simple, guys. Do you understand why they are in parallel? Because this, and this are connected side by side. They are all connected by the same wire. So potential difference here, here, and here will be the same. Got it? Why they are in parallel? Everyone? Yep, very good. Sir, will the written solutions be on the notebook? You want me to give the handwritten solutions also in the PDF? No worries, I will give you that. Okay, so the PDF, I'll give you the same annotated PDF so that it will be easier for you to revise. Let's come to Kirchhoff's laws. Yes, 6 hours now. Yes, I know, 6 hours already done. Wow, that is crazy. Yeah, Mary Grace. All right. So Kirchhoff's law. First, Kirchhoff's law is based on the conservation of charge, which says that whatever current comes in at a junction is the total current coming out. Simple. Next law is based on conservation of energy, which says that if you go around a loop and you keep adding the voltages across all the devices, the total voltage sum will be zero. Because somewhere the voltage will drop, somewhere the voltage will rise, but when you come back, the net voltage drop will be zero. Remember, the voltage drop across a battery will either be plus or minus E. The voltage drop across a resistor will be plus or minus IR. The voltage drop across a capacitor will be nothing but plus or minus Q is CV, so Q by C. The voltage drop across an inductor will be plus or minus L di by dt. So these are the main things which you should remember for voltage drops or voltage increases. Now whether to take plus or minus, that is very obvious. Like if you are going from negative terminal to positive terminal in the circuit of a battery, you're obviously increasing the voltage. So plus E. Opposite will be negative. Current, when it flows through the resistor, it will always drop the voltage. So in the direction of current, the voltage drops, against it will increase. Capacitor is very obvious because positive and negative plates, if you assume it positive negative, from positive to negative it will drop, negative to positive you will climb, so it will be plus 10. So that is how the sign convention is for this. And remember, show the starting point so that you know where to stop, or else you will keep on going round and stop somewhere else. So please mark the point when you are using Kirchhoff's laws. This is by far the easiest of it. So I think we have some questions on this. Yep, we do have. So my dear students, the question is as follows. The question is basically two batteries of EMF 4 volt and 8 volt with internal resistances 1 ohm and 2 ohm are connected in a circuit with a resistance of 9 ohm as shown. The current and the potential difference between the points P and Q is how much? Voltage difference between the points P and Q. Do you see both these batteries are in opposite directions? Okay, so let's say we start from point Q and go around the circuit and come back to that particular point, or we can even go like that, no issues. So let's assume the current to be like this. We start from point Q, the current is like this, the current is coming like this. So start from here. First time the device you encounter is a resistor, you are going in the direction of the current, so the voltage will drop. How much? Minus I into R. R is 2. Next battery, negative to positive, so it will increase by 8 volts. Next, another battery, positive to negative, so it will drop by 4 volts. Next, what is it? This particular 1 ohm resistance. This particular 1 ohm resistance, you are going in the direction of the resistance, so minus I into 1. And again 9 ohm resistance, so minus I into 9. And you come back to the same point, so that is basically 0. 8 minus 4 is 4. Minus I, minus 9I, minus 10I, minus 2I, so it will become minus 12I is equal to 0. So 12I is equal to 4. So I is equal to 1 by 3 amperes. That's it. This job is done. So current is done. Now the question is, what is the voltage difference between points P and Q? The voltage difference between those 2 points P and Q, won't it be the same as between this point and this point? Won't it be the same as between this point and this point? So it will be the voltage difference between R, so which is nothing but I into resistance. Current is 1 by 3, resistance is 9 ohm. So it will be basically 3 volts. Yes, it will be basically 3 volts, which is the correct answer. 3 volts and 1 by 3 amperes. Got it, my dear students, how we do this question? Very nice. Perfecto. Let's move to the next question then. For the given arrangement, what is the value of the current? What is the value after applying the Kirchhoff's laws? All right, Deepu will try to put the timestamps. No issues. Okay. On 21, this video which is seen by 2x speed is yours video. I mean, what do you mean by that? Yes, this video is good enough to revise most of the syllabus. Why not? I mean, I'm covering all the topics which are important, and so many topics are there. Close enough to 100 concepts, I think we would have done today. Yeah, 100 concepts is like great. I mean, there are hardly 25-30 chapters, and each chapter we are doing some 3-4 topics, subtopics in that. So it's a big thing. Just imagine. On an average, we are doing 3 to 4 subtopics or concepts from every single chapter on an average. That's a big revision milestone, guys. What is the current I over here? Okay, so this is 5 amperes, this is 2 amperes. So at this junction, if 2 amperes goes here, this will be 3 amperes. So at this junction, 5 and 3 will make it 8 amperes. 1 and 4 at this junction will make it 5 amperes. At this junction, 8 and 5 will make it 13 amperes. At this junction, out of 13, 3 goes here. So this will be 10 amperes. Is that right? Just check this out. Did we do any mistake over here? 5, 2, 3. Yes, 5 is 3 plus 2. 3 comes here, 5 comes here. 3 plus 5 is basically 8. Correct? 1 here, 4 here will make it 5 amperes. 5 from here, 8 from here. That will make it 13. Out of 13, 3 goes here. Obviously, 10 will be remaining here. None of the options are matching over here. So let me just erase this. It won't be 6. Yes, it will be 10 amperes. Just check this out, everyone. Confirm. Done. Yeah, Dilly, if you do all these concepts, 99 percentile, paka. Yeah. Okay. Cool. Very good. Very good. Very good. Okay. Everything fine, guys, over here. Just check this out. This is 5 amperes here. Not, Unless that 5 amperes was on the top, then it is a different story altogether. Okay, this 5 will go into 2 and 3, correct? This 3 and this 5 together will make it 8. 1 and 4 will make it 5, correct? And 5 and 8 will make it 13. 13 will get divided into 2. Unless this 5 was on the top, then the whole story will change. Then what will happen is, if assume that this was 5 amperes, then this thing over here will be 4 amperes as per this junction, because 1 ampere is going here. Out of 4, 2 is going, so this will be 2 amperes. 2 and 5 will make it 7 amperes here. 1 and 4 will make it 5 amperes here. 5 and 7 will make it 12 amperes here. Out of 12, 3 is going, so this will become then 9 amperes over here. So that will be a completely different thing. Okay, I hope this is absolutely clear, depending on what the question is. So moving on to the next question coming up on your screen. Here it is. Resistors having values R1, R2, R3, ratio of I3 by I1 is how much? I3 by I1 is how much? Okay, interesting question. So what I can do is, over here, these two resistors are in parallel, and at this point I can apply Kirchhoff's current law. So I1 will be I2 plus I3 using Kirchhoff's current law. In this particular loop, if I apply Kirchhoff's voltage law, what I will get is negative I2 R2 plus, because I'm going against the direction of the current, plus I3 R3 is 0. So therefore I2 R2 will be I3 R3. So therefore, what do we have? We have to find I3 by, okay, so let's say I2 by I3 will be R3 by R2. Okay, that is what I will get. Now I2 plus I3 is I1. Okay, so let's apply componendo property. So I2 plus I3 divided by I3 will be R3 plus R2 divided by R2. I have applied componendo property, which you have studied in mathematics, basic maths, wherever you have studied it. So what will this become? I2 plus I3. I2 plus I3 is nothing but I1. I just wrote it here. So this is basically I1. So this whole thing divided by I3, I1 divided by I3, because I1 is I2 plus I3, perfect, is equal to R2 plus R3 whole thing divided by R2. R2 plus R3 whole thing divided by R2. So the question is I3 by I1. The question was I3 by I1. So it will be R2 divided by R2 plus R3, which is B option. Okay, the inverted ratio. So therefore I3 by I1 will be R2 divided by R2 plus R3, which is obviously this option. Perfect. Kirchhoff's current law, Kirchhoff's voltage law to the rescue. Meter bridge, based on the Wheatstone's meter bridge concept. Based on the Wheatstone's balancing concept is nothing but where R1 by R2 is equal to R3 by R4, which can be also written down as balancing length by 100 minus the balancing length. Here the resistances are as follows: 55 by R, left by right is left by right. Left side length is 20 centimeters. So it will be, right side length will be 100 minus 20. So R will be nothing but 55 into 100 minus 20 is 80, whole thing divided by 20. 20 goes with 84 times 55 into 4 is 220 ohms. So hence the answer should be 220. Perfect. Very good. Many of you got it. Yeah, because everybody loves this kind of questions, isn't it? Very nice. Awesomeness. Shall we go to the next question? Current electricity has the maximum weightage. Keep this in mind. Moving on. The reading of the ideal voltmeter. Ideal voltmeter means it will not take in any current. So ignore, forget that there is a voltmeter. Just imagine only this much circuit is there. And the question is, what is the voltage between this point and this point? So I think we have to look at only the outer circuit only. Just look at the outer circuit, and then you will realize if the current in the outer circuit is I and you go around it once, okay, you just go around it once, you can apply Kirchhoff's law. Let's say start from here, Kirchhoff's voltage law. Start from here, the current will cause a difference of minus I into 20. Here positive to negative, so minus 4. Here again drop of minus I multiplied by 10. Here it's an increase of plus 10 and you are back to point A, so that's why 0. Minus 4 plus 10, so 10 minus 4 is 6. 10 and 20 will make it 30I is 0. So 30I is 6, or I is basically 6 by 30, which is 1 by 5 of an ampere. Once I get this, I can find the voltage shown by the voltmeter. That will be voltage between points A and N. That will be, start from here, let's say. So there is a drop of minus current into 20. Then there is a drop of 4 volts over here. Just take the mod value. I'm not interested in the sign. So current is 1 by 5, 20 plus 4. So it will be equal to, what is it? 4 plus 4, which is 8 volts. So 8 volts should be the answer. Let's check it out. Yes, it is the correct answer. I'm ignoring the minus sign because what will I do with that minus sign? I'm just interested in the voltage difference. That's all. Thank you, Pratham. All right, moving on. Next question coming up on your screen. Galvanometer concept, where most of the times the question comes on ammeter. How do you convert ammeter into a how do you convert a galvanometer into an ammeter? And the idea lies in the fact that your galvanometer has some coil resistance. This is the coil resistance, and it can only allow some amount of current, which is the full scale deflection current. So if you have to measure huge current, let's say that is I, you bypass most of the current through another resistance called as the shunt resistance. So this resistance will have a current of I minus I max through it, and that's how you will be able to measure this without damaging the galvanometer. This is the main concept, and as you can see, this resistor and this resistor are in parallel. So mainly you will use Rg is going to be parallel to the shunt resistance. So you can use all the concepts of parallel circuits, like 1 by R is 1 by R1 plus 1 by R2, or voltage difference is same, or the current will be inversely related to the resistance. Anything, every time you will get the answer. Don't sit and by heart any of these things. It is useless. Just remember this diagram and understand the concept how you are bypassing it. So usually this will be the range. Usually this will be the range of that ammeter. This will be the full scale deflection current, coil resistance, shunt resistance. This is how the values will be given to you. Is that okay? Yes. Is there any crash course for JEE Advanced plus the April attempt? Wise, yes, we do have the crash course for JEE Mains plus the JEE Advanced, and that is right over here in the description box. As you are watching this particular video, you can go down over here. Do you see JEE Crash in English medium? That is the one. Okay. Now this particular batch is right now there for 999 rupees. All right. It will be purely in English. Okay. And you can see the batch has just started on 23rd December. Whatever lectures you missed, you can watch it as recorded, and you will get access till your JEE Advanced. If you clear mains, only then you will be allowed in the advanced batch. That is natural. Okay. So this is the batch which you can go for. But if you want, no sir, I want it, I want more features in this, then you can go for Crash Pro or Crash Pro Plus, where you will get printed material and one-on-one doubt solving. This is the batch you can go for. All right. But if you are more interested in only advanced, you think, no, sir, mains is okay, sir, I can clear it. I know. I just want only JEE advanced related, preparation. Then go for the Ekalavya JEE mains plus advanced. This is the link. Click on this, and you can see this particular batch starting February 2nd is for 14,000 rupees. This is more on the advanced side, always going to be advanced side. Mains is a byproduct of this. But if you are interested, no sir, first I want to clear mains, then I will think about advanced, then this is the JEE crash. Okay, I have made it absolutely clear. Cool. Fine wise. All right. How to identify short circuits? Just see on a wire, if there is a wire, all the potentials are same. If there is a wire connecting different points, all those points will have same voltage, number one. If there is a line of symmetry, then anywhere on the line of symmetry, the voltages will be the same. So if there is a symmetrical circuit, if you see this point and this point are exactly identical, then you can short them off. You can connect it with a wire, or if there is a device connecting them, because the voltages are same, you can disconnect them completely. Okay. In fact, you should check the lecture on equivalent circuits, which I have done on the channel itself. Just check this lecture out. Okay. So on the home page only you will be able to see. This is the complete physics playlist. Go down over here. Yeah, just check this physics playlist. Go down. Almost all the chapters are there. Yeah. Where is current, electricity? Yeah. Equivalent resistance and capacitance. I have conducted a special class on just finding equivalent resistance and capacitance. In that, I have explained all the varieties of problem: cube problems, short circuit problems, symmetry problems, non-symmetry problems, Wheatstone, everything is there over here. Just check that lecture out. It will be very, very helpful. Okay, cool. All right. So let's do a question then, so that you understand. Galvanometer is in series with 400 ohm. Okay, measures a voltage up to 10 volts. The value of the resistance to convert it into an ammeter to read up to 10 ampere is how many ohms? A galvanometer of resistance 100 ohm when connected in series with 400 ohms measures voltage up to 10 volts. Just think about it. This is your galvanometer, which is of 100 ohms. If it is measured if it is connected in series like this, then it can measure only up to 10 volts. From this, I think I can get the value of the maximum full scale deflection current, because V is equal to I into R. So it is Rg plus that series resistance. V is IR, correct? So I max multiplied by 100 plus 400, which is 500. So I max will be 10 divided by 500, which is 1 by 50 of an ampere. Okay, perfect. Now you want to convert it into a ammeter. Okay, so this is my galvanometer, which is of 100 ohms. This is your galvanometer. Okay, it can only allow current up to how much? 1 by 50 of an ampere. So now imagine you want to measure currents up to 10 ampere. So 10 ampere current is entering in. So you will bypass most of the current like this. Is that right? Bypass most of the current like this through a shunt resistance, which value I do not know. So out of 10 amperes, 1 by 50 amperes goes here. How much current will go over here? It will be 10 minus 1 by 50, which is still going to be 10 amperes only. Because 1 by 50 is a very small number. So ignore that small number. So it is going to be 10 amperes. Now, since both of them are going to be in parallel, so therefore the voltage drop will be the same, which means the voltage across the shunt resistance will be R into I. I is basically 10. Voltage across the galvanometer will be R into I. I is 1 by 50. So from this, what is the value of the shunt resistance? 0, 0, 0, 0 cancels. So it will be 1 by 5 ohms. Is that so? Just check this out. Something wrong. 100 into 1 by 50. is equal to Rs into 1 by 5. Oh, yeah, it is fine. The value of X is asked. So if it is 1 by 5, it will be 0.2 ohms. So it will be 20 into 10 to the power minus 2 ohms. So the answer will be 20. Correct, because they have asked it as a number multiplied by 10 raised to minus 2. So perfectly fine. Yes. Cool. Everyone, shall we go ahead to the next question? Here it is. Galvanometer, 200 ohm, full scale deflection, convert it into 20 milliamperes range. Again, similar question, guys. See what you will do. You have a galvanometer whose resistance is 200 ohms. Full scale deflection current is 20 microamperes. You are sending in how much current? 20 milliamperes of current. You will bypass most of it. Like this. So through this shunt, so the current which will go here will be 20 milliamperes minus 20 microamperes, which is then approximately 20 milliamperes only. Now again use the same concept, because they are in parallel, therefore voltage difference will be the same. So what will you say? The voltage across the shunt will be IR. IR is 20 milli. Milli is 10 to the power minus 3 into resistance. Resistance is RS is equal to current into resistance. So current is 20 micro minus 6. Resistance is 200. So the value of RS, how much will it be? 20 cancels. Yeah, correct. So 10 to the power minus 3, 10 to the power minus 3 will also cancel. Yes. So Rs will become 200 into 10 to the power minus 3. Correct. So 200 into 10 to the power minus 3, which will make it 0.2 ohms. So 0.2 ohms is C for Capto, C for Captain Shreyas. Perfect. That is the answer. Very good, Disaster. Very good, Pavan Bhushan, Anandu, Swagitika, Girish, TGB. Very good. Awesome. Adarsh. Yes, C for Capto, Shreyas. Very nice. Let's go to the next high weightage concept, which is basically coming to AC circuits. We are coming to AC circuits, discussing impedances, capacitive reactance, inductive reactance, power factor, and special cases, of course, and the energy density which is stored inside an inductor. Okay, so in AC circuits, remember the voltage and the current may not climb up and go down together. There might be some phase difference. That phase difference comes because of either inductor or capacitor. A resistor can never create a phase difference. Keep that in mind. A resistor will make sure current and voltage are in phase. Now, resistor, although will not create phase difference, but that is the only element which can cause the power to be lost. Inductor can store the energy in magnetic form. Capacitor can store the energy in electrical form. So they too can't lose energy. Only resistor causes the loss of energy. Because in a AC, the currents voltages are varying continuously. I am thinking, is the voltage more or less? So for that, we define something called as the RMS value. RMS value gives me that value of voltage or current which will behave just like the DC, dissipating the same losses. So RMS is usually the maximum by root 2 for a sinusoidal voltages. So maximum peak V naught by root 2 or I naught by root 2. So when I do that I naught by root 2 or V naught by root 2, that value is the same constant DC current which will produce the same loss as that of the AC current. Is that okay? These are some basic things about AC. You will have some frequency of the AC, which is F, and if you multiply 2 pi into F, you will get angular frequency, just like in SHM waves and other things. Now, a resistor resists the current. Inductor and capacitor do not actually resist the current, rather they might resist the change in current or the flow of charges in some other way for AC, and that is why you will have an equivalent resistance for inductor or for a capacitor, which is called reactance. Now, reactance resists the current for AC, but it is not a resistor. Please mind it. A resistance is basically the opposition to the flow of current and causes heat loss, I squared R. But a reactance might oppose the AC current only, but it does not cause heat loss. So it is wrong to humiliate the inductor or capacitor by calling it a resistance because it is not causing heat loss. So we give it a different identity called as reactance. So XL is omega L. Omega is angular frequency, L is inductance. For inductor, for capacitance, the resistance equivalent is 1 by omega C. Keep these formulas in mind. Now, when all the three components are together, resistance, reactance for inductor and capacitor, then together the total resistance to the flow can't be called resistance because one of it is reactance, can't be just called reactance because one of that is resistance. So that total factor is called impedance, which is R square plus XL minus XC whole square, whole thing under the root. If you ever get confused, remember this triangle. There will be resistance over here. There will be net reactance, which is XL minus XC over here. And this triangle, this will be Z, which is impedance, where this is the power factor. So you can draw a triangle like this, and this is nothing but Pythagoras theorem then. It becomes very easy. Okay, fair enough. All right. Moving on, next one. The power which is lost in that AC circuit is Vrms Irms into cos phi. Keep that in mind. Vrms Irms into cos phi, which can be also written down as Irms square into R, one and the same thing. This cos phi is called as the power factor. This particular cos phi is called as the power factor of that AC circuit. Now, keep this in mind, the power factor maximum value can be 1, and when the power factor is 1, it is purely resistive circuit, and such a circuit is said to be in resonance. Such a circuit is said to be in resonance. In fact, that graph of current versus different frequencies looks something like this. When the power factor is 1, this is when the omega value is 1 by root of LC for resonance. You will have maximum current, maximum power, power factor will be 1, everything will be in sync. You will see inductor's voltage will be capacitor's voltage. So the total voltage in the circuit will be just the resistive voltage. All these things will come into place at resonance. Is that okay, everyone? Right. Now, like I said, inductor stores energy, just like capacitor store electrical energy half CV square, inductor store energy half Li square, half inductance into the current square. All right. Keep these things in mind. So let's start with some questions coming up on your screen. Statement question, just read the question, guys, and tell me which one is the correct answer. Anandu, if you are scoring 105, that means you need to see some more high weighted chapters. You need to remove some of your silly mistakes. You need to better manage your time for solving only those questions which you should do. Ignore the other questions. Target 150 to 170 marks. Okay, don't target 200 also. Target 150, 160 marks like that. And only do those chapters which will give you 150, 170 marks. Enough. And just do those concepts. Practice many PYQs. That will give you that confidence. All right. What do you think? Well, the correct answer for this, should it be option C, where 1 is true but 2 is false? Reactance in a AC circuit is 0. It is possible that the circuit contains capacitor and an inductor. Yes, definitely reactance is 0. That means it is possible it contains capacitor and an inductor, because maybe XL and XC both are equal and opposite, so the net reactance will be 0. They basically end up cancelling each other out. Definitely possible. What about the second statement? In AC circuit, the average power delivered by the source never becomes 0. Never becomes 0. The average power delivered by the AC source can never become 0. No, it can become 0. In fact, in this particular circuit, the resistance is 0, so I squared R is 0, so the power is also 0 on an average, so it is 0. So definitely in a AC circuit, power can be 0 if there is no resistance, only inductor is there or only capacitor is there. So can never become 0, that is wrong. So one is true, but second statement is false. Yes, option C. No, it is not option B. Good evening, Amuda. Yep. If you are aiming for 170, oh, by the way, start with the next question. If you are aiming for 170, I am getting it. What will be my all India rank or percentile? 170 marks will take you very close to 98 percentile. That will be close to around 20 to 40,000 rank, around that range. That is what it will be. Also depends on how many students were there in your shift and all of that. And competition this year is around 14 lakh. We don't know April attempt whether it will become 14 lakh, become 16 lakh or more. So accordingly, for that same percentile, your all India ranking can change. Getting my point? See, 90 percentile or 99 percentile, let's say for 10 lakh might be 10,000 rank. But for 20 lakh, 99 percentile will be 20,000 rank. So the total number of students will also matter, which we have to wait and watch how much it will be for the April attempt. Okay. Sanjay, good evening. Welcome back. You can leave the math section, Raghav. Many students do that. But don't expect more than 190 marks. I mean, theoretically 200 marks, but usually some mistake will happen. 180, 190 is usually the score, even if you're a very good student. And yeah, so not trying to demotivate you, but just telling you practically 180, 190 is the limit of the score that you can expect, which is close to 98, 99 percentile. Coil of inductance, resistance, heat, magnetic energy stored. It loses heat. If it is losing heat, where will it lose heat? It will lose heat in this resistance. So power will be I squared R. Power is 64. Current I do not know. Resistance is 4. So I square is 16. So I is 4 ohms. Why do I need this current? Because I want to find the magnetic energy. The magnetic energy is half L I square. So is the inductance given? Yeah. 200 milli. Milli is 10 to the power negative 3. Current 4. So square. 200 by 200. 100 into 10 to the power minus 3 into 16. So this will be 10 to the power negative 1. So it will be 1.6. 1.6 joules. Perfect. Cool, everyone? That's right. Shall we go ahead to the next concept then? All right, let's go then. Let's go. Okay, so we are coming to now ray optics, all the formulas, standard formulas which are there. Okay, starting off with mirror formula, lens formula, and then lens maker formula and refraction through curved surface formulas. Usually they ask questions through that, and sometimes they also ask questions on total internal reflection, which I'll show on the next slide. Mirror formula, 1 by f is 1 by v plus 1 by u. Also remember, a radius of curvature is 2 times of f. Magnification is minus v by u, and also image velocity upon object velocity will be minus v square by u square. These formulas you must know, and the power of a mirror is given by 1 by f, but with a negative sign. These are the formulas which are completely associated with mirrors. Whereas for lenses, 1 by f is 1 by v minus 1 by u, and the focal length is given by the lens maker formula, where R1 and R2 are the radius of curvature of the surfaces of the lens. This is relative refractive index. So relative refractive index will be refractive index of the lens upon refractive index of the outside medium. Keep that in mind. It's a relative refractive index. If outside is air, then n in the denominator will be 1. Okay. Now for a lens, the magnification will be plus v by u, same formula but with opposite sign. Image velocity by our object velocity will be plus v square by u square, and the power of a lens in diopters will be 1 by f. Okay, instead of minus 1 by f, it is plus 1 by f. If you don't have two surfaces, you have a single surface which is curved, then you use this formula. So refractive index of the second medium by image distance minus the refractive index of the first medium by object distance is the difference of the refractive indices by the radius of curvature. This is refraction at a single curved surface. All right, everyone? Okay, very good. Awesome. Only yes, Mahalakshmi, even if you just qualify JEE mains, doesn't matter, or even if you get 99 percentile in JEE mains, doesn't matter. Ultimately, your JEE Advanced All India rank will decide whether you will get a particular branch in an IIT, okay, which is your JEE Advanced rank. JEE mains percentiles ranks do not matter. JEE mains percentile and ranks only matter when you are taking admission in NITs, government institutes, triple ITs, and all of that. Cool? Okay. Now, the total internal reflection concept, where you go from dense medium to the rare medium, dense medium to the rare medium, the sign of that critical angle is 1 by the refractive index. This is one of the most important formulas which you should know. Okay. Total internal reflection concept questions do come in the examination, right? And of course, Snell's law. Of course, Snell's law. Snell's law based questions can also come, where you have sine of angle of incidence upon sine of angle of refraction is 1 mu 2, which is mu 2 by mu 1, which is 1 by 2 mu 1, which is speed of light in the first medium by second medium, which is wavelength in the first medium by wavelength in the second medium. This is by far the most elaborate formula. Sometimes they ask you question on wavelength, sometimes they ask you to find the speed, sometimes they ask you to find the refractive index relatively, sometimes they ask you to find the angle. Anything is asked, use this equation, one of this will give you the answer. Okay, very good. Moving on to some questions. Here is the first question on your screen. Object is placed over here, and the question is, if it is on the principal axis, okay, of the focal length 10 centimeters, okay, a plane mirror is placed on the other side at a distance of 20 centimeter. Image produced by the plane mirror is 5 centimeters inside the mirror. The distance of the object from the lens is how many centimeters? That is the question. All right. Okay. Yes, class 10th reflection, refraction concepts can be used, definitely. Now, read the question. Object is placed on the principal axis of focal length 10 centimeters. Plane mirror is placed at a distance of 20. The image produced by the plane mirror is 5 centimeters inside the mirror. So, the image produced by the mirror is over here. This is image produced by the mirror, which means most likely the rays would have been coming like this. Oops. The rays would have been coming like this, but they got reflected, I believe. Or 1 second. If the image is produced over here, think of it like this. The rays were reflected like this. So if you extend it here, yeah, it got reflected. That's why the image was here. So most likely the rays were coming like this and like this. So these rays come here, they get reflected here, these rays go over there, and they get reflected like this. That's why they were able to produce the image over here. Is that right, my dear warriors? That means the lens was producing a real image over here, a real image over here, a real image over here, which acted like an object for the mirror, which acted like the object for the mirror, thereby producing the reflection here. So, if it is mentioned in the question, this is 5 centimeters, how much will this be? This will be also 5 centimeters, which means if this is 20, how much will this particular distance be? From 20, take out 5. So 20 minus 5, which is 15 centimeters. That means the image distance is 15 centimeters for the lens. Is the focal length given? Yes. So use 1 by V minus 1 by U is equal to 1 by F. 1 by 15 minus 1 by U is equal to 1 by 10. It's a positive focal length, it's a convex lens. So 1 by U will be 1 by 15. Take 1 by 10 on the other side. So LCM is 30. 15 goes 2 times, 10 goes 3 times. So this will be minus 1 by 30 is 1 by U. So U will be negative 30 centimeters, which means this distance will be 30 centimeters. Negative because this is on the negative side. Yes, perfectly. Yeah, the answer is 30 centimeters from the lens. Cool. That's how you can solve this question. Just doing some simple ray diagram gives an understanding of it. Yeah, very good. Let's move. Let's move. What is this? Radius of curvature of each surface of a convex lens having refractive index 1.8 is 20. Okay, radius of curvature is this much. The lens is immersed in a liquid of refractive index 1.5. The ratio of the power of lens in air to that in the liquid will be something is to 1. What is that value of x approximately? So when you are in air, the power in air will be 1 by focal length in air, which is refractive index of that lens, which is how much? 1.8. So minus 1. This will be 1 by R1 minus 1 by R2. That will not matter eventually. When you are in that medium, it will be 1 by F of that medium. That will be relative now. So 1 by 8 by 1.5 minus 1. Remember, I had told you this refractive index is always relative. Refractive index of lens by refractive index of the medium. Again, this will be 1 by R1 minus 1 by R2 over here. 1 by R2 over here. So this will be nothing but, okay, leave it as it is. Now they have asked you what is the ratio of the power. So divide both of them. So divide both of them. Power in air by power in the medium. This will anyways get cancelled out. So 1.8 minus 1 by 1.8 by 1.5 minus 1. This is 0.8. This is 18 by 15. 18 by 3 is 6. 15 by 3 is 5 minus 1. 0.8 is 8 by 10 multiplied by 6 by 5 minus 1. What is it? 1 by 5. So this will be 8 into 8 divided by 10 by 5. 10 by 5 is 2. 8 by 2 is basically 4. So it will be basically 4 is to 1. So answer should be 4. Yes, the correct answer is 4. Got it, everyone? Very good. These kind of questions and models are very, very common. Let me tell you that. Yes, they are very, very common. Very good. Let's go to the next concept, my dear warriors. Questions on constructive destructive interference in light waves, the intensity relation, the fringe width, and all these concepts are very common. Every time you will see this. See, you can always argue, sir, that question is also important. This concept is, yes, you can find, then you have to sit and study all the chapters, all the concepts, all the lines. But like I said, we are doing all the important things over here. There might be few things here and there, but that's okay. We are concentrating on things which will definitely give us 99 percentile. All right. So here we go. Part difference for Young's double slit experiment is d sine theta. D is the distance between the two slits of the double slit experiment. If it is constructive, the path difference will be integer into lambda, lambda 2, lambda 3, lambda 4, lambda, like that. But if it is destructive interference, minimum intensity, dark fringes, then it is odd times lambda by 2, because this will become 2n plus 1. 2n plus 1 is always an odd number. So odd times lambda by 2, that means lambda by 2, lambda 3, lambda by 2, 5 lambda by 2. That is what the destructive interference will create. If you want to look at any nth fringe, bright or dark, for bright fringe use n times lambda d by d. For dark fringe, odd number times lambda by 2d. That's what you will use. And that will also give me the fringe width, which is lambda d by small d. Wavelength into distance from screen to the slits upon the distance between the slits. Keep this in mind. Apart from this, you should know that the amplitudes act like vectors. If you have amplitude 1, amplitude 2, and this is the resultant amplitude, then if you know the part difference, this part difference can give you the phase difference like this. You multiply it by 2 pi, you will get the phase difference, and the resultant amplitude is a1 square plus a2 square plus 2a1 a2 cos delta phi, the whole thing under the root like vectors. Similarly, you can get the intensity, which is I1 plus I2 plus 2 root I1 I2 into cos delta phi. That is your resultant intensity. Keep this in mind. Also, intensity of any light wave or any wave is always directly proportional to the amplitudes square. Amplitudes square. If you have constructive interference, that means delta x is lambda, 2 lambda, 3 lambda, in general n times of lambda, then the amplitude is maximum, which is given by a1 plus a2, and the intensity is also maximum, which is root I1 plus root I2 the whole square. Whereas if you are talking about destructive interference, that means delta x is 0.5 lambda, 1.5 lambda, 2.5 times lambda, like that, odd times lambda by 2, then amplitude is definitely the least. It will be a1 minus a2 modulus, because I don't know who is big, and the intensity will be minimum, and it will be given by root I1 minus root I2 the whole square. Cool? That is what destructive interference. These are all important concepts from waves, interference, light, optics, all of that. Let's see some of the questions. There are two wavelengths in a YDSE. The distance between the slits is this much, between the screen is this much, the least distance where the fringes will coincide is where exactly. Very interesting, because there are two lights. Now what happens is, over here, imagine this is your screen. Imagine you are seeing the bright fringe over here, okay, of a particular wavelength, and another wavelength is also there, but that fringe width is not so big. So what happens? The fringe which is small will repeat very often, something like this, will repeat very often, something like this, whereas the fringe which is little bit bigger will repeat little bit less often, something like this, and the distance will also be different. But somewhere or the other, they will again coincide. Isn't that right? Somewhere or the other, again they will coincide, maybe after certain fringes. Initially they are coinciding, then they go offset, offset, and then finally they will coincide. That is what will happen, my dear warriors. So when they coincide, so if this is basically your central central bright fringe. Let's say they will coincide over here. This is n1th fringe of, let's say, wavelength 1 of wavelength 1, and let's say this is the n2th fringe of wavelength number 2. This is where they essentially coincide, where they coincide. Wherever they coincide, I can say that their coordinate will be the same. So the y coordinate will be equal for both the fringes. What is the formula for y coordinate? I just gave it to you right over here. I just gave it to you right over here. For the nth bright fringe, n lambda d by d, n times of lambda d by d, guys. So just use that. So this will be n2 lambda 2 d by small d. This will be nothing but n1 lambda 1 capital D by small d. dd cancels. So n1 by n2 will be lambda 2 by lambda 1. Wavelength 2 is 5500, 5500. Wavelength 1 is 7000000 cancels over here, correct? So n1 by n2 will be, well, with 5 it goes 11 times, with 5 it will go 14 times. So this will be 11 by 14. That means what? The 11th fringe of 7000 Armstrong coincides with whom? With the 14th fringe, of 5500 Armstrong. That is the meaning of it. So in order to find now what is that particular y coordinate, either use this or use this. It's completely up to you. Let's say you use this n1 lambda d by d. Anyways, this is equal to this. So n1 is basically 11. Lambda 1 is 7000 Armstrong. So 10 to the power negative 10. Distance between the slits is this much. And from the screen, how much is it? 1.5 meters, which is 150 centimeters. Small d is 2.5. So 2.5 10 to the power negative 3. That will give you the y coordinate, which will come out to be 462. Okay, so 462 into 10 to the power negative 5 meters. Is that okay, my dear warriors? Yep. Great. Yeah. Awesome. How much time more? Maybe 30-40 minutes, not more than that. Yeah. Coming to the next concept. Yes, we are on to modern physics. So guys, not more time is left. Yeah, we'll finish this fast only on time. So already 7 hours are over of teaching. So 7.5 hours maybe. Okay. De Broglie wavelength, electrons, de Broglie wavelength, kinetic energy and de Broglie wavelength, and relation between the de Broglie wavelength and momentum. Yep. Are these questions of means level? Yes. Means medium level, simple, easy, and medium. I'm not taking tough questions today. I'm telling you this openly, or else you'll expect sir told tough questions, but actually the questions are easy. No, I don't do all those nonsense things. There is a separate session which I have made with difficult questions, and also the NT Abhyas questions are very tricky. I hope you have seen both these sessions. If you have not seen, na, please check it out. It is there on the channel only. Yeah, just go to the live section. See, just few days back, JEE Mains NTS favorite questions. These have good, average, and difficult questions. If you are specifically looking for the difficult questions of, where did it go, yaar? Difficult questions, right over here. Then it is over here for JEE Mains. If you want only easy questions, that session is also there. Everything has been already made on the channel. Okay, so just have to go through it. All right, moving on. De Broglie wavelength. Acha, you are saying that these questions are, sir, very difficult, or you are saying that these questions are very, very easy? You should tell me that. Error 404. As per mains perspective. any particle which moves has momentum and it is given by mass into velocity. But a particle not only possesses momentum, it has a dual behavior, which is a wave-like behavior. Just like light, the light is an electromagnetic wave having wavelength, amplitude, frequency, wave speed, and all that characteristics of a wave like diffraction, interference, right? All these things. But light also possesses particle behavior which is called as a photon. Photon is the energy packet of light. It has a quanta of energy given by hf, h being the Planck's constant. Similarly, de Broglie hypothesized that just like light can behave like a wave and particle, even a matter can usually show particle behavior, but under certain conditions, you can see the wave behavior, which is called as the matter wave. This matter wave is not electromagnetic, it is not gravitational, it is not nuclear, it is a separate kind of wave. This matter wave has a wavelength given by h by p, h being the Planck's constant, p being the momentum. Usually the questions are on electrons and all of that. So usually when you have electron, this momentum, by the way, can be written down as 2mk, because kinetic energy is momentum square by 2m. So you can write it down like this. But usually this kinetic energy comes because you have accelerated the particle, charged particle like electron or proton. So this kinetic energy usually is going to be the charge, which is E, into the voltage. So then you will get this formula. But for an electron, mass is known, charge is known, h is known, 2 value is known. So the wavelength of de Broglie for an electron accelerated is given by 12.27 by root v. This wavelength is going to be in nanometers. Yes, this wavelength is going to be in nanometers. Is this clear, everyone? Okay, very good, awesome. Next important thing, oh, okay, directly with problems, because de Broglie does not have much things. So usually you will see de Broglie questions are there. Either they will combine it with magnetism, where the particle enters a magnetic field of radius r mv by qb, or they will give solo question, or they will couple it with electrostatics, where kinetic energy is charge into potential difference. Usually 90% of the times these questions are there as it is. Electron, photon, same energy. Ratio of the wavelength of electron to that of the photon is how much? Okay, ratio. This question was very popular, let me tell you guys. This was asked many times in different ways in many exams or shifts. So electron of mass m, okay, has energy E, and photon also has energy E. So if you talk about the photon first, that energy is hf, which is also hc by lambda. Okay, the ratio of the wavelength of electron to that of the photon. So this is the wavelength of the photon. So lambda p will be hc by E. Okay, keep this on the side. Then let's go to electron. Also has the same energy. Lambda of electron is h by p, but p can be written down as root 2m into E. Okay, so this is lambda of electron. The question is something else. You have to find the ratio. Okay, so the ratio means lambda p by lambda E. This is equal to hc by E, and this will be nothing but h divided by root of 2me. So let's see what do we get. H cancels, c root 2m, this is root e upon e. Root e will cancel, so you will get root 2m by e. That is your lambda p by lambda e. So c is there obviously, and you also have 2m by e over here. So that's it. That is option B, I believe, because they have asked electron by proton, electron by photon. So lambda E by lambda P will be 1 by C. This will be E on the top and 2m below. Yes, E on the top and 2m below. This is B option. Is that right, everyone? Very good. All right, very good. We can do next question, guys. before going to the next concept, there are these common questions which are based on proton, electron, deuteron, and all these things. So let me tell you this very clearly. Let me tell you this very, very clearly. See, when you talk about proton, the mass is m, charge is positive e. Deuteron, ion. Okay, proton is same as H plus. Deuteron is nothing but your positively charged isotope of hydrogen. Mass will be 2m, m being atomic mass unit. Charge will be still plus e. Then you have alpha particle. Alpha particle has mass 4m. Charge will be plus 2e. Keep this in mind. Whereas when you have an electron, okay, the charge is negative e, the mass is negligible. The mass is negligible. It's very, very small. Whereas positron, just like electron, same mass as of electron, but the charge is going to be plus e. These things you must know for solving most of the problems. Yes, alpha particle is nothing but helium plus. Helium double plus. Yeah. Is that okay? All right. Now, what kind of questions do come on this? Like, say, for example, the question is like, an alpha particle and a proton is accelerated through voltage V and 2V, and they enter a magnetic field which is perpendicular. Find the ratio of their radii, of their paths. Number one. Also, the question can be the ratio of their de Broglie wavelength. These kind of questions are very, very common. So let's try to solve this. First things first, if you want to find the ratio of the radii of their paths once they enter magnetic field, radius is given by mass into velocity divided by q into b. Charge is different, mass is different, speed is also going to be different. Remember, these are not speeds, these are voltages, so be careful. So how do I find the speed? Let's think. First of all, the kinetic energy will be coming from the potential energy. So kinetic energy will be the charge into the voltage difference. Kinetic energy will be half m velocity square. Potential energy will be the charge into the voltage difference. Okay, so V will be root of 2q delta V divided by m. So use this over here. Root 2q delta V divided by m. So R will be equal to m. V is this one divided by QB. Therefore, what will happen? MM will cancel, QQ will cancel. Only 1 by B will remain. And here you will have 2 delta V. Charge will cancel. So Q will come below. Mass will cancel. Mass will remain below in the root. This is what it will be. From this, you will understand that radius of alpha by radius of proton will be directly proportional to voltage differences. So voltage difference of alpha by voltage difference of proton directly proportional to root of mass. So mass of alpha by mass of proton inversely proportional to root of charge. So charge of alpha below, charge of proton over here. What is the voltage of alpha? Alpha is basically V, of proton is basically 2V. Mass of alpha is basically 4m, of proton is m. Charge of proton is E, of alpha is 2E. So what will this be? 1 by root 2 into root 4 is 2 into 1 by root 2 into root 2, 2 cancel. So 1:1. The answer will be 1:1. The radius will be the same. Is that right, everyone? Okay. All right. We will I will confirm that AI Techie. I also got that notification saying that there are some rumors saying that the state board entrance examinations will be preponed. I was also surprised. Let me just complete the session and then I will talk about it. The next part of this problem, is comparing the de Broglie wavelength. So how do you do this particular question? Observe. Now the de Broglie wavelength is Planck's constant by momentum. Momentum is root of 2mk, and the kinetic energy is nothing but charge into the voltage difference. So from this, what do I get? Wavelength of de Broglie of alpha by the proton. H is a constant, 2 is a constant. These three are changing. Inversely proportional to root of mass. So mass of alpha below, mass of proton on the top. Charge of alpha below, charge of proton on the top. Voltage difference of alpha below, voltage difference of proton on the top, because they are all inversely related. So let's do this. Proton's mass is m, alpha will be 4m. Charge of proton E of alpha 2e. Voltage of proton 2v of alpha, it is v. Okay. So this will become 1 by 2. This will become 1 by root 2. This will become root 2, root 2, root 2 cancels. So this will become 1 by 2. So it's 1:2. So the wavelength ratio will be 1:2. Okay. Yes, the PDF will be available with the annotations. Don't worry about it. Cool. Let's go to the next concept of photoelectric equation. Photoelectric concept, which was done many times on this particular channel. Remember, when light falls of a particular wavelength or a particular frequency such that the energy of the photon is more than the minimum energy to suck out that electron on that metal, then electrons are ejected with some kinetic energy. There is a range of kinetic energies from 0 to maximum. The luckiest of the electrons have maximum energy, but most of the electrons have little bit less than the kinetic energy maximum value. Now, the minimum frequency required to start the photoelectric effect is called the threshold frequency, and the wavelength is called threshold wavelength. And that minimum energy is called as the work function phi. Work function phi. That work function will be hf naught, f naught being the threshold, or hc by lambda naught being the threshold wavelength, critical wavelength. This is maximum energy. This is the energy of the photon. So energy of the photon is work function plus k max over here. Okay. Now remember, energy of the photon can be written down as hc by lambda or hf. This is equal to work function, which can be written down as hf naught or hc by lambda naught, or you can write it as hf naught. And over here, kinetic energy maximum can be written down as half m v max square, or you can write it as electron charge into the stopping potential. Now, what is the stopping potential? These electrons which are ejected out, they have some speed. To stop them, you apply a voltage to decelerate them. So that voltage which is required to decelerate them completely is called as the stopping voltage. Now, interesting thing is, when you increase the intensity of the light, the number of photons will improve, but that will not change in any manner the stopping potential, nor will it change the work function, nor will it change the cutoff frequency or that any of these values. The only thing which it affects is the number of electrons, which will decide the photocurrent. So the current in the circuit is directly related to the intensity of the light, which is directly related to the number of photons or the number of electrons. Otherwise, intensity does not play any role. It can't change the cutoff. It can't start the photoelectric effect if by chance the energy of the photon is not sufficient to kickstart that photoelectric effect. Keep these things in mind. So this is the main photoelectric equation, and you will be most likely using this, all right, most of the times. Let's see some questions based on this. If two metals are exposed to radiation, then the work function are 4.8 and 2.2, then choose the correct option. Wow, this is not that difficult at all. I'm pretty sure you can crack this. Come on, my dear warriors. Yep. Oh, come on, think about it. Two metals are exposed to radiation of 350 nanometers. Now, 350 nanometers, let's find out the energy of that photon first. That is 1240 divided by lambda. This formula you can use instead of, see, usually what the formula is hc by lambda, right? But you know the value of hc. Let's say lambda is in nano and you want to convert it into electron volt. Then it is 1240 divided by lambda, provided this is in nanometers, and the final answer will be in electron volt. So just substitute that 1240 divided by 350. How much will it be? How much will it be? Approximately some 3 point something. Approximately it will be approximately 3 electron volt. It is not exact, but approximately 3 electron volt. So now look at these two values. Obviously you can see 4.8 electron volt is more than 3. So photoelectric effect will occur. But this guy 2.2 is less than 3. So no photoelectric effect will occur because the energy of the photon is lesser than the threshold. That's very, very important. So metal A will, what is it? Metal A and B. Okay. Metal B will not emit photoelectrons. Metal B will not emit photoelectrons. Yes, I hope this is absolutely clear. Yes, metal B will not emit photoelectrons. That is the correct one. Both will emit, that is wrong. Both will not emit, that is also wrong. Then there can be one more type of question which I have seen. Let me show that to you, which is very commonly asked. It will be like, for wavelength lambda of the photon, which is incident, the stopping potential is V. If the wavelength is, let's say, 2 lambda, if the wavelength is 2 lambda, then what is the stopping potential? Or let's say the stopping potential is given and they ask you the work function, things like that. They are very, very common. Let's say the stopping potential is now 2V. Chumma, I'm just giving some random things. And then they will ask you, what is the work function? Or what is basically the threshold wavelength? These kind of questions are very common. So what you do in such things, first situation you take, first situation, energy of the photon is hc by lambda, work function is phi plus E into V, plus E into V. Second time, second situation, what is it? hc by 2 lambda is work function plus the stopping potential, because the wavelength has increased, the frequency has reduced. Actually, let me do one thing. I've not chosen proper values. Let me choose proper values. That will be better. Let's say the stopping potential is 2V here. When this is 2 lambda, then it is V. Now it will be fine. Okay, so now let's get back. For wavelength lambda, stopping voltage is 2V. So energy of photon is hc by lambda, work function plus E into stopping voltage. Second situation, hc by 2 lambda, the work function is phi, stopping voltage is just V. This is the two equations that you will get. Once you get these two equations, what can you do? Just subtract them. Just subtract them. You will get a beautiful equation. hc by lambda minus hc by 2 lambda. Phi will cancel. So it will be 2 EV minus EV. So therefore, from this, what will you get? hc by 2 lambda is equal to just E into V. hc by lambda is just basically E into V. Use this over here. Use this right in this particular equation. So hc by 2 lambda is work function plus EV. EV is nothing but hc by 2 lambda. In this case, the manner in which I have chosen, the work function is just coming out to be 0. I mean, looks like invalid. Okay, but I had chosen some random values like I showed you. But if I chose proper values, obviously I'll get a good value of the work function. But otherwise, I hope this is clear how to solve these questions. Yeah. How is the last question answer A, isn't it D? Uh, if two metals A and B are exposed to radiation, okay, and the work functions of the metals A and B are 4.2 and 2.2, this is the work function. Oh, this is the work function. This is not the energy of the photon. I am so sorry, guys. Yeah, I'm so sorry. I'll just redo. So sorry. That is what happens when you teach for more than 7 hours, I believe. This was the work function. This was not, this was not the energy of the photon. My bad, my bad, my bad. So sorry. Now this 3 electron volt was the energy of the photon. Okay, the energy of the photon was 3. So if you see, the energy of the photon is more than the work function here, actually. So 3 electron volt is more than 2.2 electron volt, which is the work function. This is the energy of the photon. So photoelectric effect will occur in case of B, in case of B. But if you see A, this 3 electron volt is less than 4.8 electron volt. This is the energy of the photon. This is the work function. So it will not occur. So that is the case of A. So in A, it will not emit the photoelectrons. Yes, that should be the correct answer. Let's see. We didn't even check the answer, I think. Oh yeah, the answer was D actually. Yeah, you're right. It was D. Perfect. So very nice question. I mean, sometimes photons energy is given, sometimes work function is given. So you need to compare it properly or else you will get exactly opposite answer. So this is what happens. Silly mistakes. Yes, awesome. Thank you, Girish, for pointing it out. Just slipped through our mind. Okay. So guess I need a break now. Okay, we are almost nearing the end. The last concept is coming up. Okay, what do we have? What do we have? Gates. All the gates. 100% there is a question in your JEE mains. Logic gates, electronic devices, truth tables, logical operations, and or nor, NAND, not, XOR, all these things. So you should know the truth tables for everything. See, basic thing is if you have a OR gate, I think, is it there somewhere? It's not there. Anyways, see, when it is OR gate, which looks something like this, at least one of them should be true. 0, 0 will give you 0. 0, 1 will give you 0. Sorry, 1. 1, 0 will give you 1. 1, 1 will give you 1. So the operation for that is, the output will be A plus B. That is the OR gate. Any one is true, the output is true. Similarly, when you have a AND operation, the symbol for that is like this. Symbolically, you write dot A dot B. So 0, 0 will be 0. Both should be true, only then it is correct. So when both are true, then you will get 1. Similarly, you have the NOT gate, which is like this. So the output is written down as A bar, and if it is 0, the output is 1. If this is 1, this is going to be 0. This is the truth table for a NOT gate. Okay. When you have NOR operation, when you write this as NOR gate, NOR, then instead of 0, you will get 1. Here you will have 0, 0, and 0. That is when you put a dot over here. Similarly, when you put a NAND operation, you put a dot here. Then instead of 0, you'll get 1, 1, and instead of 1, you will get 0. And here, instead of A dot B, you will put A dot B bar. Instead of A plus B, you will put A plus B bar. Apart from this, there are two important theorems which you should know, also called as De Morgan's theorem. De Morgan's theorem, which will help you a lot. That is, A dot B bar is A bar plus B bar, and A plus B whole bar is A bar dot B bar. This is very, very useful. This is very, very useful. Is that clear? Okay, Manish, what to do? Yeah, all right. Yes, I know it is 6:30. All right, cool. Let's go. Let's go. Let's go. Do some questions. For the given logic gates, which is the correct truth table? Let's see if you guys can figure this out. What is it going to be? This is A. A is also going over here. This is B. B is also going here. This is A bar. This is B bar. This is A bar dot B. This is AND gate. This is A dot B bar. This is OR gate. So it will be A bar dot B plus A dot B bar. You know which operation is this? This is called as a XOR operation. XOR. Exclusive OR. Exclusive OR means exclusively they should be different. Means 0 and 0 will be 0. It's like OR gate. 1 and 1 will also be 0. Only when these are different, only then it will be 1. This happens only for XOR gate, exclusively OR. It is not exclusive here, it is not exclusive here, it is exclusive here. Both are different. Then it will give correct output. So which is the correct one over here? Yes, it is, I think, D option. 0 0 1 1 0 0 1 1 0, both are giving 1 1. Yes, it is option number D. Cool. Remember this as a theorem only. Exclusive OR is A bar dot B plus A dot B bar. That is exclusive OR gate. Yes. Awesome. Awesome. Okay, cool. Let's go. Let's go. Let's go. Okay, we are done with this. And please remember, those of you who want to join our JEE crash course for April attempt, it is still open. It is also going to be valid for JEE Advance. And if you just want the test series, that link is also there in the description box. I'll just show it to you. And where is it? Where is it? Where is my session? Yeah, there you go. Now, the best part about that test series is that, yeah, the best part about the test series is that it can give you access for not just mains but also advanced, and also you have the test series for all India entrance examinations like BITSAT, VIT, EEE, SRM, JEE, COMEDK, J Advance, EAP SAT, ISER, everything is there all in one test series, and this is available for 16667. Okay, and for your just JEE test series mains and advance only for April, as well as the mains in January attempt, as well as the advance, it's for 1333. Both the links are there in the description box. Okay, now I hope today you enjoyed this session. Also, you learned a lot from this session. I have covered major topics, major concepts from all the chapters as much as possible. There is one more interesting session which you might have seen last year, and that is something which I feel you should do. Just search for formula in the search bar. You can search formula Shreyas sir also. You will see either this session, or you can just search for formula physics Shreyas sir. Then PO, where is it? Yeah, see this complete formula revision. This is 11 months ago, 6.5 hour class. Again, your Shreyas sir is known for it. This has all the formulas, and the best part, you know about this session, it has the PDF also. Yes, it has the PDF also for all the formulas. In this PDF, it's not just for high weightage or important chapters. All the chapters are there, all the formulas are there. So you can revise through my notes right over here. Okay, so just search for this particular session. Keep in mind this particular thumbnail. Which is that thumbnail? It is this one. Okay, this 11 months ago, 6 hours 46 minutes. Check that out. Yeah, cool. So I'm pretty sure after this, there is no reason for you to complain. I mean, any person with even low score, or even with a person with no confidence after this session, I'm pretty sure your confidence level will be on the top. It should be top notch. Okay, just solve questions, Just do mock tests, just revise formulas, focus only on what you want, not what you should get based on others. Don't have to force yourself for 99. Don't force yourself for 95 or 90 percentile. If you think, no, sir, this time I think, I've not done enough preparation, I will focus 85 percentile. Next time I will get 99 percentile. Okay. But make sure you get that 85. It should not be like you are trying to get 99 and instead of 85, you get 60 percentile. That is what I mean. So please understand that you might think that, okay, this paper will be easy, that paper will be difficult. Nothing works in that examination hall. All these statistics, analysis, whatever you do, at the end of the day is more or less only for your preparation, not in the exam hall. In the exam hall, what matters is, are you able to crack that question? If you decide, I'm going to solve only 14 or 15 questions per subject, so totally I will solve 45 questions. That's okay, perfectly fine. Maybe 5 questions will go wrong. 40 into 4 will give you 160 marks. 5 questions have gone wrong, shows you will get 155 marks still. So just by solving 15 questions per subject, you can still get 155 marks, which is 96 percentile around. Understand that. 96, 97, yes, close enough to that percentile. So guys, it's all about strategy. It's all about believing in what your plan is. Your plan may not work for others. Others' plan may not be effective for you. So believe in your ideology and go through the entire rigorous process for the next 5 7 days or 10 days, depending on when your shift is. I'm pretty sure you will crack this particular examination. All right, this is just a stepping stone for most of you. I know next time in April attempt you will do even better, but don't think about it now. For now, this is what I have to do. January attempt is my last attempt. Think of it like that and try to push as much as possible, because today you do a small amount, then you have to work harder for the next attempt. Now you work hard, so you will have to cover up very little for the next attempt. Push yourself, let yourself free. I'm pretty sure you will do really, really well. Okay, so with this I shall take a leave. Make sure you like this video, share this video, subscribe to the channel, leave a comment after this video how you enjoyed this session. Okay, bye bye, take care, have a great time.